One, two, one, two. Testing one, two.
Yesterday, but otherwise we'll open the door so at least we can have some air. Thank you very much. Commence. Bonne aventure. Bonne aventure. We're gonna start now. It's okay. Comment? All good? Gilles, il t'a dit c'est bon pour connecter. Germaine, le audiovisuel, il t'a dit c'est bon pour connecter. Ok, cool. Cool. Germaine, just checking if it's all good if he plugs his computer later. Okay, cool. Thanks, man. Thanks. On commence. Test. Okay. Good morning. Good morning. Hello, everyone. Sawubona. Welcome. Welcome to South Africa for some of you. Welcome to AMLD Africa for some others. And welcome back to the few others. Welcome back because some of the faces are not here for the first time. A few people were here already in our previous edition in Nairobi, and it's a pleasure to see this continuity and the community being built and throughout borders. But welcome back also for our startups, for our communities, for our investors and attendees of our Day Zero. AMLD Africa launched or went into this space. Although our mission is to democratize AI in Africa, all in all, we all share the same mission, which is bringing growth into our continent. And this growth is brought by through research, but not only research. Research, accompanied with the right leadership to apply the correct research to write concrete projects, is also something that will bring growth to our ecosystem and something that AMLD as a platform would like to push. This is why yesterday we've had presentations of startups, presentation of investors, but also presentations of communities. We'd like to bring this growth, we'd like to break cliches, we'd like to break barriers. There is a lot of cliches that are born of this nerdy startup and this shark investor, and AMLD Africa wants to bridge this cliche to bring about more startups coming into the ecosystem and more bringing about growth on our continent. So I was told that there was a slight miscommunication about the agenda. So I will just share the website so that everything is clear. So we're here at WITS University. There are 3 rooms. The main stage, which is this one, is called WSS2. So WSS2, the morning now would be AI for Sustainability track. And in this room, we have the AI for Sustainable Agriculture and Water Management. The room 1, which is AI for WSS2, AI for Urban Management and Circular Economy, this one. Then WSS1, AI for Sustainable Agriculture and Water Management. And room 3, which is on the right-hand side, if you leave the room, would be AI for Energy Transition, Climate Adaptation, and Mining. So with that, I would like to welcome you guys one more time to AMLD Africa. This afternoon, we have the healthcare track. We have a lot of interesting discussions. We have a keynote from someone coming from all the way from Seattle, who is an ex-director at Microsoft. And we have the separation of 3 sub-tracks, which are genomic diversity and personalized medicine, public health surveillance and care delivery, and AI-driven diagnostics and digital health. One last time, thank you everyone for being here, and welcome to AMLD Africa 2026. I would like to give the mic to someone who we deeply appreciate at AMLD Africa, someone who was a great supporter of the initiative and someone that allowed us to host it at WITS University. Please, guys, give a warm, warm welcome to Time AI 100 nominee and Mind founder, Benjamin Rossman.
Good morning, everyone. Welcome to WITS University and welcome to AMLD. It's really a massive pleasure to be able to stand here and kind of greet you today and kind of welcome you to what I think is going to be a really amazing event, especially those of you who've traveled all the way from the distant corners of this planet or continent to be here. I also want to thank the organizers, and particularly Khalil and his team, who've been amazing, for all the hard work that they've put in, for choosing to drive this initiative and choosing to host it here at WITS. I want to thank all the speakers, I want to thank the funders, and really everybody who's here, all of you who are attending, who are contributing, who are being part of the discussion, because that's what's really important here, is that this isn't just a kind of setting where you sit there and absorb information from other people. This is about a dynamic. This is about contribution. This is about having a conversation. So it's really great to have you here on campus. WITS is an amazing and a vibrant university, and there's so much exciting work happening in the 5 different faculties across the campus, and hopefully you'll get to find out a bit about that while you're here. So it's fitting that an event like this brings so many different kinds of people together to discuss really what I think is a common underlying substrate of really every endeavor that we're pushing forward on across humanity at the moment, and that's AI. AI at WITS isn't new, and we've had a meaningful impact on the field for decades. Back in the 1950s, there was work done here on something called kriging. It was developed here, which later laid the foundations and became known as Gaussian processors. So they were invented here at WITS. Also, back in the 50s and 60s, we had Seymour Papert, who studied at WITS before he went on to do all sorts of other things, like co-directing, I think being the first co-director of the MIT AI lab, inventing the Logo programming language, eventually contributing to Lego Mindstorms. So all of that came from here as well. And there have been many other luminaries over the years that have kind of come from WITS and worked at WITS. These include people like Nando de Freitas, who's now the VP of AI at Microsoft, and Shakir Mohammed, who's a research director and one of the first people that were hired into Google DeepMind. Today, WITS is among the strongest universities in Africa, and I would say also the Southern Hemisphere in the space of AI. And this is very much built on the deep strength that we have in computer science and applied maths, or the School of Kazam, because it's magical. We offer a wide range of different kinds of degrees and courses with research level teaching and supervision in all sorts of areas ranging from robotics to data visualization and data science. We've now got something like over 400 postgraduate students that work in different aspects of AI here. And it's really become an exciting space. I think more important than any of these numbers is the culture that we've built in our school. We've got this open, collaborative environment that's just grounded in strong research labs like the Rail Lab, the Prime Lab, Explainable AI, most recently the Candle Lab. We've got all these interesting dynamics going on and just some amazing, wonderful people, and I hope you all get to interact with some of these people while you're here. I want to take a second and just zoom out a little bit into the broader African AI picture. In fact, in this very room, back in 2017, a group of us launched something called the Deep Learning Indaba. Now, at the time, this was a very similar kind of initiative. This was a kind of summer school. And when we did that, we thought if we wanted to be as inclusive as possible, we'd maybe find 30 people who would care to come and have a deep dive discussion about AI. And boy, were we wrong. It was enormous. And I think that and several other movements have catalyzed so much excitement across the continent. I mean, just with the Deep Learning Indaba, it's become a Pan-African movement that's now run in 47 African countries. And we've got all these other exciting movements going on as well. There's obviously AMLD, there's Data Science Africa, Data Science Nigeria. And in less than a decade, we've moved from a set of very small, isolated pockets of people just really starting to dabble in AI to what I think is the strongest, most vibrant community in the world, filled with amazing people that are really trying to build things that will change the world. This has been so inspiring to see, and it's just amazing to be here and be involved in part of this journey again with AMLD being in the same space. At WITS, we've recently taken the next step as well, and just over a year ago, we launched the MIND Institute, the Machine Intelligence and Neural Discovery Institute, which is a place that focuses on the fundamental science of not just artificial intelligence, but natural intelligence as well. We've set this up as a powerhouse for developing breakthroughs in AI and connecting it to real-world impact. At the moment, it includes 36 academics, but the idea is to keep growing this. As a community, more broadly, our feeling is that we have to ensure that Africa, and in fact everywhere in the world, is not just consuming technology, and specifically AI, that's built in particular places like Silicon Valley, but we're also contributing to its development. And this is something I want all of you to think about in terms of broader impact while you're engaging here today. So to all of you sitting in this room, I want to leave you with this thought. You are now part of this African AI story. And with that, great power comes great responsibility. My hope for this week is simple for you. Learn something that changes your work. Meet someone who becomes a long-term collaborator, and leave with a clearer sense of how we build AI that is excellent, responsible, and relevant. Welcome to WITS, and I wish you a fantastic AMLD.
Hello. Thank you, Benjamin, for this amazing opening. Also, thank you to WITS University to host this conference. Okay. During these last 4 months, I got the opportunity to curate the lineup of the AI for Sustainability track. And I try to think about some topic which is timely for Africa and also very important for the South African context. So we decided to go on 3 topics. The first one is on AI for energy transition, climate adaptation, and mining. The second one is on sustainable agriculture and water management. So the people which want to follow this talk can move to the first room, to versus 1. And the last subtrack is on AI for urban planning and circular economy, which will be in this room. So, I mean, without further ado, we're gonna start because we already got some delay. So I give you some time to go on the different room.
Est-ce que je commence à m'installer déjà ou
Yeah, je pense.
vu que je dois connecter l'ordinateur?
Ouais.
Juste pour confirmer, la pièce numéro 3, c'est
La pièce numéro 3,
c'est avec l'environnement et les mines.
Energy Transition Mining, yeah. Globalement, c'est 20 minutes, 15 minutes en talk et
Présentation,
c'est
ouais.
des
Can I
questions.
extend? Ouais, je vais extend.
Okay, good. Let me try continue.
Moi, timekeeper, mais timekeeper à partir de.
Ouais, quand je vais lui
Quand il
donner la
commence.
parole. Okay. So the first speaker of the subtrack is Mr. Gilles Hachime. He is a senior researcher at Microsoft AI Research Lab. And he works at the intersection of computer vision, remote sensing, and social impact, addressing challenges such as food security, climate change, and disaster response. He's also deeply engaged in the African AI ecosystem through initiatives like Zero Africa, AI for Innov, and Masakani Community. And today, he will present to us GeoVision Labeler, exploring how zero and few-shot learning can accelerate geospatial image understanding in data scarce context. So please help me welcome at the stage Gilles. Mr. Gilles.
Hello. Yeah, pretty happy to be here. First time in South Africa, first time in WITS. Here, I like the vibes here. Actually, I feel like I feel at home, and I also feel the sense of welcoming. And I'm seeing, I mean, the campus is very amazing here. Yeah, so amazed to be here. And thanks to the organizers who have brought all this together. Can I? Yeah. So today I'm going to talk about a topic hopefully interesting for you and for Africa in general. I think many of you, you often, you know, when you think about Africa, you think about different challenges, including food security, including disaster, and a lot of things, especially when it comes to climate and the environment. And to tackle these problems, one of the fields in AI that are really trying to bring some practical answers to these problems is geospatial machine learning, increasingly called GeoAI now. And the use of satellite data, especially satellite imagery, is becoming very, very ubiquitous, especially when it comes to these problems I mentioned earlier. There is a big challenge. I think my presentation is coming. There is a big challenge that we encounter when we want to use geospatial data, especially geospatial imagery, is that just imagine a picture of Africa, right? Africa is a huge continent. And just imagine that you want to understand how deforestation evolves in Africa. Is this working? I'm not sure. Okay. I will just move it myself. Yeah. So if you just imagine that you want to understand like how deforestation has evolved in Africa within the last 10 years, how do you do? So you take pictures of Africa through the 10 years, right? And you try to map, forests. You can also map other areas if you want to understand what is driving deforestation, like croplands and so on. And so you track that through the years. So you could track that through the years and then see the dynamics. Okay. First, where is deforestation happening, and what is driving deforestation? For instance, in many African countries, it's usually agriculture, but there are also other reasons I won't talk about here. The challenge of using satellite data comes with the fact that it covers vast areas, right? Like, we're not just talking about one city, right? Even just imagine, how big a city like Johannesburg is. Then now imagine South Africa, right? Now imagine East Africa, and now imagine the whole Africa. And sometimes we also want to track things globally. So how are you able to handle such amount of data? In many developed countries, you have a lot of, like, if you want to map, let's say land cover, for instance, you can ask people to label data. So they will look at the satellite data and say, okay, this is where cropland is, this is where cropland is not. Or maybe when there is a disaster, someone can draw on a picture on a satellite image where the damage is or not. Unfortunately, in Africa, we don't have enough label. I think that's a common knowledge now, and it's not. I mean, geospatial machine learning is not an exception. And then when there is, for instance, let's say a disaster happening, or I will come back to the land cover mapping example. You don't have enough labels through different countries to have reliable maps. So you have some global maps, right? You have the European Space Agency. Okay, you have a European Space Agency that has a few and so on. But it doesn't cover it doesn't represent world Africa. Actually, there have been studies that have shown that these land cover are not very accurate in Africa. So how do you go about it? And that's where a concept like zero-shot and few-shot learning can be helpful. So I will skip this. So there is something called visual search. That's literally like how can you find things on a satellite image without having pre-labels. And this is not something that it's not the norm right now. Like it's not something usual in the community. But when it comes to the case of Africa, it might be something that we need. And that's why we have created GeoVision Labeler, which is a zero-shot and few-shot learning framework that's supposed to, that's built to help automate as much as we can the labeling process, or help also discover information from satellite data. So this is a summary of a framework. You have, let's say, RGB. By the way, satellite data is not limited to red, green, blue bands. There are other spectral bands that we use. But here, we know that RGB is the most, let's say, simple format. So we leveraging RGB and vision language models that now have the understanding to be able to tell us, okay, this place has some buildings, this place doesn't. These buildings are damaged or not. And you can imagine different use cases. I've mentioned already land cover data. So you can you can also use this for damage assessment. You can also do scene captioning. So scene captioning can be interesting when you want to understand, for instance, what is on the ground, right? Maybe you have a huge imagery of a place, right? And you just want to ask questions directly. Okay, tell me how many buildings are here, or just describe, I don't know, what's the structure of the buildings here, and so on. Right now, you can test this tool. The latest version is not out yet. We have released the first version a few months ago. A new version is coming, but you can test that within one line of code. And we are also building a UI that will come and help even non-specialists. You have maybe an imagery, and then you can upload it and generate classification for like patch level classification or caption and so on. We have tested this. I won't spend too much time on this. We have tested this on different benchmarks. So what we've seen is that it can work, reasonably well. It doesn't always match the performance of fine-tuned model. But if you just imagine that you have no or zero label, you just go from a model like GPT-4 Vision, and you are able to have literally a level of performance that's close to a supervised model. So we have two different approaches here that you can see on this table. So the zero shot, like when you say GVL one step, is when you just take the image and you directly ask a vision language model to generate the classification. You can also have a two-step approach, which is you ask the vision model to describe the image, and then you use the description to make the classification. What we've seen is that actually, with a single step, strong models like GPT-4 Vision performs already quite well. But if you want to get the most of it, you have to use few-shot learning. That's, you show a few examples to the model. And the reason is that similar classes tend to be, I would say confused by the models. So let's say you want to classify a residential area into dense, medium, or sparse residential. You can see on the left the confusion matrix. You see there is a lot of confusion between sparse and medium, right? Because what do you call sparse? What do you call medium, right? What maybe you consider sparse, another one can consider it medium. So to be able to disambiguate similar classes, what we do is that we give a few examples. And then when you look on your right, you can see that you are able to correct not everything, but you can correct some of the confusion that's happening. That's exactly the reason why the few-shot learning here is getting us almost as close to a supervised model. I will skip this. And this is still around few shot learning. Like you can go from pretty relatively low accuracy to higher ones. Something that we have also explored is, let's say in a case you may not be interested into a lot of subtle details. Let's say you may not be interested into knowing if it's sparse or medium residential. You may be just interested in residential versus non-residential. So let's say you have a list of let's say classes. You may have 45, okay, and some of them are very similar. What do? You are not necessarily interested in those subtle differences. So maybe sometimes you want to cluster some of the similar classes. And so something we are trying now is to automate that process of, okay, we give a list of classes to an LLM, and we tell it, please merge these classes hierarchically. So you can decide the level of depth that you want. You can decide, okay, I want a hierarchy. It's like building a tree, right? So at the bottom you have all the classes, and then hierarchically you can merge them progressively. So yeah, I'll go to one of the main applications I talk about here. It's using zero-shot learning for emergency cases, especially disaster response. So I think I have already justified a little bit why this is important. So just imagine a disaster happened, okay? Actually, 2 years and a few months ago, there had been a disaster in Morocco, actually an earthquake, right? I could remember we were just leaving the deep learning in Daba, that was happening in Ghana, and we just got bad news. So it was a Sunday. So our team, usually we get some requests from humanitarian organizations or governmental organizations. And so when you get, and many disasters happen during weekends. You can't imagine the numbers. And we can't wait Monday to say, oh, we're gonna wait Monday to help an organization. No, because people are on the ground. So we, like in the airplane, my thoughts were completely okay. Already, how do I go straight to the data, use this pipeline and so on? I was already thinking about it. So when I got back home, I just grabbed my laptop and start working on it. And something that I have to do is label a few areas myself, because again, we don't have right now very strong foundational model right now that could generalize easily to different images. And really, satellite images are very difficult to work with, especially because anything can change. Like the distribution of your data can change just from one day to another, or depending on the provider. So I have to label places, and it's not an easy task, right? And so right now, what I want to do is to be able to just give some imagery to my tool, GeoVision Labeler, and tell it, please, just help me identify places where you see damaged buildings, okay? Because what happened is that during that disaster, Moroccan disaster, many places that are completely damaged are not necessarily easy to detect. So people live in mountainous places where they are not supposed to live, right? You even wonder, are they known by official authorities? Because you look at the imagery and you have a few houses very isolated for any other, and sometimes they are completely damaged. And so you even wonder, is there someone surviving there? And if yes, does someone know that they have to get there quickly? So we tried to do the burst. And exactly, this is something we want to solve with GeoVision Labeler. Like, can we identify these isolated places quickly? And so you can imagine a big place that's patched like this. So here, I'm taking an example of another disaster that happened in California. it's a wildfire. And what we did here is that we split these big patch into small patches, and we classify each of them into no damage, partial damage, and full damage. And what we do, because we are all generally interested into knowing the damage level at the building level, so we match this with building footprint, and then we come with what we call a damage map. So on your right here is the output coming from that process. Okay, and on this is your left, and this is your right. So on this side, you have the result of a fine-tuned model, which is the typical process where we go through labeling. And then here I'm comparing both. So if I'm using the fine-tuned version as a ground truth, and what you can see is that we can get very high level of similarity, which means that let's say the GeoVision pipeline can automatically actually get results that are very close to whatever we would get with a fine-tuned, a supervised model. Yeah. So I will skip. I know time is. We are out of time actually. So I wanted to talk about a few limitations. Of course, this is not perfect, right? There are a few limitations. Of course, we have to run this. A lot of API requests. There are a few constraints in terms of throughputs and so on. And there might also be cost constraints and so on. So yeah, I will skip this. Maybe through your questions, I can come back to it. And yeah, we are also working on a next step. The next step of this is that let's say you have a damage map, but usually we send this to our partners that may not be technical. They might be ministers. And they may have questions. Questions like, after a wildfire, maybe the minister can ask, which are the roads that are blocked, right? You may have a damage map, but it is not in itself useful if you can't overlay that with other type of data. But what if you don't have GIS knowledge? And so that's what we're trying to solve with a queryable Earth that will be coming very soon. So yeah, thank you very much, and yeah, happy to answer your questions if you have any.
Thank you so much. Does anyone have any question? There you go.
Okay, thank you so much for the really insightful presentation. My question is around disaster response. I mean, for instance, if there is a wildfire currently going on and the government wants to understand where to deploy resources and how to communicate this. So how useful is this? Because you talked about, in the image you show between the zero shots and ground truths, there are some places that are not identified, but now we're talking about human lives. What do these errors mean and what's their impact?
Yeah. Thank you very much. So something I think I didn't have enough time to emphasize on is that this is not supposed to replace necessarily, at least for now, the traditional pipeline. It's supposed to accelerate labeling. So the places where you may have, okay, by the way, what I've seen here is that the GeoVision pipeline has way more false positives than, let's say, the traditional one. So it will over-predict damage, generally. It will generally over-predict damage, which is good because the false negatives, like saying that this is not damage, but in reality it's damage, is the cost is higher than the inverse, right? So right now, we're mitigating that by having higher false positives. But of course, where the places where it's challenging is the frontiers or borders between non-damage and damage, or depending on the structure of a disaster. Some of the disasters are very clustered. Like you can see wildfire here, and in another place it hasn't touched it. But in other cases, you can have many houses that are not affected, and all around you have other houses that are affected. So these disasters are the most difficult ones for such pipelines. And the goal is that if you can generate weak labels with GeoVision, you can start from there and correct a few labels yourself, and then fine-tune a model if you want to have a better generalization. So yeah, it's not replacing completely the traditional pipeline.
Thank you. Does anyone have any other question?
Thank you very much. Nice presentation. I have two questions. The first one will be on the data and the labeling strategy. So on the data part, how do you prevent semantic drift between similar class labels? I mean, do you offer like prompt engineering, and like do you maybe like classify and clearly define maybe your descriptions on that, because that may cause like a drift between images and on. And the second one will be on the evaluation and the reliability of probably your models and your results. So on that, how do you now validate the results when the ground truth of the images is scarce? Thank you.
Yeah, thank you very much. So starting with how to deal with similar classes that may be confused. So I think I mentioned that we're doing two things. Okay, the first thing, and maybe the most obvious one, is few-shot learning. I think if your system can see the subtle differences, then it can predict better, and we have shown it. And another possibility is that the end user might not be interested in classes that are too similar, especially if you have a long list of classes. So that's where we propose in the approach to semantically merge similar classes, and you only do the classification at the cluster level, right? So then you get more reliable classifications. Yeah, so it depends on your use case and what you value or not. Yeah, and also cost, because if you're doing few-shot learning, the number of tokens you're using are way more, right? It's more expensive for you. So it depends. If you have enough budget, you can just brute force it by using few-shot and add more label in context. Yeah, and this is again, you can also, I mean, if you're using an open model, you can also decide, depending on time constraints, to fine-tune. But again, what I'm doing here is to minimize the requirements to fine-tune any model. Yeah. Okay.
Thank you for the different question. But I have one last question for you. Yeah. And what role multispectral or hyperspectral imaging can play in your tools, and can they help to enhance the disaster response?
Yeah, I mean, there are streams of literature looking at how to incorporate more spectral data even into the large visual language models. I think it's going to be application based, right? I would say things around, like anything you can clearly see could be, RGB can be enough, right? But it also depends on the resolution of your data, right? If you have very high resolution data, actually you have less the need of adding other bands. But if you have a lower resolution data, then you may need more spectral bands. So yeah, I'm not exploring that stream of work, but I know people are working on it. Yeah.
Okay. Thank you for this great presentation. Please help. Please a round of applause for him. Now we're gonna invite our next speaker. His name is Jean-Claude Baraka Muyaka, an urban resilience researcher and practitioner working at EPFL. He did his PhD at University of Pretoria. He's from RDC, but I think that He's more from South Africa than LDC now. So his work sits at the intersection of data science, climate risk, and public policy, with a strong focus on the global south. And his research explores how climate risk information can be transformed into actionable decisions through digital tools and governance area design. So his presentation of today will be about how ML-driven digital twin of watershed can support early warning, mobility planning, and climate adaptation systems. So help us welcome on the stage Mr. Jean-Claude. So Mr. Jean-Claude, we are waiting for you. Is that this one? He sent you the presentation. Yeah, the new one. Yeah, this is it. Yeah, where is the button?
Allô. Good morning, everyone. Sorry about that. Actually, I was on the other room. They're discussing some interesting stuff. I felt like it was more in line with my presentation today. The gentleman was talking about producing 100,000 weather stations. So I was quite interested. So before I start, I'd like first to say thank you to the organizer, Khalil, and your team for the wonderful work. I was here the whole day. I absorbed everything that happened, and today to see the way things are evolving, we are very happy to see that. So I am presenting a project that we are currently doing at EPFL, and not only EPFL, but we also have UMCSP that is involved with the project. The project is based in Kinshasa. So we have a local partner, which is the Red Cross DRC. Very interesting community. They have about 70,000 volunteers inside Kinshasa. So, also just to acknowledge my supervisor or my director, Jerome Chanel, who is not here with us, but he will have loved to be here. So that's a little bit of the plan of my presentation. So I'm sure we all know a bit about the DRC. The DRC has been in the news for some couple of time, and if you don't know about the country, I'm sure you might have met a Congolese somewhere. So there's many Congolese around in South Africa, so it's quite clear. So the capital of the country is called Kinshasa. Kinshasa is one of the cities that is currently facing a lot of challenges. Among them is the issue related to flooding. Kinshasa, just to give you a background of the city, it has been, when the city was created, it was created for about 500,000 people. That was, I can't tell you how many years back, but at the moment the city has about 17 million, and the city is growing. The reason why the city is growing in such a rate, there is a lot of reasons, and one of them is related to the insecurity on the east, but other reason obviously is related to the lack of infrastructure. If you just live about 50K away from the town, there is no infrastructure, so people rather stay close. So apart from that, recently has been a lot of rain, and obviously with the lack of infrastructure, you imagine that can be quite problematic. So this is a little bit of, if you have to zoom in on the city itself, if you see the blue area is the Njili Basin. Njili is one of the municipalities in the city. It's also one of the most populated municipalities. So the municipality itself is really just by the big Njili Basin. So we went to the ground. Obviously, this could have been done also on our desk. So we did a little bit of modeling of that basin, because that's also the area where there's a lot of flooding happening. So there is a particular 2 communities that we saw. One is Maziba, one is Dingidingi. They have been facing a serious issue with the flooding. If you see on this picture in Maziba, about 50% of that particular area is flooded all the time. And on Dingidingi, it represents about 33%. And when the flooding happens, most cases people are not aware of it, and obviously it causes a lot of infrastructure damages, causes a lot of death, and obviously you can imagine the authorities, they don't have enough resources to deploy them sufficiently or on time to help the community in those particular areas. So it's a big challenge. So what we saw, I think I should have started from here. So we collaborated with the Red Cross, and we organized a focus group discussion where we integrated stakeholders, among them obviously government actors and others, and obviously civil societies. And we discovered that we could segment the issue into 3. One of them, the infrastructure, public health, and ecology. Obviously, the country is failing in all 3, but we picked up that the infrastructure challenges is really the parts that the city has really been facing, really been struggling from the most. And we also, I think I might have messed up a little bit those slides. We also look into the governance structure as well, because we have done similar research in Kenya and in Zimbabwe. One thing that we picked up in those 2 countries is that the government structure play a key role on how government reacts when there is a disaster. And in Kinshasa, obviously, you have the metal set, which basically represent the meteorological agency in the country. Then you have the Ministry of Interior, the protection, civil protection. Then they are the one that should somehow play a key role on coordinating with all the key relevant ministries to deploy resources to the ground. Then obviously you also have the national, you have the provincial, and then you have the local, which also include the Red Cross and communities. So how do you coordinate all of this? It's a challenge. So that we saw, that was also one of the key parts that we had to look into. So then from this, we said we should look to deploy a tool that will basically support decision making and also will help decision makers basically to predict this event. So that's basically where the idea of developing a digital twin came about. And that's basically what we have been actually doing. So our digital twin, our idea is basically to predict, to visualize, and to anticipate floods in a data scale environment. That's also something that Ash need to mention. To get access to data, it's an issue. I was very interested by the gentleman on the other room was talking about they're going to deploy 100,000 weather stations. I really need to go back to him and find out when would that be deployed, because you don't have access to it. You go to the meteorological agency in the country, they will tell you that the whole city of 17 million, we have about 2 weather stations, which is hard to understand because the weather station may cover about 30K or slightly more. So if you have a city that covers about 70 or maybe about 100K or so, so clearly the data that comes out of what they are producing is not accurate at all for a system as we want to deploy. So for us, what we have done, we have basically produced, or we have bought and deployed our own weather station that we're going to make use of. So digital twin itself, I was in America and I was told there's several definitions of it. So in the African context, we'll have to deploy a digital twin that is really related to our context as well. So the idea is really to model the current system and see how do we optimize our ability to help the community. So that basically, our system basically, it will be about injecting data, integrating them, and also developing a flood modeling scenario and trying to visualize them. So on the conceptual process itself, so we have the data that we are looking for, the rainfall, that obviously you can acquire the open source data. For us, we are doing both. We're acquiring open source data. We are also deploying our own sensors. Other sensor that we need is a water level sensor. I'm not sure if here in South Africa you do have access to such. It's very critical because obviously in the Njili basin is just next to a 800 elevation, so obviously the water comes from somewhere. The idea is to basically be able to see the water level from the top, from the middle, and also in a valley. So it gives at least sufficient time to prepare. So then we have the territorial analysis that we have to do, and then there's also the identification of the vulnerable area, and the digital twin will come basically after. So there is a way of this alternative way that we discovered in our project in Malawi that is being deployed actually, and it's been quite successfully deployed, where people, they use their locally modeled water level system. So that's something that we also are going to make use of. So in terms of the data input, this is a list of such. Then I just need to go very fast. I still have some couple slides to catch. Then there is also some risk modeling that we already actually deployed, and we have considered a couple models that we felt that could be useful, but XG Post came out as perhaps the best one for the context that we are working on. And there is some couple also XG model feature importance, and the key parts that came out is the topographical drainage. And I just want to emphasize on that. The drainage system is critical for flooding. So obviously, if the system is not properly in place, you can imagine there will not be a water flow, and it could cause a tremendous problem. And in a Kinshasa context, the drainage system are full with polluted with plastics. So obviously, that's one problem. The other one, they are inexistent. The other one, they are broken. So for us, we have deployed drone images, and we are also using obviously satellite images to basically be able to detect them. Currently, there are only about 20% of drainage system that is functional. When I say functional, I'm just saying barely functional in the Kinshasa context. So clearly, there's a lot of issue there. So these some of the phases that we have used to build our model. And this is, so ideally, what we want, we want to build a platform which will be a website that will be used by the national authorities, but there will also be an application that will be deployed, that everybody will have access to it. And that was one of the questions I was asked also in America, is to see how many people have access to smartphone. So obviously there is an alternative route where obviously local communities like our partner, the Red Cross, can basically deploy their volunteer to inform people on time about what is going on. So I just want to play, this is the I'm not sure if I'm able to play this quickly. This is the version of the platform that we put, but I'm not sure. Yes, am I not? Can I play this? I want to. This platform, this should play normally. Yes. But it's not sound like just playing. You should see. So it's okay. So basically, this is a real-time system whereby there's a data that is integrated every 4 hours, and you should see basically. So what we did, we categorized the risk into 3. So you have the high, level, medium, and low. So every 3 hours, there's updated data that comes in. So you should basically see this, the risk moving within the base map that we have. So this is just a base idea of what we want to build, but the website will look a little bit more like this, but it's still, there's no layers attached to it. Ideally, we want to add layers into it, so the authorities will have access to the website, and what we have in mind is the application, the people will have access, not really the detailed one, but at least to know that in your area there will be an issue, just be careful, and we're also giving them alternative of where they could go. So in conclusion, so the tool itself, at the moment we have integrated the real-time data into it, so the next phase will be basically trying to develop a 3D system. And then, obviously, we also to say we are open to collaboration into it. Obviously, what the team in Metos, they are already doing with the 100,000 weather station, it will be very interesting to see with them how we can collaborate on such. So thank you very much, and I'm open to your questions.
Thank you so much. Thank you, Jean-Claude. Does anyone have a question? I'll start with you.
Okay, thank you so much for your presentation. My question is going to be in terms of communication. So the platform is like really wonderful, but it seems to be inaccessible to those people that actually need it. So you mentioned having to rely on Red Cross volunteers. Are they currently the only communication pipeline, or are you also looking at other avenues? Then my second question is in terms of resource deployment. So I don't know how or what measures are currently in place to either evacuate or how that is coordinated. So I'm trying to tie, how do you tie the platform to resource deployment? Because now we just talked about where these risk factors are, but how does it provide recommendations to guide either resource deployments or evacuations?
Yes, so I think those are two important questions. So at the moment, the Red Cross, because they are volunteers, they are basically local. So it's easier for them to get information from the head office or whatever who will have access to information and to share this information with them. So that is basically what is happening actually. So, and then obviously there is a difference between disaster response and preparedness. For us, we want to focus more on the preparedness part. Our tool is basically, the idea is to give authorities sufficient time. The model that we are deploying will give them a couple days. So that's why weather stations are critical. I think the gentleman spent about 15 minutes talking about that and that and that, because the more you have, the more you're able to have accurate data, and obviously we can be able to know few days in advance that based on the water level, the rain data that we have, and based on the model that we trained, we will have water that is going to overflow, and these are the areas that are going to be affected. So we are able to, either via the application sending the SMSs, or via the local channel, the community that are involved, tell people that, yes, you need to evacuate. There is an anthropological issue, and I've spoken to a colleague of mine from Ghana, who is also part of our team, who said that in Ghana they had a similar issue where the government even built new houses to people, but nobody wanted to go, because obviously you change your environment, you don't know what is out there. So that is the next phase of our tool, is to basically integrate the supply chain aspect into it. Then the person not only knows that he needs to leave, but he also knows where to go, which hospital to go, and that's also the part that basically we are actually currently looking for funding for that. So that's also something that we want to integrate in our tool.
Perfect, thank you. Any other questions?
Thank you for the presentation. It's quite an interesting study. I want to know about the sensors. You spoke of the water level sensors. How many sensors do you need for you to say that this gives like a good representation that there's going to be a flood in the area?
Actually, that's a very good question. So we are working on a very small scale. So the scale that we are working on, ideally, it's always good to put 3, one on top, one in the middle, one down, and also what is the range of that sensor, that is another question. But the biggest issue here is how do you integrate that, and how do you sustainably integrate that sensor data into your model? That is the big issue, because obviously you have internet access. In Africa, we have 38% of areas that access to internet, so sometimes you do need access to that, or you need somebody to go regularly to collect this data. So that is another issue that we are kind of facing. Maybe that's why we're looking at alternatives that we have seen in our project in Malawi, where basically they had the water level sensors, and after certain amount of time, it wasn't working because of the maintenance and many other issues that come with. So they decided to deploy such system where every morning, unfortunately, somebody must go in the morning and collect the data, in the evening collect the data, the millimeters, it works. If it works for them, if it works for the community, it's also good to empower the community, to give them something to do, to also feel part of it. So that is something that we are looking at, and one water level data sensor, it costs about 2,000 Swiss francs. So how sustainable it is, if you want to deploy it in a scale of a city of 17 million, I'm not sure. So it's worth to look into other alternatives so that it can work for everyone.
Okay, thank you for that. It's actually an add-on on her question, because I wanted to actually know in terms of how do you deal with limited or unreliable sensor data in many watersheds. I mean, do you now, like with your machine learning models, you infer missing data? Because I heard you mentioning something about satellite and using drones as well. And my second question will be like the role of digital twins and what role does digital twins like play in terms of mobility planning and also with extreme events like floods and whatsoever. So the last one will be, can this approach actually work in terms of urban planning and infrastructure development as much as like, you know, every now and then you'll be like urban expansions and also all that. So thank you.
Yes, actually, start with the last question, which I think it's covered the previous two. Yes, that's the idea. We're working with the Ministry of Infrastructure. They need such data because if with the satellite imageries, with the drone that they actually provided to us, we are able to see which drainage system that is inexistent. So for them, it allows them to plan properly. And on the next phase of our project where we want to look at shelters, how the people are sent to those shelters, that also integrates the mobility aspect where you have to look at the road, are the road accessible, and what are the issues to get to those shelters. So obviously for the planners, that's opened the way for them to know where to deploy their resources more efficiently. So clearly, the digital twin that we're trying, the 3D, just to call it the 3D system that we're trying to put together, is really for the planners to be able to accurately deploy the already limited resources. They need to just specify that. So the resources are already limited, so you really want to maximize them where really it matters.
Perfect. Please, a big round of applause for Jean-Claude. Thank you. By the way, guys, room 3 is ready. So if anyone is interested in listening to AI for energy transition, climate adaptation and mining, feel free to go there. And by the way, we still have another speaker here. So I will let Aurel introduce the new speaker. Thank you, guys.
Thank you, Baraka, for the presentation. The next speaker will be online. Okay. He is a developer at Zone 1 Kisumu, and he is passionate about building practical, community-centered technology and has developed several applications focused on everyday empowerment. In this talk, he will present FloodWatch Africa, an AI-powered early warning system designed to support community-level flood prevention and preparedness. So, Braven, can you hear us?
Yes, I can hear you.
Okay, great. So you have the floor.
Okay, so how do I share the slides? I don't have the option to share. So could you please put up my slides?
Okay, sure, we're checking, just a second.
The share option is, I can't click it, it's disabled.
You can share your own presentation. Have you accessed the button which can allow you to share it?
No, it is disabled on my
Okay.
side, I can't present.
presentation is on
Can you try now?
Can you try it?
Can you see the screen?
Yeah, we can see your screen.
Okay, so I just started.
Okay, you can start. Put your slide in presentation mode and start your presentation.
Okay, so hello everyone. My name is Bravia Nyatoro. I'm a software developer from Kisumu, Kenya, and I'm here to present a project that I've been trying to work on called Floodwatch Africa. So in developed countries, there is usually a system whereby it's called wireless emergency alerts that notifies everybody in case there's a national emergency. So this system does not depend on like SIM cards or anything like that. It's something that everybody sees regardless of whether their phone is currently on silent mode. And almost everyone so long as you have a phone in that area, so long as you're in that geological area where the alert is sent, you receive it. Now, in Kenya, floods is a real problem, but the warning systems that you usually have is usually from the Kenyan Meteorology Department, and most of the time we see their warnings is usually on Twitter or X, or sometimes they talk on the news, but this is not very reliable because how many people are on Twitter? Like, people in the very remote villages where floods actually are are not that much on Twitter, and most of them don't even have smartphones. So we have Red Cross that usually sends the alerts. I am from Ahero, which is an area that has the River Nyando passing through it, and we usually experience floods. Like, it's a common thing. Luckily for me, I am savvy enough to be online and see the warnings that Kenya Met Department gives, and tell my people at home that they should probably take precaution. Red Cross does send alerts sometimes, but it's not something you can really rely on. They send one year, the next year they don't send. So that's in Kenya last year. No, in 2024, around 306,000 people were affected across the whole country. Very many people, like 293,000 were displaced. So most of the area where floods affect in Kenya is the western Kenya. So it's mostly the areas around rivers, but there's also flash floods in Kenya. So around 315 lives were lost in 2024 from floods in Kenya. So you can see it's a big problem in the country. So, so what is the solution that Floodwatch Africa is supposed to give? So when I first pitched this project to AMLD, my first thought was about what I had started researching on was using satellite data myself. Like I take the satellite data because they are free and open source, and create a model, AI model around it to like go through it. But then during my research, I found out that there is Google released a model called WeatherNext. So this WeatherNext has specific, that is the commercial name, but within WeatherNext, there's like GraphCast and the other one, okay, I don't know the name, but GraphCast is the one that we are interested in. So GraphCast is an AI model from Google that looks at that satellite data for you. Like they already did that. So it takes the satellite data and can predict, like it is different from the traditional predictions because it gives you like percentages, like probability of it happening, and like it also gives you like a 7-day window. Traditional weather forecasting, usually most of them are limited to 5 days, and they are very expensive to run because it's a lot of manual, like how do you call it? Like manual machine learning. But this one from Google, already Google does it for you. So the solution was just the Google Cloud Forecasting API. Google Cloud Forecasting API already has that taken care of. So the only issue with why this project isn't actual yet is because for you to access the Google flood forecasting API, you have to be in a waiting list. You give them a reason why you need the API. And luckily, just a week ago, I got an email that I have gotten the access, so I can actually start building the idea. So, yeah. So FloodWatch Africa is actually a very simple thing. Like, so the data exists, but this data doesn't actually reach the people who need it. So if we can take whatever Google provides from the API, and they claim like it's very accurate. So from 7 days, it gives you a forecast. Then with time, like from day 7, is it day 1 or day 7? From day 7, it gives you a forecast. Then with the time, it increases. It tells you how accurate that forecast was. So like on day 7, it tells you there's a probability, there's like a 70% probability that there will be floods in the area. So probably take caution. Then on day 3, it tells you, okay, it has increased. It is now like 90%. Then on 24 hours before the actual floods, it again tells you another thing. So you can like plan for it. So FloodWatch Africa is supposed to provide a missing link between the data from Google, from the AI models that they already provide, and actually make it reach people. So FloodWatch Africa will take that data, then convert it into into something that people can receive. Then we use another AI to translate them to English and Luo for people in Ahero, and English and Luo for people in Budalangi, because most people in Ahero probably speak Luo, and most people in Budalangi probably are Luyas. So yeah, basically it's a very simple idea. So we are delivering these messages to people using SMS because most people have like, it's called feature phones. In Kenya, Kabambe. So most people have these small feature phones, and everybody has a phone right now in Kenya. It's either, but the number of people who actually have a smartphone are very minimal. So using feature phones, it will be able to reach the whole, like it covers the whole country. Not really the whole country, but the areas that we specifically want to target. So we are starting with a hero. Once I get the project built, and then we'll try to move to Budalang. Yeah, so this is, hello, can you still hear me?
Yes.
Okay. So the idea is simple. We take the data, we translate it, and then we deliver using, there is Africa's Talking API, which allows sending SMS very cheaply. Though in the future, we probably, with help from, okay, sharing. Okay, yes, you seem to be sending me messages, something I'm still presenting. It's confusing. Okay, so we take the data, then we translate it into local languages and we send via SMS. So it's via SMS for now because actually using the wireless emergency alert system from developed countries requires like you need telco support. Like from in Kenya, we have Safaricom. Safaricom has to support you for you to transmit through their cell towers. So this doesn't really use SIM cards, or it just bypasses and sends to any. Most phones usually have an emergency alert receiver system. So if once it takes it in, it can show it. So for now, we can start with SMS for a proof of concept. Then once we have get it, we have proven it, we can convert maybe with support from the government or something. So yeah, we can start with Ahero and Budalangi, which Ahero is my local area, and it will be easy for me to collect, like I could go and collect like mobile phone for numbers for people who are willing to participate in the experiment. Then if it works in Ahero and Budalangi, we can, it's something that can be translated to fit like the rest of the country. Then once this system is built, you know, for most people, floods doesn't really just kill people, because imagine, okay, so for most people, floods wipes out their livelihood, like it kills their cows and. Hello?
Yeah, we can hear you.
No, I thought you were talking to me.
No.
Okay, so what was I saying? In like for people who are affected by floods, floods usually takes out their homes and kills their livestock. And then there's a common phrase in Kenya. If you've been watching the Kenyan news, there's a common phrase called "serikali saidia," which basically translates to the government help us, like something like that. So people usually cry for the government to help them, but I guess it's something still in the works for the government. But this is something we can actually do using, like, I thought it was perfect for this because it's basically using an AI system that is already there and actually making it help people who actually need the system. Yeah, so if we could get like the partnerships from government and NGOs, this could be something that could transform into a wireless emergency alert system. So the weathercast model from Gemini, from Google, is very wide and can support more like extreme weather. So it could be something that can be expanded later. But for now, we are focusing on floods. So yeah, we already have the data and people have the phones. It's just that the data that could help them should reach them. Yeah, so basically that is FloodWatch Africa. in case of any questions.
Thank you so much for the talk. Does any one of you have any question? Yes.
I did have one question. So, do you ever plan on making this for any disaster, so not just floods?
Yes, from my last statement, it was, I said we are starting in floods because we need a proof of concept, but once it works well, we can, the WeatherNext model provides a lot more weather. It looks at more extreme weather that we can make it for. It doesn't necessarily have to be floods only. It can be expanded. Yes.
Thank you. Any other question? Yeah.
Okay, so I meant to ask, so not just weather related, what if it's like other natural disasters like earthquakes or something like that? Is there, do you plan on incorporating something or a feature like that? Because even with earthquakes, I mean, there's a lot of, there's a lot that can happen. So if for example, buildings collapse and stuff, there's a lot of people that also go missing there. So is it also, do you also plan on incorporating warnings and things like that for other natural disasters, or is it just mainly focused on weather?
Okay, so for me, the problem that that I have faced, so like earthquakes is not something that really is not a big problem from where I am from. I don't think it's a big problem in Africa. I'm not sure, but in Kenya it's not a big problem.
Hi.
So
I think is it. Hi, how are you?
Hi.
I want to know, how do you offset the fact that the data centers right now are being powered by coal and gas? They're like contributing to.
Hi. Yeah. Yeah, you can continue. Sorry about that.
How's that offset? Like, as far as sustainability is concerned.
Hello.
Yes, we can hear you.
Asking a question.
No. It was just a technical difficulty. You can continue. Sorry.
In terms of
Okay, so as I was saying, like earthquakes is not a big problem from where I'm from. So I don't know, maybe it can support that, but for other natural disasters, I don't know if, maybe I'd have to look at that, but it's not something I've thought of for now. I just thought of extreme weather because that was the original idea, but sure, I think there is other, like you can create a model around other natural disasters. But for buildings collapsing, I'm not sure about that. I don't know if you can train an AI to predict that. Yeah, but for weather, it's easy. There's data for weather.
I do think there are ways.
Okay, I think that, thank you, Bravian, for your talk. We're gonna now move to the next presentation. Mrs. Nadine? Mrs. Nadine? Sorry for that. Okay. So our next speaker is Nadine van der Waal, Head of Technical Development at Risk Escape and Fellow of the Institute and Faculty of Actuaries. Her work combines actuarial science, climate modeling, geospatial analytics, and finance, focusing on high-resolution physical climate risk assessment. She is also a co-developer of the Actuarial Society of South Africa, Climate Index, a major industry initiative. She will discuss today on how AI enables high-resolution physical climate risk modeling with direct implication for infrastructure, insurance, and financial decision-making. You have it.
Good Morning, everyone. Thanks for having me. Yeah, so just before I begin, I just want to talk to you a little bit about what we do at RiskScape, just to set the context and why we do what we do, just to tell you a little bit more about ourselves. So we are a spatial actuarial firm working with data and technologies. We sell products to insurers and banks to help them manage their risk, but we look at risk through a spatial lens. So we assess essentially assets of the insurers and the banks of their clients. We assess the assets in the sort of environment that they're in. So we develop bespoke technologies to do that. We work from the ground up, and by that I mean we look at literally DTMs, satellite imagery. We do addressing. Two of our directors, they were the founders of TomTom Africa. So we have a handle on every asset, every house, every residential building in the country. We know its address, we know its boundaries, and then we have other information such as building footprints, building sizes. And one can do a lot with that. If you combine it with things like climate data, you can really get a good handle, a property level handle in high resolution of the risk of properties with powerful data like that. So despite the really interesting things that we do, we're actually quite a small team, about 30 people, but a very diverse team. We're actuaries, GIS professionalists, spatial professionals, statisticians, mathematicians. We've got data scientists, engineers, just data capturers, a very, very diverse and interesting team to work with. And we're based in South Africa. We mostly start off and have developed products for South Africans, knowing that the environment that we're in, but we're expanding to other countries and doing risk analysis in other countries as well. So just a bit about our wildfire modeling. This is one of the products that I'm leading and that I've helped to develop at RiskScape. When we actually started planning this talk, I was planning to talk about the wildfire risk, and I think since December and January, I don't really need to convince a lot of people that wildfires are something that needs to be modeled and needs to be assessed in terms of risk. So just a few of the wildfire locations that you might have heard about in the news over the past month or two. They do get out of control. Quite a few reasons for that. For example, invasive vegetation, climate change, of course, terrain that's inaccessible, and just the sheer frequency of fires that are starting. And it's, of course, not expected to necessarily decrease in the short term. So there's a critical gap to fill here. There are wildfire products available, freely available. You've got, for example, the Canadian Fire Weather Index, but the resolution is not appropriate and it's not developed in Africa or for South Africans. It's at a 30-kilometer resolution. It doesn't cater for our unique wildland-urban interfaces. For example, also products that you get from the United States, their wildland-urban interfaces look markedly different than ours, so the risk can't be assessed in the same way. And hence, you can't only just take products from elsewhere and apply it as is in a South African context. Oh dear, I see my my number 5 didn't format that nicely. So today I'm not really going to go into a lot of detail on the machine learning aspects. I'm going to keep it a bit more high level, just more or less stating what we did, so it's not going to be too technical. So this is the broad process that we had to follow. Firstly, the data. This is a mouthful in and of itself. Working with spatial data is a lot different than just working in a tabular format with your usual ML application. You need to think about things in a different dimension. You need to think about it spatially. So we've got NASA satellite data. That's what we used to train on. That's our fire points, our events, if you call it that. And that's daily data on a just under 400 meter resolution. So you can imagine training on 20 years, 400 meter resolution. I see Jan giggling there because he did the training for us. That's a lot of data. Daily over 20 years for 400 meters. Then you've got atmospheric data, and then that's a whole range of data as well. We've got, for example, precipitation, convert that into a drought measure. You've got temperature, humidity, you've got, what did we have as well? We've got static variables like dew potential height, slope, height above sea level, anything that you can essentially think of, we've got in this model. Land cover, vegetation types. And what we also did with the data is we made sure that the data that we get, you can also download that according to forecasted data. So we aligned that to CMIP 6 data from the IPCC scenarios. So this is very important because you don't want to assess risk as it is now, you want to assess it going forward as well. So the pre-processing, and that's where our spatial analysts come in, very useful, because each of these more than 10, 15 data sets are on different resolutions. So you have to match the grid before you actually can start modeling. And then you have to clean it as well. And this is where the spatial understanding comes in. You can't just take every point as a fire. I'll speak a bit about that in the next slide. So they need to spend some time as well. And then the problem specification. Are we looking at fire frequencies? Are we looking at severity? In Gauteng, for example, you get a lot of controlled fires. So you can't model on just frequency because you're going to get very high risk in Gauteng, whereas in Western Cape, where you get these really big wildfires, they don't happen every year. So you can't model on frequency. You have to get a severity measure. And then the main machine learning application is you actually have to then train to your target variable, which is not easy because this is firstly a huge data set, and secondly, it's extremely imbalanced. So you would get some fires where you'd get maybe 1 or 2 fires in a certain biome, and then you'd get a lot of fires in another biome. So your data is just completely unbalanced. And it's also definitely not a linear problem to solve. Just as an example, if you think about drought, yes, if things are drier, they are more combustible, which increases your risk to fire. But if it's dry over a long period of time, then there's no vegetation to burn. So it's not linear. And you need to think about the interactions of these variables. You need water for the fuel to grow, and then you need dryness to make it combustible. So all of these, and then of course things like humidity, your vegetation type, your land cover type, everything plays a role. So this is, complicates the problem quite a lot. And then the last step, number 5, which I formatted very strangely there, you have to actually assess the risk of stands. You can't just say, okay, this property is in Western Cape in Knysna, oh, it's got a high risk. How far is it from the urban interface? What's the wind speed? What's the wind direction? What direction is it from the mountainous areas? You need to account for all of that in order to actually assess the risk at a property level. If you think about it from an insurer's point of view, they can't just not insure anyone in Knysna. That's not going to happen. So they need to be able to assess their risk properly. So just a bit more about the detail. that's our first sort of mini ML application, if I can call it that, in the modeling process. And this is actually just identifying, it's quite simple, it's just identifying fire events, but it's very important. So we essentially looked at it as a classification problem, where we classified points according to whether they belong to the same fire event or not. And this is very important, because you can't treat every point as a different event. Otherwise, your Neisner fire, which is one event, would have come up as maybe 50, 70 events. And that's not going to fly in your ML training. And then as well, false events detections, because the NASA fire satellite, it essentially picks up heat. So things like open mines, for example, just messes up essentially the fire detection. So there's just a bit of a visual of some fires that you can see there. So each of these polygons are a fire, and then each of the points are NASA fire satellite points belonging to that fire. So this is what we train on. So each of those polygons are essentially single events. And the first picture there on your left-hand side, that's an example of some controlled fires, where you can see they're quite small, but there are a lot of them, and they're in the same place. And then the second picture with the purple dots there, you can see that's a picture of Western Cape and the training data over there. You can see there are fewer, but they are larger polygons. So what we trained against was the square kilometer per day. So we measured each polygon, the area that it covers, and then the days over which it burned. So we divided it by the days to get a spread rate. And this is our target variable. So just also quickly, so to train that, and that's how we trained against the model. Step number one for us was, of course, to get an expert and collaborate with an ML expert to help us train that model, because that was quite a mission. And there you can see some output. You can see it follows the natural sort of vegetation types. It's on very high resolution. Those blocks are essentially our atmospheric variable blocks. And then we have a risk estimate per season that we then give to the insurers and the banks. And here you can see how we attach it to stands. Those red blocks are our fire blocks, essentially. So those are sort of risk estimates per area. And then we relate each area to neighboring stands. So we attach data like the typical wind speed on a windy day, and the direction, the distance from the stand to the open area, and the risk of the open area itself. And then also any barriers, like additional stands between the reference stand and the open area. So all that gets taken into account to evaluate the final risk. And there's just some sample output from the Western Cape, where you can see it essentially gradually becomes less as the stands move further away from your open areas. And this is again why I said that it's important not to just adapt from other countries' data, because their urban interface areas doesn't look like this. And then this is a case study from the recent fires showing what the model is doing and picking up. This is very, very interesting actually. So you can see in the top map, so this is Mossel Bay that I'm looking at here. This is the average summer risk from 2022 to 2025 versus the bottom map, which is the risk during December 2025. So you can see there's actually a market increase in risk here, and we're able to pick that up. And then in the graph, you can see how our expected severity, which is the burn speed, essentially increases there. So anything above 2 is really considered, quite severe and quite dangerous. And you can see it's actually been exceeded here quite a number of times. So there's some flags that were showing there even before the fire started. So just quickly on the current model application. Sure, I don't know what happened to my formatting. Essentially, the first map shows 2025, and then after that, we've got a forward-looking view. As I mentioned to you, we constructed the model to be able to take a forward-looking view. And this is important for banks and insurers because they need to not only assess their risk now, they need to report to the regulator what's their risk going to be in 30 years, because their bonds are 30 years, if you think about banks. They need to report on that not only for now, and they need to price correctly because they're locked in. So for various reasons, capital management, general risk management, they need to know. Sorry. No worries. Okay. Yeah, so they need to not only know what their risk is now, they need to project it forward, and they need to do scenario analysis as well. So how can this be taken further? At the moment, we're using it for, to help insurers and banks understand their risk. But it can also be used as an early warning system, can be developed further. It has that flexibility because we have data output and assessments for every single day that you have. If you have your atmospheric variables on a daily basis, you can assess your risk on that day, and that's very powerful. Also, the fact that we use data sets that are typically available globally, it can be expanded. The same architecture can be used in other countries as well. And so that's also important, not only it's also important from a commercial perspective because, for example, Standard Bank or whatever banks, they have, all of the big banks, they have also branches, overseas. They have in other African countries. They have European branches. So this is very important from that perspective as well. So, this was just, I think, a very interesting case study, something that we had some problems to solve with, but that I think we finally cracked. And I'm very excited because it's scalable and it's useful and it's, built for South African context. Thank you very much.
Thank you so much. Any questions, guys? Yes.
Hi, thank you for the talk. My name is Andrew. That was very interesting. Would this be able to work in countries with similar biomes then? Similar African countries with similar biomes?
Yeah, definitely. And I think actually if one would apply it in a different country, I would essentially train it fresh. The good thing about the NASA fire satellite data is that it's global. So in my opinion, it would probably take like a week or two, just train a fresh model, to make sure your data is appropriate because not all biomes that are here might necessarily be in other countries. Yeah.
Thank you. I have one question here.
Okay, thank you so much for your beautiful talk. Whilst you were speaking, you talked about class imbalance, a very high imbalance, especially when you're taking the non-linearity between your data. So I wanted to confirm how are you able to deal with this class imbalance, and I want to know the effect it had on calibration in terms of, say, severity and occurrence.
So to be honest, the neural network training and dealing with the class imbalances, that Jan that's sitting there, he helped us with that. So I think he's the right person maybe to take that answer for me.
Yes, the person. Okay. I have a question, finally, please.
Yeah.
You talked about an application to finance. How do we apply this model to, let's say, capital allocation in finance?
So with capital allocation, they typically look at the tail end of events. So what we would typically do is we would look at a time series of dates that we want to look at. Let's say we take a 3-year period. That's usually what we take. Now we've got daily data. So then we convert that essentially into a distribution. Let's say the 99th percentile. And then we look at risk at that percentile for different locations. And then that's how we would go about the capital allocation problem.
Hi Nadine, can I quickly ask you something? Did you manage to save some money in Mossel Bay? Could they act in time?
No, not yet. We actually only got the data ready last night. So, but we're working on that.
Okay. I'll answer the other gent directly on the imbalances later.
Okay.
Hi Nadine. I have a question. How do you handle extrapolating into the future? Because I can imagine if you're just extrapolating the individual input variables, that can make sense. But if you have time or date as an input to the machine learning, if you're plugging in newer values, then that could be an issue because you haven't trained on that yet.
So typically what we do when we're looking at future scenarios is we use established scenarios from climatological groups over the world, because that's not our sort of speciality to do even longer term climate forecasts. But what's nice about the IPCC scenarios and the CMIP6 modeling groups and the framework is that the data is available at a daily temporal resolution, and therefore we can essentially just plug it into our model. So things like, for example, your vegetation and your land cover we have to assume remain static, although that's something that we're also actually working on to look at changes in vegetation, because you expect that, right? If, for example, in the Western Capes that's going to become a lot more dry, you expect some changes in vegetation there. So that's something that we're looking to incorporate.
One more question here. Okay. Okay.
Hello. I have just one question, and I'm not sure if I'm being unfair to you. You said something very interesting about how sometimes you would get land cover where the surface would be very, very dry, and which means it would be highly combustible. But at the same time, because it's combustible, there would also be very less to burn within the land cover. I just wanted you to sort of re-explain that point. I really didn't quite get. I don't know if I went to sleep for a second there, because it's a very interesting point when you look at severity measure, and I find the measure of severity to be quite interesting for me in terms of wildfires. I go to Cape Town quite a lot, and there are lots of wildfires there. And I have relatives who've been affected by wildfires since. So I would like you to sort of re-explain that, if you don't mind.
Yes.
Thank you so
much. Of course. So typically if you have a period of a lot of rain and then you have a lot of fuel to build, and then when it becomes dry, that fuel becomes dry and combustible. However, and this is something that we've seen that the model also picks up, if you have a very long period of drought, then so let's say it burned and now the fuel's gone, and now there's a very long period of drought. Now the fuel doesn't actually regrow again, so it's like it's more barren essentially because it's so dry, almost like arid, becoming arid. And in those cases, the actual burn fuel is few and far between, even though it's dry, and then hence it doesn't really spread that much. And that's also one of the reasons why we had to incorporate a vegetation moisture index into our model. It's because we saw in some places in the Northern Cape, for example, you have the same biome, you have the same vegetation type, but in some places it's dense and other places it's sparse. So you can use the vegetation moisture index to actually see how sparse it is.
Sorry, I promise you this is the last one. So how do you sort of actually compute this when it seems to me that the high level of combustibility is actually offsets the range of the wildfire? I don't know if I'm getting you, if I'm understanding you correctly, because it does seem to me as if the one variable offsets the other in this particular case.
That's exactly why the problem is so difficult to solve, and why it becomes an essentially non-linear problem. And so the training needs to take care, the neural network training needs to take care of all those intricate relationships about when is something a driver of risk and when is it actually a mitigation factor. So.
One last question here.
Hi, thanks so much for an interesting talk. I had a question, I guess, in terms of your focus. Obviously, your main customers are insurance companies, is that right?
Yes.
And how about sort of collaborations with civil society in terms of governments, municipalities, to kind of give them early warning signs for potential risks of fire areas? Is that something that, I mean, I can understand it's always trickier with government, but from a kind of societal perspective, I don't know if there are many organizations that will have done this level of depth of analysis on potential fire risk, and is it something that you guys are considering doing?
Yeah, well, that's something that we're definitely open on doing. So this wildfire model is in its early stages. So at the moment we're sort of on assessing typical risk, and only now recently we've started to looking at the time series and when is it triggers for an early warning. So it's still early days, but definitely open to working with more types of organizations.
Thank you so much. A big round of applause for Nadine, please. I will pass the mic to Aurel, who will introduce the next speaker.
Okay. Our next speaker will be Dr. Tara Soute, founder and CEO of TerraClim. And she had a PhD in viticulture and climate science. And her work bridges climate research, geospatial data, and decision support tools to help producers adapt to climate risk. And we are very pleased to have her with us today. And her talk is entitled From Climate Chaos to Climate Intelligence. And she will explore how AI-driven decision system can support climate-resilient agriculture across Africa. So, Dr. Tara, the floor is yours.
Thank you very much. Can I just confirm that you can hear me?
Yeah.
Fantastic. So from climate chaos to climate intelligence, I'm Dr. Tara Soute, originally from Stellenbosch University, and today the founder and CEO of a company called TerraClim, where we aim to drive forward farming solution using technology, AI-driven decision-making, looking at African agriculture. So the narrative of the conversation today, and that was a really insightful, amazing presentation by Nadine. Very excited to collaborate. But the narrative of the conversation today for me is climate chaos is the new normal. What is the core problem we face in agriculture, agricultural impacts of inaction that we face? More coming from an agricultural perspective, why traditional models fail in Africa, and what has TerraClim realized out of pain, and what are some real life scenarios where we're using a system of systems approach to start serving agriculture and help agriculture inform decision making. And then to round off with where AI fits, where it doesn't fit, and looking ahead, really where innovation lies through collaboration. So as a start, we're sitting in a scenario of climate chaos. The presentation just now about wildfires, which is one of the fruits of climate change, is African agriculture is already operating in a permanent state of volatility. So it's not just a future risk, it's a now risk. And it's starting to cause a significant amount of operational risks. And if we're looking at the continuous increase in temperature on a decade-on-decade basis, that drives a reduction in GDP between 2 and 5% on an annual basis. And then that goes and pushes the national budgets that keeps intervening with these extreme events. So currently we've got droughts up in the north. In the Western Cape, we've got extreme fires. We've got foot and mouth. All of these climate drivers are underpinning these events from being exacerbated. So we continue to see extreme heats, extreme rainfall shifts, droughts and floods. So climate is no longer a background variable. It's today the primate variable that we need to manage and watch. So the core problem we face is Africa is currently in a state where 95% of Africa is cultivated land in sub-Sahara, which is rain-fed. It's also the greatest opportunity to transition agriculture in Africa is starting to become more water-wise in how we use our water and in irrigation. And then that links to 46% is linked to the employment in Africa is in agriculture. So again, emphasizing the importance of agriculture underpinning so much and agriculture being so volatile in the state of climate change. So if we don't act, climate impact by 2050 will have a 50% reduction in agricultural production. That will further drive 13.5 million people further into the state of poverty and have a huge impact on the GDP of South Africa. Today, there's a $400 billion shortfall that leaves the global south exposed. So we're sitting in a scenario where climate data is failing to capture the microclimate effects, failing to capture the risk, and we need to start closing that gap using technology. We're sitting in a hopeless situation where there are constant reports of crops winning, but then there's a lot of crops losses. So it's constant harvests that are failing, and it's normally in the small-scale farming community. The pain point is being felt in the commercial space. That results in farm closures, which changes ecosystems, which changes the economy of an environment. So the pain and problem is real, and it takes it all the way down to farm and field level, which is the farmer that faces uncertainty every day. In South Africa, our climate change scenario is increased seasonal variability, climate variability, water scarcity, our input costs rising, unpredictable diseases and pest breakouts, and the need stronger pressure on yields and profitability. So how do we start helping farmers? How do we keep farmers farming is really the mandate of what underpins our operation, and that's empowered through data-driven decision-making and hourly climate data. Hourly data influences the plant's response. Plants are calculators, pest diseases are calculators, as are we as humans. We calculate stress and then we break. And it's the same with plants. There's a calculation, and we, from the naked eye, can't quantify how much risk is actually being exposed to certain plants and when do plants fall out of their adaptive phase. So that's where the risk is actually measurable and has a price tag attached to it. So if we start seeing the economic impact of constant climate risk that's unquantified, unmeasured, the risk continues from a 1 to 3-fold, and the severity on the GDP just keeps increasing. And that keeps us in a state where the estimated annual adaptation costs are between 30 and 50 billion rand a year, just to realign and start looking at the direct impact on economic resilience. It's not a nice to have, it's a must where we stand today. So looking at why traditional models fail, we have weather data, and many countries have it. There's stations, there's forecast models, there's a lot of reanalysis done. There's a lot of satellite data. There are new robust satellites coming out very quickly and almost difficult to keep up with it. Those satellites are very powerful. They can provide us with natural vegetation index, vegetation, exactly what Nadine was just explaining, soil moisture, evapotranspiration proxies. Then there's a lot of soil information that's collected. There's profiles done, there's textures. There's a lot of information on management level. Then there's trials and management of cultivar trials, what works, what doesn't. Terraclim works with a lot of commodities across different sectors, grain SA, potato SA, South Africa wine. But none of this information becomes centralized, and data unintegrated is just noise. It's just another point. So how do we start bringing these data points together? And that's really where AI can take things to the next level. But to emphasize, data needs to be clean, data needs to be vetted and validated. So when it comes to weather stations, it's not just about a weather station point, it's about where is it placed, what kind of data is it collecting, what is the sensors, has it been serviced, to really quantify the environmental parameters. Otherwise, this becomes very dangerous. We end up shooting in the dark and predicting in the dark and start predicting a future that's maybe not reality. So how do we get to a place where we integrate these data sources? So that's where Terraclim has started to look at the future of agriculture, African agriculture. It's not going to be decided by climate only. It really is going to be decided by how intelligently we respond to climate, how we use one door closing and another door opening. So today, I think this whole conference is a call to action. How do we start looking at building a connected system? How do we start talking about aggregating data so that we're not building tools in isolation, but tools that can be underpinned by sound data that can transform decision making? So that brings me to Terraclim. Our goal is to address the global pain and the global problem and the pain that it causes, which is to secure food and economic resilience in Africa, and that's through enabling climate smart action. And what does that look like from a climate mitigation point of view and a climate adaptation point of view? And taking it back to on-farm, in-field, and real-time. So we've taken data-driven strategies and tools where we aggregate multiple weather stations into one centralized climate database. And we vet the weather stations, we ensure that they are aligned with the World Meteorological Organization standards, which means it's not near a water body, it's not on top of a water tank, it's 2 meters above the ground, and it's fit within that environment for use case. One of our key partners spoke earlier, Metos South Africa. So we aggregate this data into a centralized climate database, and then we use data to clean data. We run a whole lot of machine learning models. And then the next phase of that is, how do we now create essentially virtual stations to make a continuous surface of the data? And this is, we also use remote sensing as covariates to some of this analysis. But the core of the analysis is using weather stations that have been clean and collated, so no gaps in the data, at an hourly resolution. We integrate that with digital elevation models with a company called Geosmart Space. This is an example of a 5-meter digital elevation model and a 2-meter digital elevation model. So it's a model of the Earth's surface. A lot of these derivatives, slope, elevation, solar radiation, terrain wetness index aspects are mimics of the Earth's surface, but that has a direct correlation with how temperature changes. So we've, over more than 15 years, developed algorithms to model temperature surfaces of South Africa at an hourly, daily, and monthly resolution. We're also doing this for SADC countries. And why this is of value is that for every hour of the day, you can now accumulate and look at what is the heat stress in an area. This could be evident and valuable for fire risk too. Where are the areas that are already got more hours above 35, more hours above 30? So we have started to splice climate data into temperature profiling, and that temperature profiling links back to physiological responses, human stress, heat stress, plant responses, pest and disease movements. And then we aggregate this to daily and monthly, and then we take it a step further and we link it to crop planting windows. We link it to crop specific indexes. So this is an example of a bioclimatic index, chill unit specifically. This is run over the Western Cape. So you can see the darker blue areas is where you have higher chill accumulation. Each image is a different season. So I'm emphasizing the impact of seasonal variability that we face in the agricultural sector, and it's increasing more so than ever. The darker blue areas is where we would plant cherries and plums and apples, and the lighter areas is where you'd plant potatoes and wine grapes and grain. So you can already see the spatial variation difference that will dictate what crop type you should plant successfully. Then we take these maps further and look at risk assessment. So we look at what is the risk assessment over the last 5 years. So the darker red areas is where you'd have a 300 unit difference in chill. This would cause farmers to require more sprays need to be applied to ensure effective bud burst in the winter months, or they need to change their pruning methodology. So it takes it back to real life input costs. And then the lighter areas, less risk. So we do this for frost, hail, rain, and different variables. Then we aggregate all this information into a centralized crop suitability tool, where we're now looking at more than 44 environmental parameters, soil, climate, and terrain, and you aggregate it back to where is citrus planted, where is grapes planted, which is the green area, where is the purple area, which is pome and stone, and link that back to effective climate profiling or environmental profiling for that specific crop. And then we create these climate index maps, which gives you a high, low, and medium suitability as to what should you plant and what is better for that area than in another area. So the reason why this is important, because it brings it back down to the need for hourly data and aggregating hourly data back to specific crop needs. Crops have a natural plasticity within them, but there's a turning point where they can't stretch any further. They can't adapt any further, and we are adaptive by nature. So when the climate conditions exceed certain thresholds, adaptation fails, and that's where mitigation needs to step in. We need to stop looking at practices that can adapt, but you need to start looking at mitigation, which is plant a different crop type, change your activity on your land. So these results will continue to compromise production and force economic losses if they're not addressed and the data is not made available to enforce different actions. So our goal was to put this information in the hands of the grower, in the hands of the industry leaders, in the hands of the government, to start informing decision making. So Terraclim has taken this massive data set, which is available via API. We've also disseminated through a Terraclim web app, which means any farmer can access this data and start profiling and looking at his farm. Consulting and research continue to develop what we're developing. All our research is developed in the Western Cape with focus and reason, in that we've got the two coastlines that meet at the tip of Africa. It creates the phenomenon of the sea breeze effect that blows inland over an area really rich in topographic variation and soil variation. So those have added a lot of robustness and modularity to our model. So our model it's very easy to take it into another country and do the same thing in other countries. And then we've got a suitability tool, which is taking all this information and start looking at what crops should you plant where, and this links to the food security goal. So Terraclim Solutions, we don't predict the future. That's not our goal. We collaborate with those that do predict the future. We enable better decision making with hindsight insights. So looking back over the last 5 years, the last 3 years, tracking what has happened gives you a better insight as to what will happen. So we strive to have effective observations from remote sensing and station data, and then a lot of archived 30-year to 50-year data sets. We do a lot of quality and AI assessments, bias checks, interpolations. We generate these climate surfaces at a high resolution, so it's at a 40 meter to 250 meter, and we do it on an hourly resolution, so it's very high resolution. Sorry, I've been asked to wrap up. So at the end of the day, climate intelligent answers is what can you plant where, what cultivar is viable, and what should you plant? So really we're looking at what is winning, what is losing, and what is the future to get us to a more hopeful scenario of what should you plant where. Some of the case studies is taking this data set and starting to look at what is the climate hours above 35, which is deemed as heat risk, and how long is that heat risk therefore across different production zones in South Africa. And you can see the variation over multiple seasons, with the dark blue 2024 popping out as a lot more hours than other years. This is our web app, which is just an interface that you can digitize your farm and you can analyze your farm and explore. And sorry, I'm rushing. I've been asked to stop, but I'm way under my time. There are more than 40 environmental layers here, natural vegetation index, NDVIs, your climate profiling, that you can link these and understand why is there a higher vegetation index. And it's generally because there's terrain wetness underground, or it could be that, there's just lower temperature profiling that links to higher vegetation growth. So this is the web profile. It's accessible. You can go to terraclim.ca.za and sign up. It provides you with a digital footprint for your land. Let me take the analysis further, and we, as I said, do a crop suitability analysis where you can go into the tool and you can access any point on the tool, drop a pin, and then it provides you with an environmental profile. So here's a case study where we've done it for wine grapes, where you can select 2 fields on a farm or multiple farms. It decodes the data and provides you with the top 10 variables out of 44 that are most impacted, will have the biggest impact on planting wine grapes compared to potatoes. And then you look at, it's a 24% slope compared to a 10% slope. And then you look at all the other variables, and then it gives you a suitability score based on data that's in the database, using machine learning to identify you should plant Pinotage instead of Sauvignon Blanc or Pinotage instead of Shiraz. Then we create these suitability maps. And another case study is using this data to look at potato planting. So again, anywhere in the Sunbelt, you can select fields, and it provides you with suitability that you should plant. And again, it's the window of planting too. Are you planting in summer or autumn or spring? And it gives you an indication as to what you should plant. Here's an example of a nice spatial visual explanation of planting plums that have a high economic value to the country, and identifying where should they be planted and expanded. And these are 3 different cultivars: African Delight, Angelino, Sungold. And you can see Sungold has a lot more green areas throughout the Western Cape, so it's a cultivar that's possibly a safer bet than something like African Delight, which is planted in very unique bands. So this also can be used as a marketing story to say the one is the more difficult to plant, so the one can be sold at a higher value. There are many ways that you can spin this. A lot of agriculture is looking at how do we premiumize what we already have, and storytelling is also where it starts. So there are many value adds that data can add to where we're at today. So lastly, system of systems to modernize agriculture. How do we get to a place to, not just in the commercial sector, but also in the small-scale farming community, get to a place where we can democratize access to data? This is a key project currently running through the Department of Science, Technology and Innovation and the Technology Innovation Agency, with partnerships with CSIR and Agricultural Research Council, where we are looking at how do we aggregate data that sits in these robust databases for many years, and use AI and chatbots and technology to mine the data to inform better decision making. We're running this pilot in Eastern Cape at the moment and scaling to KwaZulu-Natal. And the pilot is drop a pin and it extracts all this information from the back end, and it gives you a soil analysis, it gives you the climate variability, the average temperature, humidity, rainfall, what is your risks for planting, and what of the cultivars is most viable for you to plant in the specific site. So we're currently looking at potato, maize, dry beans, canola, and it gives you an indication. So just to round off and close off, AI is an enabler, it's not a product. So this is really, AI has a place, but it doesn't fit everywhere. And I think it's important to use AI to detect anomalies, errors in climate data. It's important to use it to automate quality control. It can enhance spatial interpolations, improve our methodologies. It can summarize trends and risks. It's amazing at that. It saves a lot of the human's time. But AI supports decision making. It doesn't make decisions. And I think we need to use these platforms to communicate that and understand the limitations. So data without integration creates just noise, going back to one of my previous comments. So we need to start aggregating tools. So AI in water management is a very phenomenal solution for the future of Africa, but it requires effective rainfall integration, evapotranspiration integration, soil moisture integration. And in that place, it can start supporting real-time live inputs through inputs still being collected in field. So looking ahead, AI and innovation for climate resilient farming really lies in how do we empower farmers to be future fit, to be still farming in 10, 20 years' time. And that sustains our economy, that sustains ecosystems. So that needs to be underpinned by robust research and detailed data. Thank you very much.
Thank you, Tara. We only have time for only one question. Does anyone have a question? All clear? I have actually one question, Tara. I have worked before in commodities, and I wanted to know how available is the data in South Africa concerning agricultural data. Is it something transparent? Does the government give out the data, or how does it work?
So no, that's Terraclim actually started because we couldn't access data. So during my PhD, I'm actually a qualified winemaker that went on to doing my master's and my PhD, and in that process was so frustrated that I couldn't further my research career because I couldn't access large climate data sets on an hourly resolution throughout the whole of South Africa. And that drove us to the place where we are now in a private sector company, aggregating data, to find ways that we can better communicate climate change to the agricultural sector. So at the moment, we work with commodity heads, South Africa wine, potato SA, grain SA, to understand how those commodities can thrive in a future climate scenario. And our aim is to make this data as available as we can and collaborate as much as we can. So I'm open to anybody contacting me, collaborating. As I said, we are underpinned by a lot of research from Stellenbosch University. We still continue to do research and development. So we are always open to collaborate in any way, form or format. But at the moment, this data does sit in the private sector, and we've built key partnerships with private sector weather station networks. There is a lot of phenomenal work that the Agricultural Research Council is doing, that the CSIR is doing in the government space, but the data is not integrated in the nature that we are needing it to be integrated from an AI perspective.
Perfect. Thank you, Tara. A big round of applause, please.
Thank you very much.
I will let Aurel introduce our keynote speaker.
So we will now move to our keynote speaker session, which will set the stage for the panel discussion which will follow. And it's a real honor to welcome Professor Priya Donti. She is an assistant professor and the Silverman Family Career Development Professor at MIT, with a joint appointment in EECS and WITS. Her research focuses on safe and robust machine learning for high renewable power grid, one of the most pressing challenges at the intersection of AI, energy system, and climate resilience. She's also the co-founder and chair of Climate Change AI, a global non-profit initiative that has played a pivotal role in shaping how the AI community worldwide engage with climate change by catalyzing research, education, and real-world impact. And she holds a PhD in computer science and public policy from Carnegie Mellon University, and her work has been widely recognized, including by MIT Technology Review 35 Innovator Under 35, the Time 100 AI lists, and Voice Future Preferred 50, among many other honors. Today, Priya will share her perspective in a talk entitled Tackling Climate Change with Machine Learning, offering insights that bridge cutting-edge research, real-world deployment, and the role of the global AI community. Please join me to welcome Professor Priya Donti.
Wonderful. Thanks so much, Aurel and the organizing team for putting on this event and for inviting me to speak. Just one technical thing. It doesn't seem that I have permissions to share my slides in the Teams meeting, so I was wondering if that could be granted to me. Perfect. Okay. All right. Can everyone see my slides? Okay, wonderful. Yeah, so, thank you again for inviting me. And today I want to kind of, I guess, build upon all this amazing momentum from the previous speakers who have shared some awesome use cases of AI for sustainability, and talk more broadly about kind of what are some general applications and themes where AI can be used specifically for climate action. So climate change is obviously one of the most pressing issues that we as a society are facing today. And we're already feeling its effects, from storms to droughts to fires to flooding. And particularly given that the effects of climate most impact the world's already most disproportionately impacted populations, it becomes even more imperative to act on this issue by rapidly reducing greenhouse gas emissions and adapting to the effects of a changing climate. So given kind of our positioning all within the AI community, then it becomes very natural to ask kind of, how does AI play a role? And as you've already seen through many of the presentations kind of in the various rooms today, AI can play a role across a variety of sectors and applications, from kind of reducing, helping to better integrate renewables and electricity systems, to helping us monitor land use characteristics in order to both promote sort of climate smart agricultural practices and foster adaptation strategies in this regard, helping us kind of build better climate models by, for example, improving parameter estimates to these climate models, and kind of fostering societal adaptation strategies, for example, by enabling better health monitoring. So I want to spend a little bit of time kind of going through kind of the results of an assessment that we did several years ago called Tackling Climate Change with Machine Learning that tried to provide basically kind of an overview and a taxonomy of some of these different applications, just to give a sense of kind of different ways that I think the AI community can participate in helping to advance climate strategies. So one recurring theme that comes up is the use of AI to distill raw data into actionable information. In particular, there are many cases where ideally we would have more targeted information on the ground about things like where emissions are coming from, or where deforestation is happening, or what the crop types are for kind of to survey agricultural land. And ideally, why we would have this on-the-ground information collected in order to help foster climate-related decisions, we may not have this information already there. So AI has been used to kind of analyze raw, quote-unquote, raw data streams coupled with some amount of on-the-ground data, so things like satellite imagery coupled with on-the-ground labels, in order to try to provide these kinds of kind of large-scale maps and assessments of some of these quantities. So for example, the image on the slide is from an assessment in partnership with NASA Harvest, trying to basically assess the kind of probability fraction and land cover, probability and fraction of various types of crops, as well as land cover class, as kind of an input to climate change adaptation strategies. Another common place where AI is used is to improve predictions. For example, as we think about how to better optimize power grids in order to maintain a balance between supply and demand in the face of kind of time-varying renewables and varying demand, having better predictions of kind of solar power production, for example, becomes very helpful in actually being able to maintain that balance. The image on the slide is from a nonprofit called Open Climate Fix that has been working on this issue of kind of improving solar power forecasts and demand forecasts. And by using a combination of kind of improved models as well as improved data, so using a combination of kind of historical weather data and historical solar power production, as well as combining that with imagery of kind of clouds moving overhead, by using this kind of multimodal data, they were actually able to have the error of existing forecasts, in this case in the UK, and as a result sort of better help to manage the underlying power grid. And this theme of kind of improving predictions comes across not just in renewables forecasting, but in things like forecasting for transportation demand, for planning of transportation systems, as well as prediction of extreme weather events. While the kind of prior two examples kind of are about places where AI is in some sense kind of providing information to a decision maker, there are also sort of some limited circumstances kind of in engineering systems where AI can also kind of do automated decision making in order to optimize some kind of complex system. So for example, as we think about heating and cooling systems in buildings, these systems are not necessarily run as efficiently as they could be today because there is sort of, you know, waste basically in kind of the way in which the system is optimized. And so there have been kind of efforts to try to use AI to basically learn from a combination of data about kind of what is the occupancy of a particular building, what is the temperature of that building, what are the characteristics of that building, what is the outdoor temperature, and intelligently use that information in order to optimize the heating and cooling system with greater efficiency. And this happens not just in kind of buildings, but in kind of food storage facilities, for example, optimizing the cooling systems there. And the idea is that basically by being more responsive to kind of real-time conditions and real-time data, we can basically use these algorithmic approaches to kind of optimize systems in a way that's more tuned to on-the-ground realities rather than kind of heuristic approaches that are often used today that might be kind of overly conservative. And this theme of optimizing complex systems comes up not just in heating and cooling, but also, for example, in optimization of power grids and optimization of freight auctions. Another kind of similar, let's say, like AI for engineering style application that I'll bring up is predictive maintenance. So there are many situations in which kind of you have a system that might undergo some kind of inefficiency, some kind of breakage, and you'd like to detect that ahead of time or in near real time in order to kind of improve that issue as quickly as possible, and as a result kind of mitigate the inefficiency in the system. So for example, the image on the slide is from a study that basically used AI in order to analyze solar off-grid systems and the operation of those systems in order to try to understand, are there any kind of anomalies in how these systems are behaving, in order to then pinpoint, okay, are there particular places where the solar infrastructure needs to be kind of fixed, maintained, replaced, and so forth, looking at both kind of solar systems and battery systems. And this kind of automated kind of analysis, detection, and anomaly detection can kind of help to ensure that we're maintaining these systems and kind of addressing any inefficiencies. So this theme comes up not just in kind of solar system monitoring, but also in things like monitoring methane leaks on natural gas infrastructure, as well as otherwise fostering resilience in kind of power and transportation infrastructure. A last set of themes I want to bring up kind of relate to how AI is being used not just to, let's say, enable us to better operate and plan our existing operational systems, but also enabling us to kind of better kind of discover next generation technologies and engineering workflows that can kind of help with decarbonization and adaptation strategies. For instance, AI is being kind of explored to accelerate scientific discovery of things like better batteries, better electric vehicle charging protocols, electrofuels, and carbon dioxide sorbents, often by basically learning from the outcomes of past experiments and recommending experiments to try next. The idea being that any given experiment, for example, if you're trying to test out a new battery charging protocol, may take a long time to sort of actualize and go through the design cycle and implement. And so you want to reduce the number of times you do that overall. So AI can basically, hopefully, provide better recommendations that reduce the number of total design cycles. Now, this is an area that is in active research. There have been, of course, Nobel Prizes awarded for similar things, but also maybe on-the-ground studies that sometimes the recommendation that is given by an algorithm, for example, the material that is proposed to be synthesized is either hard to synthesize or may not be a great prediction. So I think this is an area where I think the on-the-ground impact is yet to be seen, but where there's kind of a lot of interesting work and potential being explored in this area. Another kind of application kind of using AI for, let's say, science and engineering workflows is the use of AI to approximate time-intensive simulations like climate models, energy models, and city planning models. The idea here is that there are lots of physical simulations that often need to be run for climate-related workflows. For example, a climate model is a very big physics model. And the challenge is that running that model because it's so computationally intensive, is both not something we can do at huge granularity. So we often get climate predictions at the level of, for example, a large region rather than, for example, a particular city or location that we might want to take action in. And so ideally, we would have some way in order to get more targeted predictions from these models. So one way this is done, not shown on the slide, is by actually trying to provide end-to-end approximations to all or parts of these models themselves. For example, by training a model off of the inputs and outputs of simulations in order to then provide a fast surrogate model for the original model. Another approach, which is pictured on the slide, is to try to basically post-process the outputs of these physical simulations in order to make them more actionable. So the image on the slide is an example of a quote-unquote climate downscaling application, where the idea is that if we can basically learn a relationship between climate model predictions and on-the-ground weather data historically. So we run a climate model backward, we kind of have weather data historically, and then we learn kind of the relationship between those. Then when we kind of have a future climate prediction, the hope is that if we apply that same learned relationship, then we can get an estimate of what the more granular on-the-ground weather would look like in the future at that location. And this is in principle helpful for things like understanding the implications of future climate on, again, agriculture, on energy infrastructure, on things where we might need a more targeted prediction in order to make good decisions. Now, we all in this room know, right, that the density of weather station data in different parts of the world is very, very different. And so obviously the effectiveness of these approaches today, I think, looks very different across different geographies. And I think this is where, even though I think there's some excellent work kind of exploring this downscaling phenomenon, this is where I think there needs to be kind of on the ground, bottom up innovation to really ensure that these kinds of methods are actually applicable in contexts like Africa. The last theme I'll bring up is the ways in which AI can actually itself help with various aspects of data management and scenario generation. So in the US, for example, there are many cases where we have federal data sets on energy infrastructure, where kind of the same power generation facility is referred to by different identities, by different IDs in different data sets, and kind of matching these records at scale is difficult to do. So AI has been explored to actually try to do automated record matching by identifying which entries actually relate to the same generator. Another area where AI is used in the quote-unquote data creation space is in the scenario generation space. In situations where we might want, for example, indicative profiles of future wind power production in order to help kind of envision what our energy system infrastructure might look like in the future, there have been kind of works exploring how AI can be used to basically learn probability distributions over prior wind data, and then kind of how that probability distribution can be tweaked and or drawn from in order to create kind of indicative future scenarios that can be planned against. So this is sort of a bit of a whirlwind overview across, I think, some areas and themes where AI can play a role. And the reason I provide it this way is that I hope this provides a little bit of an entry point. If you're someone who already works on AI and you already work on remote sensing, I think there's a whole class of applications here, right, for you. If you work on kind of AI and engineering systems, there's a whole class of applications, et cetera, et cetera. And I think there are just many different entry points for the AI community to kind of leverage their skills in service of climate action. And for those who want kind of to read a more in-depth kind of overview of some of these applications or kind of additional applications, I would encourage you to check out this paper. One thing I'd like to emphasize is that kind of, if you look back to kind of the set of applications that I just talked about, there's no sort of one type of AI technique that is necessarily dominating in terms of kind of how these different applications are being served. Ultimately, diverse applications and diverse settings require diverse approaches. And in some ways, I think this is counter to the narrative that is often being posed at the macro level. I think there's often this narrative that, oh, if we just scale the kind of a particular paradigm of AI, kind of large generative language-based models, with big data, big compute, only data, and with particular performance metrics, that somehow all of these applications will benefit. And in reality, on-the-ground applications have very different requirements that are not necessarily served by just this kind of one modeling paradigm. For example, in many, for many applications and in many geographical contexts, you have less data, or that data may be hard to move. For example, in power grids, there's a lot of data, for example, in the US context that's collected in sensors on the grid, but we don't always want to move that data to one centralized location in order to process it. And of course, in different grids outside the US, even less data is available. In addition, kind of the scale of compute that is available to different entities is obviously different. In some cases, you want to do inference on edge devices. Again, for example, on a powered grid, you have small hardware devices. And we, of course, want to reduce, in general, the energy and emissions associated with AI models in cases where that is wasteful. While sort of I'll call it the quote-unquote dominant modeling paradigm also tends to assume sort of data is all you need. If you just collect large swaths of data, then your model will perform well. In reality, we know that in many
Please, Tara, we have a please, Priya, we have a short technical issue here. We can hear you. Can you try to speak? Oh, no, the screen is freeze. We can hear you.
Hi all, can you hear me?
Try to share your screen again, and
Yeah.
yeah,
Can you see it?
Yes, definitely.
Perfect.
Sorry
all
for
right.
that.
No problem. So just to maybe kind of get back into it. So as I talked about, right, like we can use AI for kind of many different areas across climate action. But as I was starting to discuss, I think that diverse settings really require diverse approaches. So I'd started to talk about how you know, the data and compute realities in different places and for different applications can be very different. And in addition, what I was sort of starting to talk about is this idea that kind of, while kind of often the dominant paradigm of AI tends to kind of assume if you just throw a bunch of data into a model, you'll learn something useful. In reality, in many tasks, we have existing useful knowledge from our task or from our domain. For example, in physics and engineering domains, we already know something about the physical equations or engineering equations of the system. We also have often useful local knowledge, indigenous knowledge, other knowledge that is not necessarily being kind of captured in data, and yet kind of can be used to both improve the effectiveness of our overall modeling efforts, as well as kind of reduce the need to wastefully relearn from data from scratch. And as a result, often you have smaller models. And so I think this is also kind of a difference on the ground. In addition to the fact that kind of different notions of performance matter in different settings. For example, when using AI for biodiversity and trying to understand the occurrence of rare species, what we care about is not sort of just overall classification accuracy across all species, so kind of average performance. You care about group-weighted accuracy or performance on those kind of rarer samples. And in general, in different settings, we're often solving for different things. We want methods that are safe or robust or private or interpretable, etc. And the way we actually design methods needs to look different depending on what those on-the-ground requirements are. So for example, in my group's work at MIT, we look at kind of developing ML methods for the electric power sector, where basically we're trying to optimize power grids kind of at greater speed and scale to improve resilience and integrate renewables. And we need to do this kind of in a setting where power systems are governed by physics, you know, how power flows along the lines, by hard equipment constraints regarding kind of what we can tell power generators to do or not do, and voltages they need to be maintained at. And on top of that, we need to make decisions under uncertainty regarding things like how much demand we have and how much renewable supply we have. Traditionally, these kinds of problems are addressed via kind of traditional optimization and control, where you explicitly write down your objectives and constraints and use an optimization solver to solve them. And the benefit of that is that you actually get constraint satisfaction. But the challenge is that these methods are often very slow to solve, which means you can't often solve them quickly enough in order to kind of achieve the objective you need, like managing a power grid in real time. On the other hand, machine learning techniques have the potential to be very fast and scalable, but they struggle to actually satisfy these hard constraints. And so what we've started to look at is, are there ways that you can actually incorporate existing knowledge from optimization, control, electrical engineering, and so forth, into the way that we design machine learning models in order to kind of improve overall outcomes? And in particular, what our group does is we develop kind of methods in this area of engineering constrained machine learning, where we actually design specific neural network layers that capture some of the physics and hard constraints associated with power grids. So for example, that layer could represent equations that dictate how power flows through the power grid, and we figure out how to make this set of equations differentiable so they can be integrated into a neural network and trained via backpropagation and gradient descent. And kind of using this kind of strategy, we're able to do things like develop better forecasts of electricity demand for the power grid that are cognizant of what mistakes are particularly bad for the decision maker. And we do that by embedding a decision-making module within our forecasting method. We kind of use this to also learn fast and feasible approximations to power grid optimization problems, things called optimal power flow problems. And we do this in a way that preserves the physics around the flows of power on the power grid by embedding a physical flow module within our model. And we also use this to kind of develop control methods using deep reinforcement learning for things like inverters and batteries on the power grid in ways that provably maintain the stability of the power grid by basically designing a module within our neural network that inherits kind of mathematical machinery from the robust control literature. And then as a result, it's basically able to guarantee that the outputs of the neural network will kind of be in a stabilizing set of actions. So this is sort of one example of kind of designing machine learning methods in a way that's explicitly using kind of knowledge from the task in order to meet some kind of requirement of the task. And in general, I would argue that the demands of the applications that we actually need to solve for should actually shape the direction of innovation. In particular, the specific notions of robustness or interpretability or generalization or safety that we might be solving for kind of differ across different applications and different areas. You also have different on-the-ground realities with respect to data, with respect to on-the-ground requirements, with respect to success criteria. And this needs to sort of drive the development of a diverse set of methods to serve a diverse set of tasks. So I think a lot of the previous speakers made a great case, for example, for why, for example, Africa-specific data is necessary to ensure that AI workflows actually have impact on the ground in Africa. And I would additionally add that I think kind of developing a diverse set of methods that actually solve for the on-the-ground realities and requirements of African context is also really important to be doing, and I know something that a lot of you in this room are also working on. So last but not least, while I've kind of talked about how, so far, how AI can be useful for climate action, I think those of us as we go out into the world as ambassadors of thinking about kind of how can we best as a society make progress on climate change, it's also important to think about holistically what is the relationship of AI with climate change and how can we also help society shape the overall impacts of AI in line with climate goals. For example, there's of course been a lot of kind of discussion in the media, especially about how kind of the impacts, the energy use of AI, the water use of AI, materiality use of AI is increasing due to the kind of fast build out of data centers, due to kind of large frontier models, and due to both the computations and hardware required to power all of that. I think here it's worth noting that there's sort of a lot that we can and should be doing, not just to kind of increase the efficiency of models, but to sort of maybe change the overall paradigm of discussion around kind of some of the trends that are driving this large investment in frontier models and data center innovation. For example, I think there's a narrative that kind of bigger models are always better. Historical applications have also shown this is not necessarily true. Sometimes a medium task-specific model can do better than a general purpose model that's not trained for your task, so forth. So I think kind of fostering this dialogue that we, again, need kind of a diverse set of methods to actually serve the on-the-ground needs of diverse applications, I think also does something to address this idea that we shouldn't just be kind of naively scaling models without really thinking about whether that's actually an effective strategy for many of the applications we care about. In addition to kind of its AI being used for climate action and kind of the inputs to AI being consumptive, we also need to think about the fact that AI is a general purpose technology, and as a result, it's being used in all kinds of ways across society, including some that are not climate beneficial. For example, AI is widely used to accelerate oil and gas exploration and extraction, even making fields that were not previously economically viable to develop. And also, it's not just oil and gas, also kind of accelerating various functions in mining and bovine agriculture that kind of further entrench the roles of these emissions-intensive industries. So really, it's important to think about, as we also have roles not just as researchers, but members of companies and organizations, members of a broader kind of citizens within a government, that we kind of ensure that the way we're talking about AI applications is also cognizant that this is happening and is working to kind of avoid these kinds of things. And last but not least, kind of AI has kind of various system level impacts that are being shaped across society in terms of changing how we consume goods through things like kind of on-demand delivery, targeted advertising, changing how we consume information, changing how we see things online, changing things like the trajectory of our transport sector. There's a lot of work kind of trying to create autonomous vehicles, but often in ways that entrench the role of private transportation and not always kind of fostering public multimodal transportation. And so even in cases where an AI application doesn't necessarily directly seem, climate relevant, I think it's important in the same way that we think about, is that application fair? Are there ethical considerations associated with it? I think we also should be thinking about kind of, is that application sustainable in a more holistic sense? And how can we better shape the way we actually do that application to be in line with our sustainability principles? So kind of, many in the room are obviously working across all of these topics and doing some great work. And so the last thing I'll do is just sort of plug, if you're somebody already working in this area and kind of want to kind of meet others and further engage in the conversation, or if you're someone new to this area and are looking for entry points, there are a few communities I would encourage you to check out. One of them is my nonprofit Climate Change AI, which basically aims to provide a variety of kind of educational resources and entry points to those who are kind of both new to the space and those who are already working in the space. So we have, for example, a summer school and online tutorials, workshops to which you can kind of submit your work or kind of attend to learn about what's going on in the field, as well as kind of mentorship programs, particularly for those who are new to the space, in order to kind of help kind of develop workshop submissions. In addition to funding and online community and kind of various reports trying to guide kind of policy, funding, and research in these areas.
Hi,
And in
Priya.
addition,
sorry to interrupt.
Hi.
I know it's 6 a.m. on your side. It's getting close to lunch here, so if we could ask you to wrap it up 1-2 minutes. Thanks.
Absolutely. This is actually the last slide. So, and I just wanted to plug some amazing, Africa-focused AI for climate initiatives as well. So AfriClimate AI and GeoA Africa. I know Gilles spoke earlier in today's session, who I think are doing some really awesome work, both in kind of putting forth community building initiatives in this area, seminars, kind of research discussions, knowledge sharing, as well as doing some really exciting on-the-ground research in weather and remote sensing applications. So definitely encourage you to check them out. And kind of the closing thought I'll leave is that AI for climate is something that we together must actively shape. And I'm so excited to see this session with so many people kind of working together on this topic. So thanks so much. If there's time for questions, I would love to take them. And if not, happy to chat offline.
Thank you for the talk. Unfortunately, we are running on time and we will not be able to take questions. But they have your, address, email, contact, so you can join her by email. Professor Pia is very open, so we can chat with her either by LinkedIn or by email directly. So thank you. So now we're gonna move to the panel session. I know that we are very late, but sorry for the technical issue that we encountered during the morning. And yeah. Okay. So the panel topic is around how we can use AI to drive sustainable development in Africa. And it will be moderated by Mrs. Nadine, who just a few minutes ago shared with us a talk on risk. So Mrs. Nadine, you have the floor. Also, I forgot, Mr. Emil will, left us at 1 p.m. because he have some, he had talk, and also he got a lot of technical issues, so we are very late. And I hope that Mrs. Nadine will ask him some tough questions, and after that we can let him go. So you have the floor, you can open the section.
Thank you so much, Aurel. Testing. Okay, we're good to go. Okay, I think maybe just for some background for all of us and getting to know the speakers, I just want to go around and maybe let everyone introduce themselves and just give a few examples and just some insights for us as an audience to know how has AI affected the work that you do on a daily basis, and how in terms of also if that's relevant in terms of sustainability in South Africa and Africa. So I think I'm going to start with Chris. If you can introduce yourself, how does AI fit into your daily work? Yeah.
Thank you, Nadine. My name is Chris Kutsia. I'm founder and CEO of a company called Africa. Basically, we exist to bridge the gap between what corporate institutes want in AI and how it can actually be implemented within their organization, taking their context and their narrative into consideration and using their data.
Thank you, Chris. And then, so Emil, you work with weather stations and you work with them across the country. But how does AI fit into the work that you do?
Yeah, so good afternoon, everyone. I'm responsible for keeping everything afloat at Metos, which primarily looks after weather stations, weather data, aggregating those and making it available for, let's call it data insights. So the question is, how do we use AI? We use it in many ways, but first of all, I need to emphasize that you need validated data. That's where everything begins, and that's for any AI model. So much of my work goes into making sure that the input data is correct and validated, vetted, if you will. And then from there, we use AI models, we use machine learning, we do predictive and analytics, we do disease modeling, we do let's call it forecasting for the next week. We do the possibility of an outbreak of a certain bug. Those are the things. And then one of the sister companies that we work very closely use AI and machine learning to also help us make sure the data has integrity. If there are gaps, and there are gaps, they do happen. Nothing is perfect, but it's how we go about and fixing those gaps and making sure that they still comply. That's so AI every day.
It's very interesting. And Jean-Claude, so you're very much involved in urban planning and research, and I've seen some very interesting things about the flood modeling that you're doing as well as part of your research. So just in general, how does AI affect the research that you do? Is that sort of your core focus, or is it like just a tool that you use for a bigger project?
Okay, so my name is Jean-Claude. I am a scientific collaborator at APFL. I know there's many of our helpers today. They're also part of that institution. So in my background is actually I'm an industrial and system engineer, and the past couple of years, yes, I've been in the urban field. And I found it quite interesting because I don't know how many of us knows industrial engineers. We kind of can fit anywhere. So trying to find a way of integrating different aspects and putting people together and making things happen. So I think that basically where industrial engineers kind of fit. So if you want to choose another career, you should go for that. So yes, so we initially we developed a tool that did not integrate machine learning. We actually deployed it in Nepal and in Bangladesh. And the result we got was not bad, if I can put it in that manner. But when we deployed it in Malawi, we picked up some gap on what we actually tried to do. So the tool that I actually presented earlier, we actually integrated a ML model, and that gave us basically an edge compared to what we actually initially produced. So yes, it's something that we have discovered that it has a lot of value, and it offers us, I think, a better approach on the decision making and the planning. So yes, it's something that even in our lab, most of our research now is migrating towards the application of machine learning and artificial intelligence. So yes, it's something that we are now daily making use of.
Yeah, I really agree, and I think that it has a lot of potential to make a big difference in risk assessments. Also myself been involved in some flood modeling, and just the sheer data to scale something like that, I think machine learning can really be quite powerful to help in that regard. So Stephanie, you work at the South African Weather Service. I think in terms of what people are generally aware of at the South African Weather Service, we don't always know, that you are or might be involved in AI applications, or that some of your research projects might be involved in that. Can you maybe elaborate on how AI has been sort of affecting the work that you're busy with.
Yes, good afternoon. As Nadine said, I work for the South African Weather Service. So how forecasts are actually generally made, as some might know, this is actually physics-based numerical weather prediction models, and these are one of the most expensive computational systems. We also run our own high-performance computing system. So what AI started doing is it takes some of those expensive mathematical processes and it speeds it up. Especially when you go to your finer scale resolutions, like your cycling or your interaction boundary between the atmosphere and the ground, which is quite small scale processes. So now, instead of trying to resolve those physics and mathematically, you just try to do some AI. So it speeds up the thing, the whole process a little bit faster, which then obviously is economically better, and it's also the your carbon footprint reduces as well. But just a part of that is then together with the physics base, because you really can't just get rid of physics altogether, but you do train it on them, is then to, with the post-processing of the data, is once the forecast is made, is then to handle all of the data that's coming in real time. For example, what we're trying to look into is the season that we just had with the flooding to the northeast and then the fires to the southwest, is that how do the forecast from the physics-based models, how can the data from there then be interacted with the real-time data that's coming in to help assist with the early warning or with the first responders in real time, to tell them the fire is there, yes, but we're expecting the wind to change or the humidity to increase or something, and then that'll help with that discussion and interaction between what's happening at the weather service as well as then with disaster risk and the disaster management. But we need data that to go through all of that quite quickly and then also give you a probability. So it's not just a deterministic thing, it's what's the probability of things changing. So this is with that communicating. So it's all just for public safety and public health, but it speeds up the numerics quite a bit.
That's actually fascinating, and I can presume the data that you have to just compile and pre-process, and that's even before you start with the AI application. That's actually fascinating.
I think we calculate like 3 trillion data points per second.
Wow, that's a lot. Sure. So Emil, Stephanie also mentioned some of the the recent floods that's happening or was happening now recently in the past month or so. We briefly touched on it earlier, but a lot of the forecasting models differed quite a lot, on whether, and where the risk areas are actually going to be. So what do you typically do when you have to, let's say, communicate with farmers or stakeholders, and they might have one model, do you think that's something that AI can play a role in?
Yeah, so a very good question, and I had this explanation earlier that sometimes AI does get it wrong, and those who followed what happened in the Northeast would know that it was a system, and there were two kind of schools of thought about what that system was going to do and what the result's going to be. The thing is that that's why it's so important that you don't only rely on one input source. So that's the one thing. Your forecasting model has to be right, and if it isn't right, there's a lot of damage, a lot of distrust, which is probably also as damaging, because then people just say, listen, I don't trust the model.
The reputational damage.
The reputational damage. So it's very important that and I emphasized that in the earlier session, is that you have to have ground truth data. And there's nothing replacing that. So what we now can do, and some of those of you who were in the session would remember we said measure, analyze, and learn. if you don't have the data input to see where the model went wrong and why, you're still back at square one. So it's very, very important that you use several inputs. How do we communicate that to our customers? Everybody is on a mobile app, and the system then triggers based on certain thresholds. They issue the warnings, but it's obviously only the guys that have the app and obviously have access to that specific weather station. But I can say that the one forecasting model that we used were completely wrong, and that's just not good enough. So it does happen, and we need to fix that.
Oh, go ahead, John.
Okay, so I agree with Emil, because we also had similar issue. I also think that often we build these models and we think that based on the analysis and how we set it up, everything is fine. And often we don't really integrate the local context in those models. And I think that's key. In our work, we really try to bring in the community-based approach into what we do. Because once the community, they feel involved in this, they know better their community, they know better the reality, they know better when this type of rainfall and what comes after, and that helps you to validate your model. So as you are building it, you are involving the community, you are engaging with them, you are able to see as you are going through these phases where basically you might be going in the wrong direction or not. So that also helps you to calibrate your model earlier on before it is deployed.
Maybe just a comment on that. If we had a system or a network of rain gauges deployed that could in real time provide the feedback to the model, so that model in theory could real time see, listen, my forecast is out, and adjust. Now, I'm not a data scientist, I'm not a data analyst, I'm just a user of the output. But the thing is, this is real life, and it caused a lot of damage. So we need to get this fixed. But having sensors out there that could real time provide feedback is definitely one of the options that we should consider.
Yeah, I just want to touch on that. So that's what the Weather Service is doing, but we've been doing it on a statistical method. So the forecasters can know every hour, 2 hours, what was happening, or even the morning, how the model is out. So that brings us back to what AI is doing. That's not disrupting, that's just changing the field, is the sovereignty of a nation or sovereignty of a region. For example, you said the model was out. I'm not going to say which model that was, but the ones that we run in-house was better. So if there is a public-private collaboration, you probably would have gotten better information, because we also we run it every 4 hours. We update our forecast system, and it's a whole 3-dimensional system. So it's not just looking at the rainfall. It does, but that's what makes it so important to start collaborating with public-private and see what's happening, because we do have a lot more technical and detailed local atmospheric information and modeling that's been optimized than, for example, the global models that you get. Yeah. But some of those, like you said, is statistical. Hopefully AI will speed that up for us a little bit.
So one last comment is, if you have the data, then you can rerun the model and see, where did my model made a mistake or didn't use all the information that was there. If you don't have the data, you can't rerun the model. So that's why having those sensors, having the actual data, the density of the data is so important.
Testing, there we go. Yeah, so now I completely agree. I think especially in the sustainability in the climate space, because data is so important and fundamental to what we do. it's really important to have this collaboration between private and public. And I think something that sort of is complementary to that is also to have investment in, projects and climate projects, sustainability projects, and also with AI and, cutting edge technologies in mind. But I also think that sometimes that's not always, that easy to get through and to get buy-in from investors and so on. So Chris, I don't know if you can maybe tell us, because you've worked with a lot of big corporates and AI projects with them, what's been some of the barriers that you've seen and experienced when, talking to either a commercial client, possible client, or to an investor to get buy-in from them, and also to get them to implement it correctly?
So that's a huge stumbling block in the private sector. Corporates generally, they see the hype, they see both sides of the coin, the good and the negative of it. A lot of hype on AI is going to steal jobs, etc., etc., and they don't really get the overall view of what AI can actually implement. I think one of the biggest issues, in addition to that, is governance. A lot of corporates think that AI is an IT problem, and it's not. It's a business function, and it needs to be driven from top down. If you're not going to have executives buying into an IT strategy, an AI strategy, it's going to fail. So having said that, if you're sitting in front of an executive and he wants to implement AI, he wants to see return on investment yesterday, and it doesn't happen. A lot of the questions which executives tend to pose, the default answer is how long is a piece of string? There is no definitive answer to a question A, B, and C. And this is where context comes into play. You could have two execs in two different companies in the same industry with different contexts, different agendas, different strategies, etc., and their AI use case will be totally different. So I think there's an executive gap in terms of what AI can really do in the industry, and that gap needs to be filled by consultation with the guys, partnering up with public sector. You guys, the public sector, sitting with the bulk of the data. And I think the biggest gap and the biggest stumbling block is the executives are just misinformed, and they are misplacing it in terms of who owns AI in the organization. And it is the C-suites that own it, or that should own it, rather. So, sorry, you asked also about investment, sorry. I think because AI is so new globally, and even more so applicable in African context, where we tend to think that we're behind, but actually we are sitting with so much resources in this continent. We have the people that can do it. Investment tends to halt, again, with the how long is a piece of string question answer. What is the MVP? What will my return on investment be if we implement A? What will my return on investment be if I implement B? And what happens to the people? People forget about change management. And all those factors, they tend to not take into account when they are addressing the investable function of implementing AI. So there's just too many unknowns for executives right at this stage to make those decisions.
Yeah, no, that's very interesting and insightful. And I'm actually wondering, Emil, is it time? It's time.
Okay, one last question.
Do you see something similar with the farmers, that they are struggling to sort of accept and understand what AI can do for them and invest in it?
Fortunately, we have the young crowd that's coming in, and they are very much on top of new tech, and so they are driving this. We are very fortunate that the space in which we work, we have executives that understand the value, and they actively drive this process. But generally, if you look at the corporate farms, the mega farms, there we have open arms. I think the development work needs to happen where we can showcase the validity of the data, how we can help the subsistence farmers. Because there's a lag. But nothing stops us from introducing this data to them. I mean, it's on an app. It's on a smartphone, right? So, and everybody has got a smartphone. So it's really, I believe it's an education process, but the young crowd they are on top of it, you know, so it's the old grey guys that battles a little bit with AI. me excluded.
Well, that's at least, I think, one positive, that there are a lot of newcomers coming in that are embracing it. Thank you very much. We'll excuse you. Thank you, Emil, for joining us. But we'll still have some few questions that I'm going to ask some of the panelists still. So I also want to touch on early warning systems a little bit and what AI can do for that. I think in terms of sustainability, climate change, climate risk, this is very topical at the moment. And I also think that, as Stephanie also alluded earlier, it really helps with processing time. It can make decisions just a lot more faster and quicker. But I think it's sometimes easier said than done. So Stephanie, I want to start with you, but Jean-Claude, you can also just chip in if you want to, because I think there were some practical barriers here, especially in Africa and South Africa, because even if you have this information, how do you act upon it? And how can you make this piece of work that's amazing and that you had to invest in AI processes and that's maybe generated by AI, but how can you make that useful and practical?
So early warnings is again, so the World Meteorological Organization is driving this concept quite a bit, because the United Nations started an initiative called Early Warnings for All. So everyone is trying to catch up with that to make sure that every person in every country, in every continent actually do get warnings that will help save lives and infrastructure. The problem there is it's still legacy issues, and it's the implementation between like the old physics and the new AI-based systems. What we are looking into locally is to look more apart just from processing the data quite quickly, is then also language models, because of the different 11 languages that we have, is to make sure that actually the message comes across and it is gone, and also then the communication chain as well, because you have the main South African Weather Service, but you have to remember we are responsible for 56 million people. It needs to go everywhere, so it goes through the whole chain of national disaster management, then provincial, then local, then even...
I can imagine there's some delay there as well.
Exactly, so we're hoping that maybe some of this language or the integration will help assist them just with getting that message out quicker than to wait for that whole language or the telephone line to go down, that it gets, and then action can be taken quicker, because that's the whole problem. But then some systems are still, AI is still struggling with some systems as well, so you can't just really rely on AI, so we still need to make sure that the AI is functioning as well as the physics-based. Because if the AI is wrong, as Emil said, it can be wrong. But for us, who do we answer now? We need to go to government now and say, why were we wrong? Why? We need to be accountable and we need to explain what went wrong. So we have that little bit of extra pressure that we need to make sure that whatever we are using and how we are interpreting it and how we're putting it out is as accurate as possible.
A lot of model risk there. And Jean-Claude, can you maybe add, do you want to add anything to that from an African perspective?
Yes, so I think to just go back to the earlier question as well on the AI, how is it applied, or how can you make it to grow? I think there are two key figure here. Key figures I think we should maybe note. Just to know that less than 1% of infrastructure of AI around the world is in Africa. I think that's something that we really need to look into and say, how do we build AI infrastructures so we can promote it in the future? And the next figure is to know that only 3% of AI talented individuals are in the continent, and that's also not acceptable. I think that also shows that maybe our education system, we really haven't really integrated that key component of growth and development in our curriculum. So maybe something that we really need to look into as a continent. So as for the early warning system, yes, I do agree. But just to mention some of the challenges that we've been having, trying to integrate the early warning system that you build in a Western context and in the African community is not the same, you know. And I was presenting similar work in America, and a question was asked: how many people have smartphones? You know, it seemed ridiculous, but yes, it makes you to actually say to yourself, at what extent am I able to contextualize my solution to make sure that as many people as possible in our communities are able to have access to it. So I think above the ability of putting such system together, I think there is also that aspect that need to be integrated as well. So I think that's basically what I will add as well.
So I think you just remind me of something. The other problem, I'm saying it's problems, but it's not problems, it's just things to address, is challenges, is that obviously Google and Microsoft and all of these global companies are also now running their own weather models. So I know Google actually issued a warning to the north before the Weather Service actually issued that, which is actually illegal, because in South Africa the only authoritative voice that can issue a weather warning is the South African Weather Service. That means if you distribute a warning or something that's not from us, it's actually illegal. You can go and read it. It actually can actually do some jail time, but let's not go into that. But so the problem now is working together with them, because even for us, as the South African Weather Service, we actually represent the whole of SADC. So all of the 16 SADC countries, we support them with weather forecasting, and especially for Mozambique that really struggles. I mean, those poor guys, they get it at least 4 times a year. We are not allowed to issue a warning. We can just tell them, listen, severe weather is coming. We are not allowed to do anything for them. So we need to work with these organizations to make sure that there's one message coming across. It's one thing, because otherwise you're going to get public panic. Or people's not going to know, because like, oh yeah, you're putting out a warning, you're saying there's nothing, so that's why it's, so that's the other barrier or something that we need to work with AI as well. So you need to be wary of where the information is coming from and who's responsible, because Google might issue a warning, but if it's wrong, who's going to hold them responsible? No one. So if no one's going to cover the cost, if the first responders are going out, no one's going to. It's only us that can actually be held responsible. So that's one of the things for the early warnings or the warnings that goes out, is you need to be careful of where you're getting it from, and just double check, the legitimacy and the authenticity. But that's why we need to work with public sector as well, and the World Meteorological Organization is trying to work with companies like this to say that, listen, it's okay, you can make a forecast, but you're not allowed, you can't take the sovereignty away from that nation. Yeah. We've seen it now ourselves as well. So.
Actually, that's a relevant point. I think that the key to find a way of coordinating with relevant parties, even public sectors, even how do you call it, civil society as well, finding a way of integrating them into this. I think that can be helpful to save as many lives as possible.
So a controversial opinion on this, and I'm loving, you've particularly, John Paul, raised a lot of interesting facts. I think that Africa in its own right is in a very unique position, although only 16 of the 52 countries have got governing laws regulating sovereignty. it puts us in the back foot. All right, so brain drain is real. We all know it. And I do think there's a misconception around sovereignty, and it's not only where data where your data sits and where your compute happens. It's a lot deeper than that. It's the humans that are actually developing the systems. It's the governance. It's all these soft skills that are not taken into consideration. Everybody talks about data sovereignty. No one talks about digital sovereignty. No one talks about the individual that's actually developing the model. The West and the East are coming into Africa very aggressively. And as I mentioned earlier, we've got so much skill and talent in this continent, and not the ability to upskill them. It's great sitting in a room full of students and professors and scientists, etc. But we should, as a continent, we should start developing those skills from ground roots today, if not 2 years ago already. The power of the power of AI in this continent sits with the 8-year-olds today, and with no identifiable means on how to actually get them to the point where they could all be sitting in a lecture hall like this, talking about AI. And that's a huge risk for us. We're going to be taken over by the West and the East. Don't quote me on that.
You touch another thing that's actually what we're struggling now with, is to say data sovereignty. So we say that we are a sovereign nation. We want to go to cloud, we want to, but national law, we are not allowed to put our data on any server that's outside of our country. So whatever cloud system there is, it needs to be within our borders. Otherwise, we are not allowed to put our data onto the cloud because it's sovereign, it's our data, and we can't put it anywhere else. So it's a barrier because we don't necessarily have the infrastructure here. There's one company that can do that for us. There's one.
Cassava. Cassava. Liquid Telecoms. They didn't pay me for saying that. So
even if you are right, I'm not going to go. But there's only one, and that's a problem because it limits how we can help the organization, how we can collaborate internationally, or how we can do anything. Is because with the public sector, public funded, our data is not allowed to leave our borders.
So again, digital data sovereignty is a hot topic, right? Where your data is stored. I'm not going to mention names with regards to hyperscalers. The crux is that digital sovereignty is the next fundamental pain point. Like, where are you actually processing your data? Now, I can tell you for free that if you're processing your data on one of the hyperscalers, you're actually processing it in Ireland. So, yes, government is addressing data sovereignty, albeit quite slowly. But we don't know to which context they're going to be to which extent rather they are going to be taking sovereignty into account. I think with the rise of AI and physical GPU, I mean, a GPU is an expensive piece of equipment. To put it into context, the H200, which is the flagship, is $60,000 US for one GPU, and you can't just buy one. You asked me about investment earlier. How do you justify buying 2 GPUs for 120,000 Rand, let's call it 2 million Rand, and you haven't done one line of code yet? So, that's an obstacle as well. Government needs to come to the party. There's an organization called Cassava Telecom, Cassava AI, building a huge hypercluster here, an AI factory. I think that's the right step in which we are going. But that's, again, we're only addressing sovereignty and digital sovereignty in South Africa, not the rest of the continent.
Yeah. Just want to test, there we go. So I think we're out of time, so I want to end with one last question, and any one of you can put your hand up for this. If you could see one change in the next, let's say, 5 years to build like an Africa-led sustainable future for Africa, what would that change be?
Education, edutech. We're actually in partnership with another university in developing an AI application for kids between the age of 8 and 18, so that when they matriculate, they could have basic understanding on how to code in Python. I think that in terms, when we're speaking AI, that is something that we need to change, because that is transformation. That is transformation in its absolute core. That's what I want to see.
That's where I think I completely agree with that. Okay. And with that, I would like to open the floor for questions. I'm not sure if there's some of the staff members here to help us.
Test. Thank you so much, guys. A very interesting panel, and it's really interesting to see different perspectives, you know, from business world, from academic. Thank you very much. It was very insightful. We do have one question. Time for one question. Ladies first.
Thank you so much. Hello, everyone. Great insights being shared. So just a little bit of background maybe to my question. Because we know South Africa and load shedding and sometimes data connection and having to have AI, is there like somewhat thinking that has been done to sort of like look at a solution that is also reliant on manual processing maybe or reading of data? Because load shedding is an issue. Access to data sometimes to effectively access your AI solutions with maybe high data, like has that been considered? And also there is agri-smart tech. It's one of the innovation ideas that was submitted in UNISA that lady's doing some great work there. She's actually doing the sampling and reading of soils to basically assist like your subsistence farmers and basically the farming field. So I don't know, there's someone that said something, Christian, earlier on, so I just thought I should mention that. But what are we doing to foolproof a day in which, you know, we don't have data or electricity? And again, because COVID also happened, we sort of like saw how whatever possibilities that are there for like business solutions and things that we are working on. Thank you so much.
The shorter the better, guys.
So I just want to quickly say, from a public operational centers, we have failovers that has failovers. So we can bump over two systems that actually addresses load shedding or downtime. So we don't just run one.
So I'm no engineer. Only 2 weeks ago found out what the terminology brownout means. So we're actually working with a data center that's got 20 years worth of data, and they are specialists in backup power to data centers. And they've built over 200 data centers on the African continent. Now, with the rise of AI and the power consumption of GPUs, etc., obviously the workloads will intensify. So we're working with these guys to pick up trends in terms of when there are drop in electricity, and a key focus on load shedding, believe it or not. And the intention is to make sure that they can actually, the number one priority is to make sure that they can protect their backup power. So when do they start implementing backup power before, when is the right time to implement backup power when ESCOM announces load shedding, to ensure that there is a stable, stable electricity in the data center. And we will be doing that through proactive triggers. They've got a NOC, a network operating center, where instead of rule-based alarms, it will be AI-prompted alarms based on the data that they have for 20 years. So I know the data centers are looking at it. How long it will get there? How long's a piece of string?
So just to add on this, I think on the sustainability point, until we get serious on key investment on infrastructure, I don't think that we're going to succeed on, if we really think that AI is the future, we cannot get away from the fact that we need to invest on infrastructure. At the moment, we only 38% of Africa, they have access to electricity or internet connection. This type of figures is, you don't find it anywhere else. I think we really need to go back to our policymakers and tell them, look, we think this is the future, and if there is a need of cutting some budget that is unnecessary, let's focus on this. And I think that will also drive other aspect also.
Thank you very much, guys. We do have 30 seconds for one question.
Yes, I'm going to just go quickly. Orson Scott Card says in the end of this game, you're going to, once you beat them, you want to beat them forever. So that's how I see AI. So I don't have a question. My only question is if you disagree with me, say so. Yes, you build an AI model, it's 100% accurate. It doesn't depend on the data. You've bet it, you've made it for all the scenarios. It doesn't depend on load shedding, it doesn't depend on data. You can plan forever. You can say if you disagree with me.
Wow, very bold statement from Jan. Jan will be also doing a workshop on Thursday, guys. So you will be seeing similar. Wednesday. Yes, sorry.
Also a COFSI student, because he's a COFSI student. As a COFSI student, we can take that conversation offline.
Okay. Please, guys, very short.
Hi, I wanted to ask, as we know, AI is definitely the future, but the thing is, people are always focusing on the models, developing more accurate models, but then they're not developing on the technology to go with the models, like technology which will allow for more accurate and precise future predictions, like in weather patterns or flood or other natural disasters. Another thing is youth, people. AI is generally a new genre. So normally when people are going to attend universities and colleges, only like a handful are dedicated and focusing on like studying for AI, because they know where the future is. But majority of students still go into more popular subjects like engineering or law and accounting, and they don't even bother focusing on AI. And my last point is, what are governments, how are they gonna be managed to be convinced to invest more in infrastructure and employment and education in regards to AI?
Is there one volunteer to take this bold question?
So on the technology part, I think there are existing technologies that we can make use of, because you can start from somewhere, you know. So for me, I don't think there is a need to develop new technologies, just the need to develop skills that allow you to make use of what is existing. Then if you are able to develop new one, then that's best, that's good. That's where entrepreneurial spirit comes in and people make money out of it. So I think for the continent, if I have to speak as a continent member, we need to learn first how to make use of what is existing, what has already proven to be accurate in other places. Then from there, we can now adapt it to our realities and see how do we make it accurate to suit us. But otherwise, if we have to be thinking of building new one, I think it's a bit of a waste of time if we cannot use what is existing.
Thank you very much, guys. Please, a warm round of applause for Nadine, Steph, Jean-Claude, Chris, and also a thought for Emile, who unfortunately had to leave due to technical problems that made us have a delay. In the same note, we apologize for the shortened lunch break. There is good news, though. The afternoon is on time. It's everything on the website the agenda on the website will be followed. So please, guys, you can go ahead and have lunch. In this room at 10 past 2, we have Lili Paemka, starting in this room. In the WSS1 over there, we have Mihir Patel, a great American entrepreneur. In the room WSS3 over there, we have Dino Resch. So please, guys, go ahead, check the website. It is updated, and we are starting on schedule in the afternoon. Thank you very much. For speakers, please follow Farah for the lunch area, and startups, communities, and other attendees. We have the veggies option today. So please, you can accommodate on the left-hand side. Thank you very much. See you later.
2, 1, 2, 1, 2.
No, 2 minutes.
I guess I'm not. Maybe I catch up. 1, 2, 1, 2. Mic check 1, 2. Hello, hello, hello. Seems like it would be better to run off of the system itself. You're absolutely right. Let me get that sorted now. And if you're busy, I can just leave it in. I'll come back. 100%. Let's do it now, and then at least you won't forget it as well. And then there's something else. Maybe 1 minute break. I want to see if you have the web page running in the background. Thank you, and I'll be back.
Yeah, she's gonna help. Okay.
How many people do you need?
I think like maximum 2, and maybe in the other rooms as well. So 2 here and 2.
Which one? 3 or 1?
Yes.
Which one? 3 or 1?
Where you don't see people, you can go just to help with the mics and questions. It's only for the questions. Okay. So then you can use it. Okay. So when we start the questions, you just get the mic from here.
You say how many people this side?
Here 2. We should start in the 2 minutes. Yeah, we're just bridging people over. Okay. Je vais leur donner le micro.
faudrait que 2 ici. Les autres, on devrait les passer dans les autres salles, ils n'ont aucun micro.
Non, juste un seul.
On a juste un seul ici.
Non, un seul pour les speakers.
Et un seul pour les questions.
Pour le moment, je pense qu'il y en a un autre transfert.
Ok, ça. Ben, je vais appeler les autres.
Non, en fait,
je reste là.
5 minutes. Sorry? So just 5 minutes and we'll start.
Well, I would prefer something where I can be hands-free. Okay, so I'll put some open door. Okay, and I'll be here as soon as whatever session's ending, I'll be here to get mic'd up. Okay. Thanks. Okay. Thanks.
We're just bringing people over, so 5 minutes. Si tu veux, je peux genre vite fait aller. Non, parce qu'il y a Camille il y a Camille qui est en train de faire. We just want to for a few people to come and we'll start something. Small delay. And then like, is there like a specific like kind of Emile, commencer. Ouais, il est plus sur là, je pense que c'est that one's auditorium too. On va commencer. Jermaine, are you ready? I'm ready. Okay, we'll start. Okay. Quoi? Ils arrivent. On va commencer là. Hello everyone. So we're going to start now with 15 minutes delay, sorry about that. So my name is Sarah and I'll be hosting this session this afternoon in our broader AI in healthcare track. We have a really exciting lineup this afternoon. So we'll have 3 talks followed by a short break, a keynote, and finally a panel to end the day. And so let's dive right into it. So Africa has the world's largest genetic diversity, but the thing is it's still underrepresented both in genomic data and in AI-driven solutions to address that. So today's speakers and session will focus on how to tackle that gap and how to develop solutions that are adapted and personalized for our continent. Let's get started with our first speaker. So Dr. Lily Paemka is a molecular geneticist at the University of Ghana and Deputy Director of the West African Genetic Medicine Center. So join me in welcoming Dr. Lily Paemka.
Okay, thank you. This one, all right. Thanks, thank you. So hi everyone. Okay. So first of all, I'm going to talk about genomic diversity and personalized medicine. So I'm a molecular geneticist, and why are we having this talk? Why am I even here? You know, because my space is in molecular genetics. However, this talk is really important. It's to help set the stage for the rest of the talks coming up. Why is it important? One, genomics define disease risk, diagnosis, and treatment response. Like she said, Africa is underrepresented, and it does have serious consequences for precision medicine and AI. So, like I said, I'm going to do some basic genetics. So you take a human, we are made up of billions of cells, right? You go into the cell, and then you have the nucleus, where you have your chromosomes. In humans, you have 46 chromosomes. Now, these chromosomes are the DNA that is packed. But then, it's what a DNA is that you have this chromatin, which is DNA that's wrapped around proteins called the histones, and then it's packed tightly into these chromosomes and then into the nucleus. And this DNA, the very basic units are the nucleotide, A, T, C, and G. Now, most people forget that we have other DNA in our cells. The mitochondria actually has its own set of DNA. There's mitochondrial DNA and do have an impact on the rest of the organisms. So the DNA provides, so actually, hi, wrong slides.
Just gonna switch computers really quickly and we'll be back in 30-40 seconds.
Perfect. Sorry about that. Oh, okay. It's not showing? Oh, okay. It's going to do it. Okay. So I already mentioned this. I already described the DNA. And so basically, what does a DNA do? It provides instructions to make proteins and basically help development. So you have it, the DNA molecule, that comes in codes. And each one codes for an amino acid, and then you have a string of that, you have all these proteins that are expressed. What's the role? First of all, it can show how humans evolved, the evolutionary conservation between species, among species. Here you have an alignment of protein from different organisms, but I can see there's a lot of similarity. It also gives instructions for development. How do you start from a zygote to a whole human being? It shows the basics of diversity. No two people are the same. It shows the genetic basis of disease as well. Single gene mutation, you have sickle cell. You have a whole chromosome, 21 Down syndrome. You can also have multiple mutations in a cell that can lead to cancer. So what's genetic diversity? It's a natural genetic variation among individuals and populations. So that's why we're all not exactly the same. We have these variations in our genome. The most common one is called SNP, single nucleotide polymorphism. You see these three individuals at the same location, they are different types. And most of them contribute to the differences among the individuals. We have structural variations, deletions, insertions, etc. Regulatory variation, where certain genes may be expressed, not expressed, different levels. And they are controlled by DNA elements, including what we call epigenetics. People talk about genetics, they don't talk about the regulation. Why do you think you're made up of 200 types of cells when you have the same DNA in every cell? There's a way that DNA is regulated, and it's called epigenetics. You have these markers on the DNA and the histones as well. They're able to shut off genes in certain tissues that are important and turn it on in different genes. Now, we are 99.9% identical. It sounds like a huge number. However, we are made up of 6.4 billion bases. The DNA, haploid is half of that. So if you merge 0.1%, talk about millions of differences. Now, this variant, first of all, can influence disease susceptibility, while someone get diabetes and not another person. The way you metabolize your drugs can be influenced, and even the immune response. This is an example that I always like to give. Even during COVID, which is a viral disease, somehow there are certain loci in your genome that influence how you respond. So this loci picked up in genome-wide association studies where those who had severe COVID had variants in those particular loci. I had a master's student group patients along the ABO group system, blood group, etc. We found out that those who had blood group O were less likely to have severe COVID. Funny enough, Africa and some indigenous populations have the highest percentages of blood group O. It partly explains why we didn't die as much from COVID. I mean, there are several reasons. Anyway, so let's focus on genomics in Africa. We have the longest evolutionary history. And so there's been time to accumulate all these different variations in our genome. In fact, we diverged from the chimps about 5 to 6 million years ago. So globally, we have the high genetic diversity. Now, there's an opportunity to identify novel genes, novel loci that underpin some of these traits and diseases. So when it comes to identify complex genetic traits, which are traits that are influenced by genetics and the environment, we are the most likely population to help identify that. Why? First of all, humans evolved in Africa and then migrated to the rest of the world. You had smaller populations moving out from about 100,000 years ago. Because a subset, we have the majority of the diversity still on the continent. So this is a study that was done where they looked at 650,000 SNPs and microsatellites in about 938 people. And what they show, if you look at the function of diversity from Africa all the way to the Americas, diversity drops. There's another interesting thing that was found a few years ago. They deeply sequenced 910 people from 51 populations and then looked at, the sequences. Now, when they aligned it to the reference genome that's used currently, there's extra 10% of bases that had never been seen before. And some are actually in gene coding and protein coding regions. So what does it even matter here? So some of these variants you see in Europe, you wouldn't find them in Africa. And most of the data is heavily Eurocentric. If you develop all this therapy from Eurocentric data, it's not sometimes relevant to us. And then disease-associated loci can vary across populations. So you can have the same disease, but the genetic drivers might be different. Same drug responses can be different, even within a population. And so I can't talk about genomes without talking about the Human Genome Project. It was the biggest to date biological project in the world. 20 labs, 13 countries, $2.7 billion to sequence the human genome for the very first time. That's when we found out that we had up to 22 to 25,000 genes, and this has accelerated a lot of work in the biological space. It gave rise to genomics and then bioinformatics, which is required to analyze such data. It ushered in the omics era. You're not just looking at DNA, you're looking at epigenomics, you're looking at RNA transcriptomics, proteomics, protein, and metabolomics. Now, what's genomic medicine? It's an emerging field of healthcare using information from people's genome to guide diagnosis, prevention, and treatment. So it differs from the traditional treatment where most of the data is population-based or is just generalized. But here they look at your genome and are able to determine what kind of disease or that you can suffer from. And so other than genetics, the environment, the kind of food you eat, lifestyle, clinical context are all taken into consideration. So one of the things that can be done with that is risk assessment. With your genomes, you know whether you're going to develop cancer maybe in the next 20, 30 years, things like that. So you're able to plan treatment, etc. Gene therapy, clearly your genome is required to know the kind of mutation. Now there's therapy for sickle cell disease, and also other targeted therapies that are targeting specific genes or specific gene products. Pharmacogenomics is one huge area. We have so many genes, over 54 genes that are drug metabolizing enzymes. And your response to drugs is determined by the drug metabolizing enzymes. There's a lot of variations. Sample have adverse drug responses, etc. So this doing of pharmacogenetics, or the genes that are probably metabolizing a particular drug, will help you with the dosing, etc., and avoid that. There are so many gaps, unfortunately, in Africa. 2 whole decades, actually a little bit more, after the Human Genome Project, the genomic data we have still lacks diversity. There are a lot of unknown genetic and environmental risk factors. it's hardly studied in Africa. And a lot of these variants that are found are classified as unknown. They're not properly characterized. 78% of the genomic data are in Caucasians, only 2.4, actually less than 3 that are from African populations. These are just a few known databases, and I've highlighted in red how little of African genome is represented. Now, there's a thing. Traits, skin color, whatever, and diseases do present with ethnic and racial variations. So you can't always copy and paste from European populations. Even with African Americans, where we share recent, relationship, they're not fully representative of us because they're an admixed population and it was a much smaller population that moved. So certain drugs, for example, efavirenz for HIV that was developed on a Caucasian background, doesn't work well for most Africans because there's a variation in that drug metabolizing enzyme that is up to 50% in Africans, but it's less than, it's about 10 to 20 in Caucasians. So there's this need for population-based study. I give you, there's a lot going on. There's an example just from my lab where we did some whole exome sequencing in women with breast cancer. And out of a relatively small population size, we found novel mutations, 20 pathogenic variants, and then you're familiar with BRCA genes with breast cancer. We saw new variants. And other than the genes that we felt were driving the cancer and tumor, we also had genes that are involved in metabolizing drugs as well. Now, what are the consequences of underrepresentation? Variants are misclassified. Because if it's not in the reference genome, you're not quite sure what the impact is. You can't predict risk factors properly. Clearly, the clinical usage is limited. And of course, the inaccurate diagnosis. So where does AI come in? AI, I'm preaching to the choir here, is based on data. And genomic data is really needed for AI to come up with this relevant models. So there's a lot of bias at the end of the day, and doesn't, it's not relevant to the African population. But it cannot infer risk, factors that it hasn't seen before. So some of the models end up being poorly trained and are not relevant to us. We know genomic diversity will improve AI. So there's better variant discovery, better fine mapping of disease, models. But the cool thing is, once you use it, it's not only relevant to, Africans. We are what we call the mother population. So it's going to be relevant to other populations as well. And that's going to be essential for equitable precision medicine. Now, what needs to change? We need more African genomic data sets. We need African-led research and governance, interdisciplinary collaboration. I guess that's why I'm here. This is not my usual crowd. But then you have AI, data science, all of that. We all need to work together. And then so we can integrate molecular genetics with AI. Now there's hope. There are a lot of initiatives that have started. I'm going to give a few that I'm familiar with. Of course, I mentioned my lab, although relatively speaking, it's a much smaller sample. But the H3 Africa, which is a 10-year NIH project, sequenced a number of populations around the world and across different conditions. We have the Sickle Gen Africa from my center, where we have the largest population of sickle cell cohort for disease modeling. Now we have Yamachi Biotech. I'm also associated with Yamachi Biotech. And we are currently sequencing cancers across Africa. Because of the diversity, you can't just pick from one part of the continent. There's a wide range of variety. And there's this audacious one, 3 million African genomes. Actually, the PI is he's from somewhere in Cameroon, but he was in South Africa, Ambrose. And they have some preliminary work. They've showed extensive capability to actually run this project. It's quite expensive. We're talking about $4 billion to run it. And there are several others. I saw one that's 110K genomes right here in South Africa, and there are several others around the continent. So, I guess I was rushing, so I have some time left. So, the opportunities ahead, not all is lost. Building AI model from diverse genomic data to improve robustness and fairness and reduce healthcare inequities. Now, precision medicine without diversity is not precision, it's actually exclusion. Thank you.
Thank you, Lily. So now we'll have 5 minutes of Q&A. Feel free to raise your hand, and once you have the mic, just stand up and shoot your question.
Hello. Can
Hello.
you hear me? I'm Clayton, and I don't know much about biology, but I'm learning quite interesting things. So I heard you talking about the differences between our genetics, as Africans and people outside. I just had a curious question as someone who knows about these things. So the question is, since you say our genetics are different and we may have different reactions to the same drugs, does this also apply to vaccines? And maybe as an example with COVID-19, were these factors considered when it came to the distribution of vaccines, like Pfizer or Johnson & Johnson, since we know that they were discovered in countries that are outside Africa?
Yeah, so absolutely, it makes a huge difference, but they did not consider that. However, as part of a study with my MRC group, as well as people in the biochemistry department and WAGBIP, where we measured responses to the vaccines that were given, and found out that, in a nutshell, Africans had a higher response to the vaccines than other populations. So that's an example. Although they didn't take that into consideration, we found out they responded differently. Yeah.
When you say a higher response, do you mean in a positive way?
Yeah, positive way. Yes, okay. A positive way, absolutely.
Thank you.
Yes, it's not always positive, but this was a good one. Yeah.
Yeah, Lily, thank you so much. So, obviously very interested in this topic. I wanted to understand, since there's so much to do, right? We're saying that 2% of the genetic information is actually captured compared to what is available. How do you propose we prioritize the search for materializing this potential? So say we are doing whole genome sequencing right now, we have a bunch of conditions, we know what are the blockbusters in European markets. Does this guide any of your research, or do you have maybe a different lens based on the disease burden with respect to specific geographies within the African continent? Thank you very much.
Thanks. So there's so many ways to prioritize. First of all, knowing that there are a lot of sequencing initiatives around the continent, I think one is to consolidate, all these variations that have been found. So there's a recent, for the 3 million genomes project, there's a preliminary work a few years ago where they sequenced about 420 something people, and they saw 3 million different variants. And so starting off with that, I think one of the things that needs to be done is functional work. We need to understand what these variants do, because at the end, if it's not in the reference genome, it can't properly, characterize them. I mean, you can rely on in silico tools, but you can't properly characterize them. The next thing is to do in silico tools, but I need to prioritize by looking at the ones that are more common in our population. We also can think of, disease-based research. For example, I talk about the sickle gen project is on people with sickle cell disease. I mean, even though some of these focused disease, you can actually still use them to, characterize other variants, other conditions. You can also do that. But ultimately, the good thing is, if we're able to sequence more people, we can get to figure out what the spread of variations are. Another thing too is, we can't sequence from one end. We need to try and cover, much of the continent. So H3 Africa came out with an array, a SNP array. So it's an array that is to identify SNPs across the genome. The SNPs, the array that was being used clearly wasn't too good for us because it had limited variations on there because it was developed off a Caucasian background. But with H3 Africa and all the sequencing they did, we were able to develop a new SNP that better represents Africa. It has way more SNPs than they've seen before, and some that are population specific. Now, another thing too is targeted sequencing. The studies have been done where they found genes that are, underpinning certain conditions. So that has been done quite a bit where they say, okay, BRCA, for example, causes breast cancer. So one cheaper way to now go and target, sequence BRCA And the most variations that have been found are in black people. But unfortunately, that's a bit myopic because you don't see the new genes. And like I said, even with the small study we did, we've seen novel genes and whatnot. So we have to we try to be as comprehensive as possible, because at the end of the day, the data is not only relevant to our population, it's to others as well. And so, yeah, that helps the answers the question. Yeah.
I think we're done with questions. So thank you so much. You will have time later at the break. Thank you, Lily, for the insights, and thank you all for the questions. Next up is a true regular at AMLD Africa. He's the head of AI for biomedical sciences at the university UM6P in Morocco, and he's the living proof that once you come to AMLD Africa, you keep coming back. Help me give a round of applause for Dr. Tariq Daouda.
No, that's not that. That's not that one. Someone change this. C'est quelqu'un qui a changé les slides. C'est quelqu'un qui a changé. Non, 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 j'ai rajouté tout à l'heure, je les ai rajoutés ici. Je les ai rajoutés là. It's okay. Where's your laptop? Yeah, right. Well, can I send you a link?
Yes, absolutely.
Okay, give me an email, I'll send you the link, or WhatsApp, I'll send you the link and then we can just...
Or should I give you a USB? It's faster.
No, no, it's alright.
But it's okay, he has
Or if you have any...
A USB. What? Is it USB-C, Mac?
Do you have WhatsApp? No, no, it's yeah, just open your WhatsApp, I'll send you. Non, il y a quelqu'un qui a envoyé un message de la présentation. Non, ils ont donné une version. Give me WhatsApp.
Just put your number.
Can you put your number here?
To put with international
Yes,
code?
yes, please.
Yes. Plus is better.
Plus is better.
Yeah, just plus, and then you can go. What's your name?
Jermaine. Jermaine, can I type for you?
It's a mine. It's a nice name.
Thank you very much. I think it's French. And then I'll give it to you.
Phone number from Morocco.
From Morocco. Okay.
That's the one.
Yeah.
That's it.
That's the one.
Yeah. You can just click on the slideshow.
Okay. Can I download it so that you can use the clicker?
Oh, the clicker will work.
Oh, it will work.
Yeah,
Oh,
it will
sure.
work.
Okay.
Yeah, that's
100%.
super easy.
Oh, there we go.
Hmm? Good. Hello.
Hi.
Good evening, everybody. How are you doing? Good. I'm amazing. Okay, everyone. So the goal of this presentation is, as you can see, it's titled AI for Biology Beyond the Hyped. And the subtitle is Transformer-Free, Diffusion-Free, and NLP-Free. I could have put LLM-free. I scared someone already. And the reason why this is the title is because I want to convince you guys that what you hear about in AI, actually the problem we have is not data. I'll come to data. It's not necessarily data. It's not necessarily the computational power, but it's the domain knowledge. It's how you apply basically AI to whatever you want to apply AI to. And it so happens that biology is very complex. And you can't just take an LLM and then slap it on a biological problem and hope it will work. However, if you know the issue, if you know the problem, you can then design models that are adapted to the task. And yes, so let's start. As a use case, the African genetic diversity. And you can see this is like some movements of population. And here you have an idea of how, a theory of how, for example, these populations have mixed and admixed together. And you can see it's very, very complex because you have these different populations and N is Neanderthal. So it's what we call an archaic human being. And you see the African ghost population? These are potentially types of hominins that have disappeared, just like Neanderthal. We don't know about them. But they probably have had an issue, an impact on the current genetic background of the current African populations. But also we have admixtures from Europe to Africa also, which is also very, very interesting because we have, it's not because Neanderthal didn't appear in Africa that there's no Neanderthal genes inside African populations. So it's very, very complex. And use case I will use Morocco because it's the country I know best. And you can see the geography of Morocco is very interesting because Morocco is kind of an island, as you can see. So there's a big mountain that looks like a banana. So sea, ocean, and then the banana mountain. It's called the Atlas. And what you can see on the figure over there is that this created some pockets of population. So we have like very interesting genetic backgrounds in very, very small populations. So this is otherwise known as consanguinity. But it happens. Also, people do move around, and as you can see, so this is what Africa looked like 10,000 years ago, and people could move around the Sahara Desert, and that actually created some very interesting things. As you can see, again, if we look at Morocco here, you have the maternal line and you have the paternal line, because we all have a father and a mother, and we can trace the paternal line following the Y chromosome, and you can trace the maternal line following the mitochondrial DNA. And what you can see on the Morocco maternal line is that it's mostly Europe. I mean, 25%. And then you have North Africa, and then you have sub-Saharan West Africa. From the paternal line, it's very interesting because you get East Africa. How did that happen? We don't know. But that's the data. That's what the data says. Then Eurasia, and then Mediterranean. Makes sense. But East Africa is a mystery. Good. So, what I want to show you now is that we actually need better methods. And the reason why we need better methods is because methods are applied to the data. And methods have a compounding interest, which means if you develop a good method, then you can apply it to different types of data. And we also need cost-effective methods, because transformers and diffusion models are very expensive. Good. So these are the challenges we have. We baselined This is a general challenge in biology in general, but more so in Africa, so the baselines are usually lacking, just because we like to sequence diseases, and we rarely sequence the healthy states. So what do we compare? Well, we have to what do we compare it? We have a problem in precision and integration, because if you want to sequence like the efforts that Lily was just talking about, it means that it's a multi-group effort, which means different people, different places, pitching in together, which means we have to be able to integrate all this data without erasing the biology. And interpretation is very important. We need to be able to interpret the models, and deployability, and that means we need something that's small, smart, and cost-effective. Because the more so, the more we can deploy these models. So a big model is okay, but a bloated model is not. And I think that most of our models today are actually bloated. Good. So for precision and integration, so this is one of the works in my lab by my student Fatem Zara. And basically the idea is very simple. You take 1, 2, 3 data sets or more, and you make a big data set out of them. And then you get your insights from the big data set. This sounds like an easy problem, but it's actually a very hard problem. Because if you sequence some people over here, and then you sequence other people over here, the most variance you will have, which is the biggest signal you will have, it's actually not the biological signal. It's the machine and the person that actually sequenced. So you need to be able to remove that so you can get to the biology. And for this use case, we had cancer patients at treatment, and some of them were okay, and some of them had very, very, very intense autoimmune diseases. And we want to see why. So the way we tackle this problem is very simple. We took the current state-of-the-art models. We didn't try to make a new one. We took the current state-of-the-art models and we decided to make them better. This is like taking a car, opening the car, and then changing the engine, basically. And by doing that, we want to do this. We take the original model and we make it better in 2 dimensions. So one dimension is biological conservation, and the other dimension, White-Tick-Bao, this is censored by Camille. He's giving the next talk. It's data set integration. And what we get is something like this. You see the red and the maroon, they're overlaying with the purple. We don't want that. We want them to be separate because they're different cell types. And you can see that this is normal SCGen, state-of-the-art model, and this is our version of boosted SCGen. They're separated. Good. So this is just the benchmarks, cell types, like how well we preserve cell types versus how well we basically integrate, and we beat the state-of-the-art. So just doing my due diligence. We don't care about this slide. And this is what we found. So you see the cluster number 7. That was completely missed by the people who originally published the data. And the reason why it was missed because they didn't have the right methods to find that cluster 7. That cluster 7 is very interesting. This is what you see in the heat map over there. It's a very unique cluster. It doesn't cluster with any other clusters. And it has 2 features that are very important. The first one is cytotoxic. Cytotoxic means cell killer. It means these cells kill cells, which is autoimmunity. And also cycling. Cycling means they're dividing. So very dangerous. And this is the trajectory inference, pre-treatment, post-treatment. What happens to these cells is they start growing, and then you give them steroid because you want to save the person, and they come back. And this is what you have here. So this is exactly what we would expect. And when you look at the important genes, you see granzyme K, which is a gun for killing cells, and then CXCR3, which is a gene that's linked to autoimmunity. So we actually found the reason why these people develop autoimmunity. Which was these cells. They had these cells. So now we can screen for these cells before giving the treatment. Good. And also it's cost effective. And we invented a new type of layers that we call multi-compression. And we benchmarked multi-compression against attention, like multi-attention, we just like transformer layers. And you can see that on CPU, we are way faster. This is MC. And even on GPU, we are faster. So this is even cheaper, way cheaper to run than standard LLM. It's frozen. Nice, thank you. So this is the second one. This is baselines. So baseline, the idea is we don't have baselines for a lot of the projects we have. So the idea is, what if you could use generative networks, models, to actually make these baselines, again, without using transformers and diffusion models and things like that. So the use case here is cancer cells. So cancer cells are very interesting because they do whatever they want with their genes, almost. So they can have usually, like normal cell has 2 copies of each gene. So in that case, don't turn this to me. So in that case, they can have more than 2 copies or less than 2 copies. So what we did is we generated basically new cells as if every cancer cell had exactly 2 copies of each gene. And by doing that, we're able to better predict survival. So as you can see here, Kirk is kidney cancer, Luad is lung cancer, and you can see the curve clearly separating. And if you're into biology and cancer, you know that mTOR is what we call a canonical pathway, which is super important in cancer. And we can even better predict the survival just looking at mTOR. So this is huge for cancer survival. Same thing here, these are different data sets. Original is red, our thing is the blue, and we can predict survival better. Good. Boom, same thing here. Nice. So the next one is interpretability. So we want a model that can interpret the biology and give us some insights. And this is one of the models we developed, another generative model. And the nice thing about the generative model is it creates basically disentangled independent factors. And this is what you see here in this heat map. You see it's mostly white because we want it to be white. And this is the competition. It's not white. So we're better. Good. And this is also like me doing my due diligence, so we're better. So we're the red ones, always at the top. Good. And what's interesting about the fact that we have disentangled, which means like different independent factors of variation, is that we can play with these factors of variation and we can start doing some very interesting predictions. So for example, as you see, like this is on liver cells. So the top is the original and the bottom is the prediction. Very, very similar. Other thing, sorry guys, is castration. But it's mice. So when you castrate mice, you get certain cells that become another type of cells. And then when you reintroduce androgens, which is basically testosterone, they go back to what they used to be. And this is what you see at the top. Correct prediction of the movement this way, and correct prediction of the movement that way, after we introduce androgens. Same thing here, but this is like a more fine-tuned view of it. And you can see how the observed and the predicted cells, basically, what you should see is the blue and the orange cells like doing this, as predicted. Good. And this is also something very interesting. So these are the most important cell types of the immune system at the bottom. And these ones you can observe. If you take blood samples from people, you can observe these cells. However, you have cells in between because cells divide and they specialize. And these cells, they're called progenitors, and they're very hard to find because they're not as numerous and they're not everywhere. So this dendrogram that you see here took decades of research for immunologists to be able to define it. SC Disentangle was able to do it in a few hours. And just being trained on these ones, the cells that you can actually observe from the blood. So that's it. Thank you.
Thank you, Tariq. Any questions? Yeah.
Thank you. Hey, Doug. That
Hey.
was impressive.
Thank you.
The application for this, and talking about real world applications, where would you and how would you apply this? Thinking about the world is always on the move, right?
Yes.
And I'll tell you pretty much my plan, or the plan of my group, in the sense that when we're looking at telehealth, where you have a doctor who is able to talk to a patient online, with obviously assistance of these kind of analysis, where do you see that linking in? Because I see that as a way, look at our continent. The biggest challenge that we have in Africa is also how many doctors, 100,000, how many doctors per population.
Yes.
Now, it becomes part of the problem where you are unable to, be as a doctor available to each and every patient as much as you would. But how would we then plug this to be able to solve that problem using telehealth or remote, kind of a assessment? For that
Yes.
matter? Yeah.
Yes. So all these methods are based on samples. So you still need to get your samples to the doctor. However, what these do is that they actually help. These methods can help the doctor make better prognostics. Because one of the big problems we also have is in Africa we're using the biomarkers. Like a biomarker is just a marker, but the biologist adds bio to it, but it's just a marker. So we use biomarkers that have been defined on other populations. And we know that these biomarkers are not applicable necessarily to the African population. And we know that anecdotally. It's like me speaking to, like if you talk with clinicians, they would tell you, oh, this marker, yeah, sometimes it works, sometimes it doesn't work. Sometimes it works, sometimes it doesn't work, means it doesn't work. Yes. So so we actually need this kind of information, and these type of models can help you get this type of information. But what they can also do is that if you can create a pipeline, for example, for sequencing, just like what Lily is doing. If you can create an efficient pipeline of sequencing, then you can feed these results into the models, just like what we do. Basically, it's a cancer pipeline, for example, and then you feed it into the models, and then you can do 100,000 patients in a day, and get precise prognostics and precise diagnostics for each one. So that's how I would see it. Yeah. Thank you.
We have one question over there.
Hello. Great talk. Very interesting.
Thank you.
I'm hoping that I can also ask you this question. I wanted to ask Lily, but it was on the availability of data, genetic data across Africa. I believe that in other continents, sharing data has become, an easier thing throughout the labs. I know that right now there are many labs throughout Africa that are starting. But what do you think about, the collaboration between these labs in sharing the data? How are the current systems, and what do you think we can do better if we're not doing well in that case?
Okay, that's a very good question. I think this is a question we should answer both with Lily, because we're both sides of the same coin. She actually generates the data, and I use the data, but I can see when the data is not well generated. So I'll give a quick answer, and then I'll give the microphone to Lily. I think we should ramp up the effort, that's for sure. But also we should do it in a way that's standardized. So that means basically the quality. There should be some quality insurance that's basically the same all over the place, because otherwise the data becomes unusable. And I think that's what we should do. And also, we should do something like what they're doing with the human, human single-cell atlas, for example. Like we could have a human, like an African single-cell atlas or an African genetic atlas. And that's basically different groups have a standardized method of sequencing, and they all put their data in the same platform. And then that same platform also has a standardized bioinformatics pipeline inside of it to integrate the data. And that makes it really easy and usable, for example, PhD students who want to keep going and keep working on this data. So I think maybe some consortium effort like this would be very usable for us.
All right, so I totally agree with him. When it comes to data sharing on the continent, we are doing terribly. So when it came to, for example, so we did a study looking at transcriptomics of airway epithelia in COVID. My PhD student worked on that. When we generated the raw data, we couldn't find enough raw data to compare it to. The only one we found was in India. However, we still got a good results indicating that immune genes were more regulated in our population versus another. But we couldn't access a lot of the raw data. And like he said, I think we have to have a concerted effort to deposit our data. If it comes to NCBI, if it's sponsored by NIH, for example, you're obligated to, deposit it. We deposited out, did we? No, it wasn't NCBI. But we need to have something like that so that we can, share data. But at this point, I don't think we are doing very well, unfortunately. If you're not part of a consortium, for example, you don't have access, yeah.
Thank you, Lily.
Thank you, Tariq and Lily. That was our last question. So next up is also a special speaker for us today. He's actually an alumni of AMLD Africa, who's now upgraded to a speaker. He's a founding engineer at Isospec Analytics in Switzerland, an AI-driven startup developing molecular solution for drug discovery. So a round of applause for Camille Serrouchny.
First, I'm gonna check if this works.
Third time is a charm.
Okay, so yeah, thank you for the introduction. And first, I want to acknowledge the amazing efforts that this young committee is doing. Just for the audience to understand, they are embarking on a journey where they're organizing an AI conference in the country most have never been to. So please, just a round of applause for the organization, please. So, all right, let's kick this off. Oh, I was about to. Anyways, I can just start. Right now, I mean, you've seen, we've laid down the foundation of genomics and what it means and why is it important. We've discussed a bit how AI can contribute to basically improve the insights we can get from this data. And my role here is now to talk money. So I think this is going to be interesting for a lot of you guys, and I want to kick this with a story, and the story of a Nigerian founder, very famous. He's a doctor called Eneo Bong from a family of scholars, both well-educated. He studied cancer biology, but also human genomics, and he was very fond of using and harnessing genomics data, coming from this big gap of 2% representation. So you have stories it's a bit all over the place, but it's fine, showing on the left-hand side two drugs, one for osteoporosis, the other for cholesterol. Both drugs were coming from discoveries on mutants that were specific to populations living in Africa. For romosumab, it was actually an Afrikaans mutant, and for the other one, it was not so specific. But anyways, what I want to tell you about is that this startup was basically focusing on trying to harness this genomic diversity into research insights that would power novel pharmaceutical developments. And the story was beginning really well. Like, you look at the fundraising story, seed at 4.5 million, then Series A at 15 million, only 1 year after, then Series B, 25 million. So it's altogether, they were funded 45 million to take on this journey that we just laid down for you, harnessing African genomic diversity in order to build up the drugs that would actually work on us. Amazing story, right? So let's see how this unlocks and invades. So why am I also talking about AI? Well, I mean, coming from the space, originally I see every new model release normally within a few hours. I mean, at first it always feels like it's just yet another model, just the hype. But then you start hearing this guy, like Sanofi CEO, saying that basically AI is going to take on pharma and that they want to have them in all over their verticals. So AI is being taken very seriously in the pharma space. This picture was taken from Recursion official website. Recursion is one of the biggest tech bio companies using AI, and basically look at the stack of layers that they want to take in: genomics, proteomics, transcriptomics, and so on, all into one single model of biology. Isn't that crazy? That's how the biggest pharma companies today are thinking about AI. So if by now it's not so clear, AI and biology, or AI and biological discoveries, are becoming the same thing. Yet another example that this is the case. You guys all have been hearing about agents, right? So again, one example that of an AI development or AI trend or AI technology, call it how you want, taking into pharma. And these are two companies coming from Y Combinator, so like the biggest startup accelerator in San Francisco. They are basically AI or agent native. So I mean, if you haven't understood by the slide, AI, pharma, same thing. We okay? All right. So now, why are we talking about this here? Actually, WITS University is at the forefront of genomic discoveries, and you have the Sydney Brenner Institute here, led by Professor Michel Ramsey, that are really contributing to the field in terms of the research. So like the fundamental science that is being done. They're looking at the impact of our genomic into discoveries for mental health, for cardiometabolic health. And I mean, if you guys are students here, make sure you send in a CV or a PhD application to this lab. They're doing amazing job, and we're super happy to be here and talk about this here. Especially Dr. Vivian Chebby just got a grant 5-year with, I think it was 400,000 budget to go about the, what's it called, Deep Gen Africa, so focusing on mental health and metabolic diseases. So why me? Very quickly, I mean, this was mentioned, involved in the biotech, tech bio ecosystem. Shout out to Isospec bringing me here, and I wrote a complete article on the topic I'm presenting. So that's where this comes from. So essentially, defining biotech, it's very hard. If you don't know the words, it will mean nothing to you, and if you don't know them, the definition will be too simplistic. So what I want to do here is just to give you an idea of like what's a traditional tech bio versus a biotech. So tech bios are really like, you can think of it as the software play entering pharma. Basically, you have a technology, you build up lab capacity, and you use this AI stack to power discoveries that will enable traditional biotechs that are focused on one single compound or potentially one single disease or one single pathway, depends on the biotech. But usually what the biotechs do is they develop assets. So in one word, biotechs, they focus on developing one drug. Tech bios, they try to have a platform horizontal, and they try to enable drug development. All right. Now this definition is starting to be a bit fuzzy, and if I wasn't hidden, you will see the famous Spider-Man meme. But essentially, biotechs and tech bios are becoming the same thing because of one reason. If you're a tech bio and you're so successful, you should walk the talk. So it means if your platform technology works, you need to show assets in clinical development that are potentially worth billions. And if you're a biotech and you're not tech-enabled, what are you doing? So these are becoming the same thing right now, and we're at the point where it's becoming very, very, very hard to distinguish between the two. I hope you guys still follow. Okay. So what's interesting for Africa is now we have the playbook. We now have the playbook to develop a successful tech bio. And I want to walk you through this playbook, because if you guys become entrepreneurs and want to go for tech bios from Africa, you should know this. And I will come back to 54 Gene's story. It always first starts with the data. Lily's work, stressed by Tariq's, you need to have some special data. This will be the moat of your business. This will be what powers any of your discoveries. Then you need to have your platform, so basically your model. You need to have your AI team in place that is able to basically extract whatever insight that is coming out of it. And then you need to put all of this into something, an asset. So it needs to go in this direction. Don't start with the assets, or the AI start with the data, and go that way. And usually, the first part of the playbook, our tech bios have got it right. This is just a quick refresher to tell you where the bottleneck is right now in Europe. Like, what's the problem that all these tech bios that have all these resources, what's the issue? They're all failing in the later part of the funnel. So if you take drug development from the very hypothesis to actually testing it on humans, which would be the phases 1, 2, and 3, you can see here the probability of success. It's getting lower and lower as you increase the phases. So it's costing more to test because you need to recruit humans and organize all of this. This is very expensive. And also, we're discovering that all humans are very different. There is a lot of heterogeneity going on. And because of that, the translation from whatever we tested on animals up until models is failing. So tech bios in Europe, they didn't get this right yet. So this is the opportunity. There is an opportunity here to make this different. And for me, there's two ways of doing it. I've called it, one is the bench side. It means that basically the data that you generate in an experimental fashion somehow needs to be closer to humans. So either you take small organs from humans, you grow them, and then you start testing compounds. This would be an idea. Or on the bedside, you make sure you are screening the hell out of a population, genomics, metabolomics, whatnot, in order for you to build your moat and then go into your business. This still makes sense? This is fairly technical, so I'm impressed. Anyways, why is there an advantage? Or still why is this something to be done in Africa? I mean, many reasons. I like the genetic advantage point, where basically we're discovering more and more how we could potentially respond better to vaccines, as we discovered, or the other way around. But still, there is an opportunity to be harnessed, and there is a place for it. What do we have in this continent? Well, we have infrastructure that is being built. We've talked about efforts of H3 Africa, the TACA from Yamashi, scientific hubs with efforts like Lily's lab. We have AI talents. I mean, this is a conference that bringing AI talents. There are other conferences here. Big tech are coming. We have more and more pharma partnerships. So Roche, Sanofi are funding research efforts in Africa. So there is something that is happening, for sure. And there is a flywheel effect going on, and you can build on top of it. All right, so back to the money. Yamashi Biotech is actually, we have one of the leadership team, or at least advisor with us, Lily, so she's very familiar with their work. But essentially, they got the first part right. So it's, again, a tech bio. They are focusing on genomics. They are building the complete cancer atlas, focusing on Africans, and they're having some strong partnerships with big pharma companies. And I mean, I think everyone here knows Roche, right? So this is one clear example that there's something going on. Biocertica, South African companies, working with sorry, this is Revna, by the way. So again, this is a Ghanaian company working with AstraZeneca on genomic panels for cancer. Again, signs of it. So I'm just showing that you have companies, you also have incubators going on here. So Illumina is funding a bunch of companies with this. So if this was not enough of a tell, you guys need to get involved and to do it fast. Okay, so back to 54 Gene, right? They started really well, 45 million in funds raising. Isn't that amazing money for African startup? Well, it didn't really go well, actually. So what happened, and I'm just gonna show you what happened. So basically they closed in 2023 after raising 45 million. First they started laying off a bunch of people. Then you see final closing, and this is from actually the Y Combinator website. So what happened? Well, basically, and also this is very recent news, but those guys are going to court because they have now a biobank with around 300,000 samples, and they're battling on who's going to get access to those samples, actually, in order to power potentially a new tech bio startup. So what happened? Basically, in 2021, COVID hit, right? And this was a very juicy opportunity for anyone being in the field to go into diagnostics, actually, and start doing panels and start doing PCRs and whatnot. This was very lucrative. at that time they were raising their Series A. So like they were showing it to investors that they were able to put in 20 million revenue, and they've basically put in a lot of money to do that. They've hired 100 people. They've opened a bunch of labs across Ghana, across Nigeria, and I mean this was massive, right? Well, basically what they did is they were short-sighted. So they got the first part of the playbook really well. They understood that data was the first mode. They've started the research, but in research, it takes time to basically understand what to leverage, what to put into what is worth going and pursuing into an actual compound. This takes time. And there was now a juicy opportunity to show revenue to investors. They took it, and then all of a sudden, they changed the DNA of the company. And it's very hard then to go back full on research mode, not having a long-standing framework that you're following. So basically, change of plans, killed the company, hurted our brand, because now, imagine how it sounds, right? 45 million of investors' cash completely drowned into an African startup. It hurts all of the ecosystem, by the way. And why am I right in saying all of this? Because this company, so Syndicate Bio, is the new company of 54Gene founder. So after the craziness unfolded, he reflected on this playbook. And he founded another company where this time he focused on AI. And he now needs to battle for access to the samples he raised all that money to collect. So if that wasn't so clear, data, then AI, then compound. Minimum 7 years to 10 years vision. This would work. If you go for the quick buck in the midway, you're going to lose it. And the opportunity is humongously big. Investors don't put $45 million into a company if the market is not humongously big. Keep that in mind. So I want to close on this. So if you guys are Marvel fans like I am, you can imagine that Thanos is like TechBios in Europe, and basically Tony Stark would be TechBios from Africa. Thank you very much. I'm looking forward to questions.
Thank you, Camille. Any questions in the audience?
Hi, Camille.
Yeah, here we go. So my question is, you had mentioned, that's kind of a sad, scary story, and you had mentioned the potential negative impact on investment for maybe the continent, but certainly within the biogenetics field. Can you tell us something positive? What's the next step? Is there a green field that you see? How do you see something growing from what looks like a tragedy?
Yeah, for me, the early signs are the positive thing. So how the story unfolded, this was 2023, 2024, and these are very new news. So this comes from this year. So basically, what the stance that Yimashi is doing, for instance, so they're taking their time. They're really focusing on building the infrastructure right. And when I say infrastructure, I also include data, meaning they make sure that they're getting the right partnerships, the right exposure, the right scale for their data collection. Because again, in order to discover something meaningful, you need to have a breadth in the data to power actual insights. And for me, this is very positive. I'm also, something I didn't mention, and thank you for the question, is also so because this is B2B. You have also moves B2C with Biocertica. This is a South African company based in Cape Town. They're basically selling genetic diagnosis tests for like general health. But there's a very interesting spin because if the story 23andMe means anything to you, those guys started really well. They've gone bankrupt because I think, in my opinion, they raised too much money too fast, but that's a different story. But still, the way that they're being saved right now is through their assets, and the actual asset is not the execs of the company, but actually the data that they collected, so the consumer data. So for me, there is a world where Biocertica makes a spin, and becomes B2B and leverages all their data in order to power insights using AI. So for me, those are the positive signs I'm seeing for the ecosystem, and we have some in like 2 hours flight from Johannesburg. I hope this answers the question.
Thank you. There's one more question over here.
Question.
On the right.
You said this is an opportune time for people to get involved in tech bio. So how does one get involved? Like what communities or places can they get more information about this, and what research? Because then I myself like have experience in AI, but I don't have any experience in the medical side, whereas I also know people who are involved in medicine, but they have no idea about the technical side and the computers and the AI.
Thank you very much for this question. Gentlemen, can you stand up? What's your name? Terence. Okay. Terence, you're exactly the kind of person I want to get a question from. So essentially what you should be doing is throughout this talk, you now have discovered the field you potentially didn't know about. We've told you what to do with it and how it can allow you to make money but also benefit people. Your hat is the AI hat. You need now to find other people to convince of this mission. And you can get people around you with other skill set. You could be the AI guy, you can go find a biologist, you can go find something that is more business oriented, whatever. You form a team. Once you have that team, you start looking for the resources. The first resource you need is data. So you go and you talk to research labs that are getting that data and maybe don't know what to do with it. Because there's a lot of research going on in the continent and even here, just here in South Africa. Once you get access to that, you can pitch in some AI projects, discoveries. You basically show them that you can deliver. Once you do that, my friend, you have a highway in front of you.
Okay, thank you.
Yeah, one more question, one last question from the audience.
Okay, thank you so much for the presentation. My question is, it's more like what kind of conversation should we be having? Because I saw a clip on social media where the would I say House of Parliament was asking a founder who is involved in genetic data, like, okay, what is the consumer's consent? Like, how do you handle these data privacy issues? And if at all, what kind of conversation should we be having such that people feel safe knowing that, okay, organizations are harvesting this data for the prosperity of the country, not like tomorrow they're just going to sell it off to somebody and, you know, what's in it for me and things like that.
Yeah, I think that's a very good question. And I think that's also why there is a big opportunity to do big stuff here in Africa compared maybe to Europe. So in Europe, we're looking at a landscape that is very regulated for some reason, and there the concerns are coming before even the opportunity. So like you can think of having the idea and they're gonna slam you already with the regulation, and it's a big topic going on in Europe at the moment, and it's also one of the reasons why the US is a bit ahead in terms of technology and considering Europe as just regulators. But if we come back to Africa, one of the issues that we're having, and also that is explaining why we don't have that much clinical trials going on at the moment, is that people are a bit scared of getting collected, whatever that means, just for blood or just, they're a bit afraid because they don't understand. And there has been, COVID was an accelerator in this regards because it allowed people to understand really quickly that, okay, there was a pandemic. In order to solve this pandemic, we need to get to those centers, and there's going to be intervention on us, but actually it's going to be benefiting us all. So we're witnessing more and more a change in mentalities, and this is also explaining why now we have more and more clinical trials being organized. Now, onto the anonymization part of your question, we're looking here at massive amounts of data. And this data needs to basically, as it gets collected, it's aggregated and anonymized. So the more data you have, actually, the higher the anonymity and safety of your people. So you can think of it as like if we start doing a questionnaire in this room, the more people we have, the harder it's going to get to make sure it's actually you who answered. So there's a flywheel effect, basically. you start with changing the mindset, and then you collect more and more in order to ensure the safety, but also the power of whatever you find. Because there's stuff that in biology, in bioinformatics, they talk about effect sizes and power. All of this comes from the sheer size of data that is powering the insights you're extracting. So, I mean, everything is pointing towards getting more data, and it's happening. It's just a matter of making sure it's also within commercial application insights, and that was the nature of this presentation.
Thank you. Actually, we still have room for one last question. Is there? Yeah.
You guys are draining me.
Hi everyone. Okay, so lately my work involves cancer and computer vision. And where I come from, I read from a newspaper article that our health data, the ministry gave our data to a particular company okay, I will not mention which company it is. So in a case whereby the government doesn't trust you with such data, say maybe I have a tech startup back home, right? And then I approach this ministry and I tell them, you know what, I need some data, this is what I want to do, and propose an idea. And then they decide not to give it to me, but prefer giving it to those outside the country. How do you go around that? How do you convince them that this is what you're bringing onto the table for them? Because they tend to trust the startups or the companies outside of the country, and they don't trust the startups from within local startups. So yeah.
I'll try to answer the question in all angles I can in order for you to be able to have an impact when you come back. So first, I can completely understand that, and if you look at the likes of 54G and Yamashi, those were actually like local people from the countries, but that were trained abroad or had some sort of specialization abroad that brought, and also professional experience, so that when they came back, they were actually in a position to talk with officials and also convince them of their effort. So I can completely understand that the conversation with officials can be hard. So kudos to you for trying. I would say that maybe going for the data that is behind the government wall is not maybe the fastest way, and I don't think that it's the only data that you have available. I think what you, in my case, and as I was advising this gentleman right there, Terence, you should actually look for more independent research labs within universities with a PI that has some flexibility on the data and it can be open to doing more of the preliminary work. Because at the end of the day, what you want to get to before talking with the officials or government people is credibility, right? If it's not going to be throughout seniority, if it's not going to be throughout foreign experience, it has to be throughout traction, value that you have already generated. So you need to generate that data before you start engaging and having those conversations. And I would actually go and generate that value first and then engage second. I hope this answers the question.
Thank you so much, everyone. Thanks again for our speakers. So now we're going to take a short break, and everyone should be back here at 3:50 for our last part of the day. So we'll have our keynote and then our healthcare panel. So let's just give another round of applause for all our speakers.
Peut-être que ça va être dehors. Ouais. You liked it? Hey? You liked it?
Yeah, very nice.
What
It
are you
speaks
using?
really well.
Yeah, you see. What is this?
It's my business card, and then I got this from somebody today.
Nice.
You're gonna
connections,
making links.
Yes.
Nice, nice. Ah, c'est là, c'est là. Ah, tu vois, là, on a bien fait.
Is he inside here? Yes, just okay, that's all. Wow.
need to have the mic from the start. Thanks.
Say that again?
You have around 20 minutes for the presentation.
And then 10 minutes for
And
talk.
yes.
Yeah.
And you can see the timer there, but she'll be the one pointing towards you and
Okay,
giving
when
the
you're doing this,
indication.
I'll stop.
Yeah. And she'll also tell you like 5
Like
minutes.
10 minutes, 5, 3, 2, 1.
Perfect. And you'll be sending it. Okay, perfect.
Ok, donc 20 extraits.
Ça, c'est sur mon téléphone.
Chargé, 10. Yes, it's 20 minutes and then 10 for the questions.
Question? Ok. Il faut les ramener. Elles sont juste là. Il faut juste que quelqu'un m'aide. Enfin, il faut juste qu'il y ait des mecs qui m'aident à les ramener. Oh, sorry. You want to charge? Sure. Is it the lightning? Ah, yeah. Give me your phone. I will find a charger. No, this is. You have the new iPhone.
Hello, everyone. I hope you enjoyed the sessions and the interlude. My name is Sarah, for those who weren't here, and it's with great pleasure that I'm hosting this last session of the day. But the real star is standing next to me. It's Tom Laurie, a former Microsoft executive and a powerful and impactful voice in the global discussions on the AI applications in healthcare. So please help me in welcoming Tom right now.
You know, I'm a techie, but it would help if I turned that on. Okay, we're going to get started. We're going to jump. I'm going to do 3 things in the next 30 minutes. 1, I'm going to give you a perspective on AI generally, and then some thoughts on Africa. 2, we are going to talk about AI in health. 3, I'm going to do what I call 20 in 2, which is to say I'm going to take 20 years of learning, of working in advanced analytics, and I'm going to try and condense everything I learned that you might want to think about into 2 minutes. And all of that is set up for a really great panel that's going to follow. So with that in mind, let's just jump in. First of all, AI perspective. Here's the premise I'm going to put forward. AI gives us a once-in-a-century transformation opportunity, possibly a once-in-your-lifetime opportunity that will not be any better than anything you will see in your entire career. Now, I say that based on the fact that economists talk about something known as general purpose technology. These are things that come along once every 50 to 100 years. Unlike other tech innovation, these things are rare. So I want you to think about things like the printing press, internal combustion engines, electricity. When those things came on the scene, they changed everything: how we live, how we work, the very fabric of society. I believe we're on the early stages of a similar transformation with AI, which gives everyone in this room great opportunity if you choose to lean in. So a lot of the tipping point came in the fall of 2022. All of us were there, where all of a sudden things like large language models and Gen AI came screaming out of the research centers and onto Main Street and our mainstream consciousness. So 2022 became the year of generative AI. We often measure tech by adoption rates on the time it takes to reach 100 million users. So these were the fastest things known to humankind. I was shocked when TikTok hit 100 million users in less than a year. In the fall of 2022, ChatGPT went from being introduced to 100 million users in 8 weeks. Nothing in the history of humankind as a product, as a movement, has ever gone that fast. I think it really makes sense when the smart folks at McKinsey say we're going to experience more technological progress in the next decade than we have in the past 100 years. I believe it. It's already happening. We're all witness to it, and we get to choose how to relate to it. So when I look at that, I work with a lot of advisory clients. I do a lot of conference talks, and frankly, there are a lot of health and medical leaders that are freaking out over AI. And I can't tell whether it's AI itself or, frankly, they're freaked out over the velocity of change it's causing when it comes to how they work and practice now and how that's going to change. So when I bring all that together, I really do believe that Africa is potentially an amazingly great AI hub and incubator. And again, you're here hopefully because you believe the same thing. I think African innovators will be those who create AI solutions that address not only the local needs, but I think you have a very good shot at really being able to play out innovation at global scale. So let me back that up. I mean, maybe you already know all of this stuff, but did you know that Africa has 6 of the world's 10 fastest growing economies? Combined GDP of $4 trillion by 2030, your population is growing, and what's really fascinating to me is Africa has the youngest population of anywhere in the world. And I don't have time to go deep on anything with 20 minutes, but I can tell you, I believe that the youthfulness of your continent is a great factor when it comes to innovation. And it's better than many of these other countries. I think the youthful Africa plays to your favor when it comes to innovation. So it's not just my view. Coming out of Davos last week, Bill Gates and OpenAI committed to the first tranche of $50 million coming into Africa to help use AI to improve health. The goal initially is to say they're going to direct $50 million towards primary care in up to 1,000 clinics by 2028. So that's a lot of money coming in, getting ramped up fast. And if nothing else, if you're an entrepreneur and you follow the money, that's not a bad start. So how is AI changing health and medicine today? I'm shifting gears. We don't have time to go in depth. I do like full half-day boot camps on things like this, but I'm going to talk about a few things. So there's something I've talked about before, and the concept is AI and what I call data whispering. So all of the things we do in health and medicine, from x-rays and lab tests, and all those things that we're trying to get information and make decisions on, every one of those things have been telling us all kinds of things, whispering things that heretofore we've not been able to hear, see, and use. AI gives us the ability to see and do so much more with what we're already doing. So I look at things like the common chest x-ray, the highest volume procedure as far as images go in the world. And what we're finding is with the use of AI, data whispering, a single chest x-ray can predict things like tenure, heart attack, stroke, and risk of cardiovascular death. In some cases, better than the tools we're using separately to try and determine those same things. We're seeing increasing use of what's known as AI-driven voice biomarkers. I can take any 30-second snippet of you speaking and risk rate you for the propensity of things like depression, dementia, Alzheimer's, PTSD, all just from the voice. And then Google's doing some amazing work with just sound biomarkers to be able to take a cough and diagnose so many things with just those sounds. I'm fascinated by what's happening in the world of ophthalmology. A quick story. It was probably 15 years ago. I was part of a support team that was working with a brilliant group of data scientists and ophthalmologists to say, can we take a picture of the back of the eye, the retina, and use AI, then a vision API and some machine learning to look at patterns in the retina to determine or diagnose diabetic retinopathy, leading cause of blindness in the world. And back then, it was a camera about the size of that podium, lots of heavy lifting on math, and they were one of the first to be able to say, yes, we've demonstrated that you can actually use machine learning and AI to diagnose diabetic retinopathy. So today, when you go to the eye doctor, they take a picture of the eye. That's commonplace. But here's the thing, back to data whispering. What we're finding is those same images give us the ability to risk rate and diagnose the propensity of things like cardiovascular, neurological, and many other systemic diseases. So if you just think about that alone, instead of going in for all of these tests, the things we can determine by just having AI look at patterns in the retina of everyone's eyes. So we're at a point where we've got a whole new specialty field called oculomics coming forward because of AI, which is the science of analyzing ocular data to identify, diagnose, and manage systemic disease. So think about all the things we can do with a retinal image going forward. So let's build on that. So FDA recently came out with approval and clearance for fully autonomous AI to detect diabetic retinopathy from any handheld camera. So let's think about that. And first of all, I believe we already live on what I call the planet of the apps. I mean, think about, usually I have a drum roll there, but think about everything you do in your life when it comes to that smart device. So maybe you've heard it here first, but I believe when you take everything I just showed you, in the not too distant future, I predict there's going to be an app on your phone. You'll be able to take a picture of your eye, and it will produce clinical grade data on a host of conditions that you may want to pay attention to. So if we look at that example alone and say, well, how would that play out with the diversity of the geography and the people of Africa? So imagine the most rural areas today, someone's got a smartphone. And imagine connecting that in urban areas. But when I look at what's happening in health and medicine, it's not where we are today, but it's looking at these technologies and extrapolating where will we be in the next couple of years. So, just wrapping up on that in general, why health and AI matters in Africa. Bridging the healthcare access gap. When I look at all of the data, whether it's nationally or some of the countries within the continent, your ratio of physicians and nurses to citizens, I mean, frankly, it's the worst of anywhere in the world. So imagine, the ability to take those precious few clinicians and leverage and extend them through the use of AI. Huge opportunities that we're already seeing. Scaling public health, the ability to bolster public health in Africa, whether it's urban or rural, is huge. And then all the things on improving decision support. And the previous speaker was talking about the importance of data. And data, AI needs, feeds, and thrives on data. But I'm imagining not just data sets that are generic, but the development of data sets that are specific to African populations that can then be used on everything from treatment to getting out ahead of predicting the next things where health resources are going to be needed. So here's where we're going to go to the 20 and 2. And I look around the room, and it's been fascinating to spend the last 2 days meeting many of you. But I look around, and you're a proxy measure for this thing of Africa having the youngest population on the planet. And so I've been at this a while, and those of you who are still in school or you're just getting started on your trajectory, these are the kind of things I wish I would have known about when I was getting started, like many of you are. So the first thing is this. Done right, AI is not about technology. It's about empowerment. It's empowering you and your customers or the people you serve to be better at the things you care about. As simple as that sounds, and I get to work with organizations and clinicians around the world, there's a huge difference in your trajectory based on whether you start AI initiatives as a technology initiative, or you start them saying, this is a tool that allows me to work differently and empower people to be better at the things they care about. Huge difference. Happy to talk about that later if you're interested. The other thing is the two words I use the most in my advisory work, my speaking, my writing are the words done right. It's a prerequisite for achieving value at scale. Having said that, as your provocateur today, here's the thing. Most people, when they start out using AI as an individual practitioner or as an organization, they don't start out doing it right. They start out doing it wrong. That's not a criticism. I want you to think about the process and art of mastery. So you've decided to take up a second language, learn a new software, foolishly take up golf. Do you get things right the first time? Every time you start out on that journey, you make mistakes. And there are many organizations and some colleagues of mine who love to write articles on how this or that failed when people tried to use AI, as if it's a negative. Every time you fail, it's not a failure. It's informational about what did I learn? How am I going to do it differently? Thank you. So, it's okay to make mistakes. It's what you choose to do in treating that as a great learning opportunity. We were having this conversation earlier with one of the people who did this part of the startup pitch. Tech is easy. People are hard. And I'm not suggesting technology is necessarily easy, but in my experience, you can develop the best IP, the best machine learning algorithm, you can start a business, and if you don't pay attention to all those things on creating adoption and a glide path that creates value, no one cares about your IP. And what's interesting, at least in health and medicine, there are studies that show for those organizations in the provider, payer, pharma space that have been investing in AI had done the right things and they look back of what the impediments were, number one with the bullet when it comes to driving value at scale was resistance of the workforce and AI behavior change. I'm going to do a call out to Blaine over here. He's got some great thoughts and an organization trying to focus on how do we work on workforce upskilling. Because most humans, you know, if you don't understand something, if it frightens you, typically your reaction is resistance. So how do we lower the resistance by upskilling every knowledge worker in every industry? And then don't be afraid to be different or tackle hard stuff. And if some of you feel like your ideas are kind of wacky, it's like, God bless you, you're probably going in the right direction. And then doing things that are hard. Africa has challenges. I look at the infrastructure, I look at some of the things, and I think there's a great talk tomorrow on overcoming some of this infrastructure challenges. But it's like, you know, take those as great challenges. And does anyone know the story of DeepSeek out of China about a year ago? So China, you know, America's in control of all of the supercomputer chips and NVIDIA, and as Americans we say, well, we don't want Chinese, you know, companies to have these high-end chips, so we ban them from going into China. So there was a startup called DeepSeek. They said, you know, we got all these things that we can't use. We're going to create a company and look at, can we invent a new AI model to kind of replicate all those things that groups like OpenAI is doing? And they came out last January with this model that basically replicates most of what OpenAI does. They did it at a fraction of the cost, the amount of data they trained, the amount of investment, and all of a sudden they proved that with low-level common variety chips, they could overcome those challenges they had in China. So if a startup can do that in China, well, why don't we do the same thing when it comes to all of you smart people saying, well, let's take what we have in Africa and figure out how we're going to spin up our own models. Okay, I'm going towards closing, and would love to get your questions and comments. So anything else you'd be thinking about? And the answer is yes. Here's the thing I want you to think about. AI success will come to those who think, work, and lead differently. And it was interesting listening yesterday to some of the pitches and some of your questions. And it's almost like there's a shyness about you. It's like, you know, you're young, you're starting out, but if you've got good ideas, you've got good ideas. And in many ways, where you are positions you better than someone who's been at something for 20 years. They're stuck in the ways for how they do things. This is the time to do these things. And I'm going to close with a story. I'm looking around. There are one or two of you that were actually around that will remember the story. The majority of you, though, weren't born. So maybe you saw this in an episode of the History Channel. So when I was at your level, I was just coming out of the university, and there's this brand new technology called cell phone technology. Oh my God, you could make and receive calls without being tethered to a hardwire. So 1980s, that brick phone cost an average of $7,000 US. It had a battery life of 20 minutes. But if you had one of those, you thought you were as cool and sexy as American movie star Michael Douglas. Are you guys old enough to remember the movie The Matrix? It gave us our first look at what became known as the flip phone. I was a junior hospital executive at the time. I thought that was so cool. I would purposely walk into a medical staff meeting to make a call just so I could flip that out. It was just so cool. So you know, these were the early stages. It took 20 years for the tech titans to battle it out to say who's going to win the cell phone market. And this is a cover of Forbes from November of 2007. Nokia ended up with a worldwide monopoly in the cell phone business. Across the world, they controlled everything. And so here's the CEO, latest device, Nokia, 1 billion customers. Can anyone catch the cell phone king? And the answer is yes. Shortly thereafter, Steve and Apple came along with the iPhone. The people who've been beating each other up for 20 years that own the market, they laughed, they scoffed. Who are these people? It doesn't even have a keyboard. It won't last. Any of you sporting a Nokia or flip phone these days? The beauty is, and what's really interesting is the iPhone at the time had pretty much the same internal componentry. But Steve and others said, you know, this device, which keeps growing in power and popularity, there are a lot of other things we could do. And what's interesting today is, I don't know why we keep calling it a smartphone, because the data shows of all the things you do with that device, making and receiving calls is one of the least likely things you're going to do. But I look at this. This is what was happening when I was coming out of the university. AI is happening as you're coming out. What are you going to do to understand and catch this slipstream? Because it's occurring. We're all early in the journey, and we all have the ability to make a difference. So, okay, those are my prepared comments. The only thing I'd say is, if you're out there, if you're wondering, I would just say, no, you've got this. Go out and do great stuff. So how are we doing on time? Oh, okay, so let's just roll that over. And then, Jermaine, can we try that new thing? So here's the thing. I know we've got our trustworthy roving microphone people. So, but the other thing I thought we'd try is this. Could someone, if you've got your smartphone, scan that? And then this should allow you to ask questions or provide comments. So if you scan that, just type something in. Type something like, who's your favorite band or group, just to make sure this is working. Fingers crossed. Well, are you guys, okay. Okay, KB, anyone else? So AC/DC, man, okay. That must be an Ulster in the crowd. So here's the thing. Would love your questions or comments. And if you're an extrovert and you want to use the microphone, then just raise your hand. But okay, but if you don't, I'm an introvert. I would probably never walk up no matter what to a microphone. But if you have any comments or questions, this is totally anonymous. Just put them up there, and would love to engage you in the conversation. So, Khalil, and then
we have a question over here. Aurel, can you give him the mic?
Okay.
Please stand up so everyone can see you.
And then who you are and what you do or where you're from, or just something so we know.
Hey. Okay. So my name is Feris. I'm one of the organizers here. I live in Germany and I'm a software engineer. And I had one question. It's actually a question that always goes in my mind. And when I heard you say AI is not about technology but about empowerment, so I wanted to ask it to you. How would you say that sentence connects to the other sentence, AI is going to take over our jobs?
Well, you know, if you read a lot of the literature, even the professional literature, it sounds like a wonderful future. First it's going to take all of our jobs, and then it's going to enslave us. It's like, wow, that's what I want to lead into. Again, if we had more time, I took some slides out, but I would be willing to bet everyone in this room is some form of a knowledge worker. And so there are certain jobs. I mean, AI adds value in one of two ways. It's the only way across any industry. It either automates the way work is done, which is typically work that is highly repetitive, low variance, not much thinking, or it augments work which is highly varied, lots of variance, requires a lot of knowledge, wisdom, common sense. So when I look at any jobs, I mean, those jobs like manufacturing, there's a reason AI and automation's been in manufacturing for a long time, because you know, there's one thing in an assembly line that's done 1,000 times the same way, and it's got to be done that way, and then it goes to the next step. But anyone else, AI, in my view, is not going to replace anyone anytime soon. It's going to dramatically change the way you work. Maybe it changes the number of people, but I do a lot of work with doctors and nurses, and when you look at anywhere, but here, particularly in America, we have a gross shortage of nurses. Here you've got a gross shortage of physicians and nurses. And so the ability to say, well, what if I can eliminate a lot of the low-value, repetitive activities we force those doctors to go through and free them up to do higher-level things? That's the value proposition, not only for doctors and nurses, but anyone who's a knowledge worker in any industry. So I'd love to talk more about that, but, you know, but that's my view. But here's the thing. That's only my view. If there are people, and I work with a lot of nursing organizations where there are many nurses that are fearful for all those things. And it's like, we can't poo-poo that. We have to meet them where they are. That's an emotional reaction. What we have to do is help them along, which is where we come back to upskilling the workforce, of not making them programmers, but making them understand some of the fundamentals where done right I believe, you know, that you actually gain superpowers if you start leaning into AI, particularly leaning into AI, adopting it before others in your work and what you do will do. But a great question. But it's people will choose to lean in or they'll resist because they don't understand that. Great question. Other
Tom,
questions?
maybe
Yes.
we can take one from here and then
yeah,
get
thank
back
you.
to the audience.
Great. Once again, I don't know how to explain it other than to say, within whatever organization you're working in, you know, is there an effort to say, we want to start educating all of our employees, all of our workers on what this is, how it may impact our industry, our company, our organization, and your work. And again, I was having a conversation with one of the people who did the startup pitch, and there are a lot of things that can be done to start having people lean in, but it's that education up front. So if you're already here, my guess is if you're here, you're already leaning in. But if you know others in what you do that are not, again, this is where it's an emotional base. I can't go, I learned a long time ago, my epiphany was, I can't convince someone who's afraid with my brilliant logic and use cases of AI. So if we understand at a human level that, you know, again, we're all early in the journey and we'll get there, but a lot of it is simple upskilling, simple helping lead people into it. And I believe when I do the boot camps, the main goal I want is people walking in who are fearful or anxious. I want them walking out thinking it's not as hard as I thought, and it seemed like it would be better for me to start leaning in than resisting. When you get people to that point, that's the turning point, and that's where we get away from that. 55% of organizations doing this in healthcare report the number one impediment to value at scale is resistance of their own employees. You had your hand up almost second, so let's make sure we get to you. And then we'll come back to some of this.
Okay, my name is Bumi Akeremi, and I'm from Nigeria. I work as a machine learning engineer. So my work is, I used to work for ad tech, that's advertising, and I'm quite familiar with how we track metrics and all. So you were talking about having a mobile app that can sort of diagnose if you have an eye infection and what the impacts are. And I'm thinking of the implications in the ad tech industry, because why they would not say, oh, we are tracking what disease you have to recommend drugs. We can still get metrics really similar to that and use that in advertising. So I'm concerned a bit because I'm not sure, I'm not comfortable with an organization having access to those apps, right, and using that for advertisement, because it's not, they just say allow tracking. They don't tell you what they track unless you explicitly read. They wouldn't take the results, but they can tell what pages you clicked, what buttons, and then they can infer from those things what ads to suggest. So I'm curious if you are thinking of the impact in terms of monetization, because the whole aim is just to make money. They don't care, really.
Okay, first of all, there's a whole lot to unpack in what you just said. Thank you. I'd quickly summarize. As you were talking, what I'm thinking is there's great upside opportunity, and there's also great responsibility. And so I often have the conversation that I refer to as we need the gas to make this go faster, and we need the guardrails to make sure it goes in the right direction. So what you just said on, you know, the eye movement and other things, a lot of people that in the workplace are worried about, you know, are they going to track me? Are they going to do these things which are not good for me? Which brings us back to what I would call responsible AI. There are a number of things we need to do, including establishing trust. And is anyone going to use any software application that you don't trust? And the way to drive adoption is to establish trust. And how do you establish trust? Well, you have principles, you have guidelines. You typically, the best way to establish trust to me is the very people using these things are helping to drive the deployment, the management, and the monitoring. And I'm hoping, I know we've got some really good experts coming up on the panel that on a lot of work in the area of responsible AI, but you're opening the door to, with all of these great upsides comes great responsibility to do it right, to have people, I mean, the best way to establish trust is those using it are in the loop, they're planning it, they're deploying it, they're monitoring its use. And when you get to the point where they trust it, I mean, to me, that's when the magic starts happening when it comes to that value that you're driving.
Thank you, Tom.
Okay.
We should be moving to the panel. Don't worry, you'll still have time to ask your questions, but please be concise. We're a bit short on time. So joining Tom, I call on stage Dr. Mary-Ann Hartley, more commonly known as Annie Hartley. And she is from Pretoria and working between EPFL and Yale on solutions in underserved healthcare solutions in underserved regions. And joining her and Tom is Greg Barrett, CEO of Cyrus AI, and we'll have an exciting panel on healthcare in general. Please, a round of applause for all our speakers.
You made it. We've never met, by the way, until now, but I was hoping to meet you, and all of a sudden, a couple hours ago, I got a text along with a few others saying, I'm on campus, where is this? And so you must have found it.
It
Greg.
wasn't easy. I've got very, very bad luck with my neighbor in a plane. I won't say what happened, but it was unpleasant. There you go. But it was worth it. Thank you.
Greg, welcome. Nice to meet you.
Yeah, I think we spoke on email when you were...
Yeah, this is totally unstructured, so this will be awesome. So I'm wondering, can we start with each of you just bragging about yourself, starting with you, Annie, what kind of a little bit about what you do? And
Well, I have a reason I want to brag, I want to impress, because I'm always looking for brilliant students coming from my home continent. So my name is Annie, I'm a professor of AI, I'm also a medical doctor, and I lead a lab called LIGHT, which stands for the Laboratory for Intelligent Global Health and Humanitarian Response Technologies. It does exactly what it says on the tin. We are working with humanitarian aid organizations in places that are really underserved and sometimes very volatile and difficult to reach environments and populations. And we're making AI tools specifically adapted to those needs. So from fundamental like AI development to make sure that it is efficient and optimized, to also going all the way to proving that it actually works and going into the field and running clinical trials. So we are based in Switzerland, but also, this is in the Swiss Institute of Technology, but then in 3 other places as well. So in Harvard School of Public Health, because we're quite interdisciplinary, and then in Rwanda with the Ministry of Health, and in India, also with the Ministry of Health. So please, if you're interested, reach out, and very, very always looking for brilliant students coming from my homeland.
Thanks. We're building stuff, quite a lot of stuff. Perhaps too much to go into, but that was sort of the previous session, just touching on some of the stuff we're building, but it's to build up South Africa's strength so that we can be globally relevant, because, you know, speaking about some of the aspects you were talking about in your presentation, a lot of the folks view entrepreneurialism as an avenue because they actually can't find employment, but it's not a solution. It's symptomatic of a problem. If you take someone like Anglo American and take all their contractors, they employ over 100,000 people. That creates employment, and those are the kinds of things we need to start creating in South Africa. We went through a period in South Africa where you had sort of industrialization for various reasons, but those large companies that came, like SAPI, Mondi, Sasol, Anglo American, you know, they employed a substantial amount of people, and to create or solve the country's employment issues going forward, we're going to have to start tackling things at an industrial scale that create opportunities, so when students come out of WITS or out of any university, they've got a pathway, because they can't all create their own business, create their own idea. It's just not possible to be everyone to be the next Steve Jobs creating Apple and all these sort of things. They can be part of a team within an organization that creates products and services. And so we need to understand what our strengths are in South Africa to create competitive products and services, to create industries that are globally relevant, just like the Chinese have been doing. The Chinese are very assertive, very aggressive. You know, they're building vehicle manufacturing plants in South Africa. You know, what are we building in China? Or maybe if not China, somewhere else. And we need to be earning that hard currency to redeploy in the South African context. If you want to affect societal and economic change, you need to start doing quite a lot of things to create the resources to be able to go into communities, to provide healthcare, to provide services. We have a set of needs and wants, which I think goes to the AI discussion you brought up in your presentation, is that fundamentally AI is not going to necessarily change our needs and wants. Like a woman still going to want a Coach or Chanel handbag or something to that effect. Maybe AI will have an impact on how you manufacture that product. Okay, so it's going to be a means to an end, not an end in and of itself. And we need to understand how we can use AI in our context here to make sure we as a country are much more competitive, can generate returns that we can redeploy into low resource environments. So for me, that's our focus of our work, is literally building stuff that creates the stuff that makes the world go round.
You just said 1,000 things, and I'm going to come back to that in a second. So Annie, you know, your journey spans clinical, public, health, and AI. I mean, you've done a lot of things. You got a varied background, but so your background in clinical work, how does that influence the way you actually approach AI?
Well, to maybe build on both of the things that were said just before this, I think the most important thing is that as a doctor, you're a public servant, and you have this real need, it's in your DNA, to serve your patient and to serve the public interest. And we work overtime, and we don't get paid overtime, and we love it. And this kind of need to serve something that's greater than you, this like public health and this concept is embedded in how at least a lot of the people in our group think. And that's why we really feel that really open models as a public good is a really important aspect of how we build tools and what we want to promote. Not everything has to be sold, but it can actually benefit what you were just saying before, that we can have things that are like very strong, booming industries, and we can have jobs and that are created by big corporations. But we also need to have an understanding that AI is knowledge, and knowledge is a public good, and knowledge is medicine, basically. This is what we do as doctors. We give information out. And so I'm interested in the open aspects, and that has changed my way of how I build things because I'm a doctor. Yeah.
Greg, as you were talking earlier, in my mind, I saw this framework starting to emerge that I think you were talking about. And, you know, some of the people I've met over the last 2 days, excited, leaning in, but I think to your point, somehow there has to be a structure that gathers and harvests the best ideas in a framework that actually produces good. And so back to what you were talking about, and particularly with your deep background in med devices, I mean, expand on that, because there are some people who are, you know, in that startup mode, and they are going to go off and create something cool, and then there are others that are really needed to fit into the bigger organizations working on building stuff and deploying stuff. I mean, give us more on your thoughts for you know, if you're in the audience and you're starting out, how do you fold into something that's going to produce some common good that have impact coming out of Africa?
Yeah, I think just to her point earlier is that in the AI context, we talk about artifacts, and those artifacts being available openly to the scientific community for validation. Data sets, models. You know, people also need to realize that NVIDIA, it's actually more of a software company than a hardware company. First of all, NVIDIA don't actually make their own chips. ASML provide the machinery to TSMC, who manufacture the chips. They design it. And if you were to look at AMD, for example, as an alternative NVIDIA, the reason why NVIDIA is usually the go-to is because they've got a much deeper software stack. And their libraries are far more extensive, so you can sort of fire up and go much easier on NVIDIA infrastructure than you can on AMD. But the point is that there's a whole ecosystem to all these things. And if I'm sitting in the US and I want to do a startup, I want to do something new, I can plug into an ecosystem which can support me. In a low resource environment in Africa, you often have to, that ecosystem is deficient or non-existent, and you've got to almost create that entire ecosystem. So that's also an opportunity though. But you just got to know that your challenges are quite different to what you'll find in a developed environment. I mean, you can go to the US or just to North America and you can have a conversation about self-driving labs, which is where you develop battery technology. It's where you develop a whole lot of new technologies. You have a conversation about self-driving labs in Africa and people are, you know, think it's just maybe an automated lab, and that's not really the case. So I think we need to take a step back and contextualize things to properly understand where we're coming from here and what the opportunities present. From a health perspective that we were speaking about earlier, physicians are not scalable, all right? But an AI version of a physician is, okay? And if we look in Africa, there's a desperate need for that. So if we're going to address that need in an African context, you can often land up with something which becomes globally relevant. So in solving your challenges here, you can actually land up with a solution which is, you know, something really powerful. So it's about understanding our challenges here, forming solutions to them. And that's what I think South Africans have been pretty good at over the years. And in fact, those industries we spoke about being created some time ago, because of the apartheid era when South Africa was locked out of the global community, you had to become self-reliant. And so you created Sasol to get fuel from coal, for example. And you sort of got to take that mindset again and look inwardly in Africa to say, what have we got that we can build upon? We have to take an ecosystem approach and you can build it all up and you can land up with something which is really pretty strong. But it takes an holistic focus. You really got to connect dots. And I don't think many people are good at the big picture thinking, but it needs to happen. And it needs to happen, you know, so Africa's got all these like master plans, as they call them. And the interesting point is that their master plans are now being, AI is having a big influence in drafting those master plans. So they're using ChatGPT and a bunch of stuff, and you can see the master plans are actually a lot better than they used to be. But the point is, you need to actually bring AI into all these contexts, not just from creating these master plans, but also if we're going to deploy some new technology in the country to do something, AI needs to be inherently part of that process in terms of automating or making it state of the art so it becomes far more efficient and effective because you're competing globally. You've got to anticipate what the Germans or the Chinese or someone else would do. Can they do something more efficiently and more effectively? And you've got to take a mindset whereby we've got to create a sustainable approach. Now, I come from Northwestern University in the US, and I was just seeing the other day, their Simpson Query Biological Center does $1 billion a year in revenue. It's got 4,000 faculty. It's because they're producing real-world outputs. They get that $1 billion in every year, which they use 100% of it for research. And it's like, because they've got a sustainable model. I remember the discussions that have happened here recently, like particularly last year when the US cut a lot of funding to the institutions here. And then they were like, oh, shock and horror. And it's like, but we've been telling them for years that you've got to create a sustainable model to generate real world outputs to get that revenue in, because eventually the grant funding will dry up. And so I think a conversation needs to be had for AI, but in a much broader context. And it needs to encompass people just understanding that there are a lot of challenges out there, and some things are much more viable than others.
Right.
So it's
as you're talking, again, a lot to unpack, but I mean, this is where I often look at people falling in love with the technology, and I think to some of your point is, you know, the technology doesn't matter. You have to be able to eventually demonstrate measurable value at scale against something that you or your customers or the government or the organization cares about. And it's amazing to me how many people chase after that shiny object of AI and they fail because of everything you just said. It's like, it's great IP, look how cool it is. It's like, well, how's it doing something I care about? How do I measure it? And how does it have impact against whether it's shareholder value or whether it's serving the mission of improving the health status of a population of people, which brings me back to what you do, Annie. So for some reason, when this lady asked the question and I was thinking about responsible AI and trust, I flashed to thinking about some of what I understand you do. I love your thoughts on the framing of what responsible AI looks like and how that needs to play out, particularly in health and medicine.
Yeah, so responsible AI for me is actually just knowing that it actually works. When people are saying that it has impact, prove it. Prove it. Just prove it. It's not that hard. And this is what we actually have to do. We have to go from AI evangelism to AI evidence. It's obvious. And we have to there's this huge risk of all of these, AI medical quacks coming out. And everyone in their granny has got some app that's got 10,000 parameters that looks at your eye and then it tells you your mood and all this stuff. And it's coming out. And actually governments don't know what to do. So when you speak about responsible AI, it's often a policy kind of framework. And then we're working with a few governments in India, in Rwanda and others, and they're getting inundated with these quacks that are coming in and saying, I've got the best AI tool and I can give you X, Y, Z. And there's all of these kind of exchanges under the table trying to happen to get their startup idea first. And they have no way to actually challenge them and say, prove it. And so this is what we're doing in our lab. It's one of our bigger projects. It's called MOVE. And it's been going on for now 2 years, and it's really gaining a lot of traction, and we're rolling it out across India as well, Rwanda and a few other places, where it stands for, it actually also does what it says, MOVE. It's it moves models into its context, right? Into where it's supposed to have action. And it stands for massive, because it has to be big, open online validation and evaluation. So that we're trying to actually give the tools to people who are using them, collect evidence that it actually works. And when it doesn't work, we don't go, whoops. We actually use that and feed it back into the model to make it continually better and to move it into the context in a way that makes sure that the evidence is behind it and it's fueled by evidence and it's continually learning. So I think responsible AI in healthcare is a continuously learning AI, an AI that we know that we cannot accept that it's going to be good when we're starting. I think that's really important. And last thing, I keep on hearing this resource limited setting. It sounds like such a Debbie Downer all the time, going, we're trying our best, we're resource limited. And for me, it's completely the opposite. I am so excited. I would never want to work anywhere else but in a resource limited setting. Why did DeepSeek come out? Why was it so amazing? It's because they were forced to work under constraints and they made something extremely efficient. And this is this is our asset. Our asset is that we're not messing around. We're not wasting resources. We own efficiency. We own optimization. If you're a doctor here, you own creativity because you can't work like a normal doctor. I love seeing doctors coming from other countries and trying to work here and then just seeing how they do. We know stuff differently and we own that here, and it's a power. Like resource limitation is a power because it forces you into a certain path of optimization. And we own impact because you can go and put the best tool in like a Swiss hospital. And you know what you get? I don't care because it's boring. Maybe 15 seconds of someone's time spent, that's saved. Here we can actually save lives and make an absolutely enormous impact that shifts everything. And I just think that that's so powerful, and it's something that we need to enjoy, Yeah.
And I think that also calls attention to how Africa is unique in many ways. And my thing about it's okay to be different and not be afraid of solving hard problems. And I love the DeepSeek because it makes me think about, somewhere in Africa, there's a group of people that are capable of doing the same thing, just what you said. Here are our challenges. Here's the uniqueness. The smartest people to know how to solve for the uniqueness are the very people in that situation. And it doesn't have to look like any other country's solution, in my view. So Greg, I've done my homework on you. You've got an exceptionally deep background on med devices across many forms. And I've got several questions on that, but I'm curious, when I look at the intersection right now on wearables and AI, what are your thoughts on what's happening there? Is there anything you're particularly interested in or particularly wary of?
Yeah, I think it goes back to what Annie was saying.
I don't mean to interrupt, but just this will be our last question, and then we'll move to the Q&A.
Perfect. Thank you.
So it goes back to what Annie was saying. You need to build benchmarks to validate stuff, and that's a problem in the wearables industry. Like blood pressure monitoring is a major issue at the moment because the devices need to be calibrated. So we've a doctor once a few weeks ago just told me about a situation whereby this one patient of his now has on his health record with his health insurer that he's got this particular condition, and he doesn't actually have this condition because the wearable spat out a whole lot of nonsense, and it's given him, it's basically said that he's got a heart condition. All right, he doesn't actually have a heart condition. It's the wearable has not been calibrated properly. But now he's got that against his health record for his life insurance, and that's an issue getting it out of there. So I think one has to, going back to what you said, you've got to benchmark the stuff. It can't be a black box. And it's not rocket science. We had data science, then it sort of morphed into machine learning, and then it became this whole AI bandwagon. In data science, you have a training set, a validation set, and a test set. And that also applies to machine learning, and you tend to want to make that openly available to the scientific community, so not only they can reproduce stuff, but they can validate it and check it and make sure it works. And the FDA and others are currently grappling with this, because when it comes to stuff, the ordering, wanting certification with the FDA and stuff, it's like, okay, well, those sensors, they work under certain circumstances and don't work under others. We need to be able to calibrate these things, and we need to be able to benchmark them and validate that they work. So there's a lot of opportunity in developing wearables, and you need to do so because for precision medicine you need to be able to measure various biomarkers on a very frequent basis to inform dosage and all sorts of things. And that's all within reach. But you've got to do it in a very scientific manner, if I can put it that way. There's a lot of people that will just throw a lot of spaghetti against the wall and see what sticks. And that's sort of what's going on. The regulators are struggling to catch up because they're getting swamped with all these applications to say it does this, that, and the next thing, and they don't necessarily have the right approach yet to how to properly confirm that. And so I think benchmarking is becoming really important from a health perspective for regulators to actually give consumers the confidence that these devices and all the data that's coming there from is actually valid and actually can be utilized. So, but I think it's a huge opportunity for us to actually bring machine learning into the various stack and actually derive a lot of value from that in a lot of different contexts. So what we're talking about in the previous session is Africa may not have a whole lot of GDP per capita, but we have a lot of data potential per capita. If we can unlock that data, we can then start to create new pathways here at WITS and others to do drug development, accelerated drug development. Because soon you will have the computing infrastructure, now you're going to have the data infrastructure. You've got the population to generate the data, you've got to feed that into drug development, and then you can actually develop those drugs here in Africa as well because pharmaceutical ingredients. So you put all these pieces together and you've got something really compelling. Anyway, so
and guys, it's the coolest place to work is that benchmarking space. That place where you're going and like putting in the real world stuff. I think like that space is like it takes all of the interest and creativity to actually see it work in the real world.
I see a lot of people getting ready to raise their hand, and we're also back to this. Why don't we start with the bottom? With over 40% of Africa lacking internet access, technological advances often deepen the digital divide. How can we prevent AI from doing the same? Wow, anonymous, great question. One of you want to start?
Sure. I just think that first of all, we need to make sure that we don't have vendor lock-in. You just saw that Gates Foundation, for instance, has funded a $50 million investment in OpenAI, basically. And this is great for access, but it might be short-sighted where we are then locked into this in the future. And so we want to make sure that to really have access, we need to make sure that we make value, right? We prove the value. Again, it comes back to evidence. If you can show that having access to an AI tool can save lives at scale, governments are going to be very incentivized to expand internet access, for example. And so if you have got evidence that something works and has a massive impact, you will incentivize people to expand access to it. We just have to make sure that that access is accessible in the long term and that it can be owned by us as well, locally. We're not reliant on
And I'd pile onto that because back to what I call responsible AI. The question is, AI in Africa, will it be done to benefit some citizens or all citizens? And it's a really important question when it comes to that thing of, if it's going to benefit all citizens, you know, that's an issue of not only how we develop technology, it's about legislation, regulation, and policy making. And it starts with that to say, as we do this, are we going to work to bring everyone along to benefit, or is it just going to benefit some? And that plays out in many ways. And then the only other follow-up to what you were saying earlier about responsible AI is we're seeing it, and unfortunately it's in the clinical literature, where AI in many countries can be totally legal, totally regulatory compliant, but still very unethical in terms of being very biased and benefiting some populations versus others. And we can go deeper on that, but these are all the things that as we talk about stepping on the gas, we have to have very honest conversations about the guardrails we choose to place that eventually means it's going to benefit some citizens or all citizens.
And just when we're talking about benefit, it's not just about the outcome of the model being correct. In other words, equitable accuracy being spread around. But it's also about like the ownership of the tool. If you are investing everything into one company, it'll be an issue, right? We need to own the value of these tools ourselves as well, and that's why open resources are important.
Okay, I just got the 5-minute signal, so we're going to all talk fast. Yes.
Okay, so I did put my question up here. You spoke about the ecosystem earlier and building that ecosystem. That's exactly what we're trying to do at New Global AI. In your professional opinion and with your experience, what would you consider to be very important or crucial to have in an ecosystem like that?
Well, first of all, I think that one question at the bottom there, just about the connectivity is an issue. We've actually been working with the ITU for Partner to Connect to actually bring connectivity to communities who don't have it, but actually being able to subsidize it so we don't have any dependencies. Then there's also, like you would have noticed, Vodacom and others. There's an eye effort because everyone, you buy data in South Africa and after a while your data expires. It's completely brain dead. So it's costly, though, to take the government to court to get rules to change, but in the future we're hoping to have more resources to pursue those kind of activities because, I mean, the connectivity in Africa is just a complete joke. But there are plans to actually address that because, first, you do have to have connectivity, otherwise you're not going to really be part of the AI world. Yes, we are putting models that are small enough to run on embedded devices, your cell phones, etc. But, you know, at some point in time, you do have to have the connection beyond that local device. So connectivity, top of mind, working with Starlink, for example, who now has S-band, which means you're on cellular wave as well. So it's becoming more and more difficult for those roadblocks to connectivity to remain in place. And it's become much more difficult for governments to also to engage in subversive practices like the Iranians and Uganda shutting down the internet. So connectivity is really important. It's part of the ecosystem and it's an enabler. But it's really about, like I said, mobilizing data around that and getting people part of that data ecosystem, which is so critical to the functioning of AI. But the area is very deficient because you do also, and this was spoken at Davos recently, AI computing infrastructure, and not just computing, but you must remember when you've got like an accelerated high-performance computing platform, it's all the engineering around there that supports it. It's not like you have a workload, you send it and click run, and it runs, and then you just get an output. There is a huge amount of engineering that sits around that. And those ecosystems, like you have the national labs in the US, Oak Ridge, Livermore, etc., that's a fully functioning ecosystem that you don't have in Africa, which is problematic when you need to do things like climate modeling, for example, which can be really intensive, or accelerated materials discovery, and all those kinds of things, which here in South Africa, like you can go up just a little walk up the way here, and some of the best material scientists in that came out of this institution. They're now in the US working at those national labs. So we don't want that, we don't want to go downhill here, all right? We don't want to hit the ground. What we want to do is we want to turn around that trajectory. So we just need to basically build on our strengths and remobilize, but in the modern era. So we've got to bring all the AI stack and architecture, the hardware, the engineering, and bring that to bear on all this work that we've been doing for decades and be really good at. But now that's languishing. But it can be done. It just needs to be a rebalancing of investment. We've got to understand what's the strategic investment that can yield return over the decades to come, and what's just going to be a handout which people are going to reinvent the wheel, and it's not going to be sustainable because some big tech firm in the US will be able to pancake it in a few years.
So we just have one last quick question and then closing remarks from you, please.
Thank you very much, great panel. It's actually not a straight question, but a comment about talking about 40% of Africans do not have internet. I think it's a little bit more complex than that. If you take a data that was published by the GSMA, it talks about roughly 86% of African, at least in Sub-Saharan Africa, that have access to at least 3G, but only 26% of Africans are using the internet, right? And therefore, there are many challenges in terms of relevant local content, right, skills, knowing how to use the technology, and so on and so forth. But when we look at AI, the other perspective that I believe that is very important is that you can't talk about AI without the digital infrastructure. That's what one of the panelists was talking about in terms of digital infrastructure, compute infrastructure, the data, and so on and so forth. But also in terms of policy and regulation is also tap into existing policy and regulations. And so I think there are all of those elements that need to look at from a holistic perspective, to look at how do we have locally relevant AI use cases as the moderator was talking about, to make something useful for the African continent. Thank you.
Tom, I think you should be closing.
All right, I was waiting for you. So look, some of us will stick around. I know several had their hands raised if you still want to talk. And two, I mean, it's always interesting. I learned so much just by listening to you and our panelists. But and the last person that just spoke, I was like, there are some things unique about Africa. There are some things that right now are hard. But again, we're early in the journey, and I have confidence that if we gather 2 years from now, we'll be much farther along. And it's like, have confidence. Think differently, because such great opportunity here to not only do good, but to do well. And I'm confident that over time you're going to solve some of these challenges. And the only other thing is, I know there's a session that someone's doing tomorrow that specifically is trying to address things like some of the infrastructure, the low power, and it's like, how do you start having those conversations? How do you do basically Africa's version of DeepSeek to say, here are our issues, here's how we're going to make progress? And the smartest people are not anywhere else other than in this room and on this continent. You will figure it out, and that's where my final salutation is like, go out and do great things. I'm confident you will do that. But we'll stick around. Thanks a lot.
Thank you, Annie, Greg, and Tom, for the insightful discussions. Thank you to all our speakers, and thank you for being here. With that, we are closing our day 2. We're halfway through the conference, and we have a feedback form for you, if you can kindly fill it in. It's with your feedback that we keep getting better, and hopefully tomorrow and after tomorrow we run smoothly. Thank you again for being here. And one last thing, we'll also remind you that we have a challenge on LinkedIn to win 2 Oppo phones, so we'll put that slide in as well, and make sure to participate. Thank you all.
I've worked with some big med device companies. I've got some theories about med device people, but
look, Department, I'm meeting with IMEC on Thursday. I'm sure you know IMEC. We're not going to make nano electronics here in South Africa. It's not feasible actually for diagnostics. There's much better options. We'll make the laser-induced graphene in South Africa, for example, hundreds of millions of units a year, biosensors. But we'll move away from silicon-based versions of biosensors.
I spent a couple of years at GE, and the challenge was always taking devices and trying to put them in places like China where the water, when you don't plan for the criteria you're going into in other countries, it screws things up. Anyway. How you doing? Good. I've seen several of your posts. I've already liked them. Thanks for connecting.
I really appreciate it.
It was fun. We learned from each other.
Indeed we do. In fact, I've been trying to get your attention the entire time since you had your basically like a year title to ask you a question.
They look at them, I realized I wasn't looking at anyone on that side.
So it didn't help. But nonetheless, so I was specifically thinking about induction versus deduction and how phenomenal AI is at deduction. You know, taking data and producing patterns, and how compared to humans, they're not as good as we are with deduction. Whereas it comes to the point that it can give us the information, but it does not know exactly what it should do with it yet. When will AI be bridging that gap?
Great question.
Or would it ever be able to bridge
Well,
that gap?
and that's where I took a bunch of slides out because of the time constraints.
Yeah.
But a follow-up to that, how AI adds value is understanding what it's good at and what it's not good at, which I think addresses your question. So right now, AI is better than humans at many other things like pattern recognition, going through massive amounts of data. But humans are uniquely qualified with the other things we're referring to, like wisdom, common sense, experience. And this is where AI is starting to mimic some of that, but
it doesn't
get it right. And in my boot camps, I teach that module, and then I always put up what I call a spurious correlation. I had one in about South Africa where I can show that with a simple AI tool and data aggregation, it shows there's a perfect correlation between hydropower energy generated in South Africa correlating almost perfectly with the number of pirate attacks globally.
Interesting.
But the point is, I make things like that, and I've got the data to prove it, to show, I can do a lot of things on correlations, including some things that look very realistic. That one isn't. Like with the wisdom of the clinician, when AI makes a recommendation on this treatment, they can look at it with their wisdom and their judgment and common sense and say, that doesn't make sense. And I don't think we're going to see that. I think there's always going to be the unique qualities of a knowledge. And we'll get better and better with AI, but
you don't see it bridging that gap anytime soon.
Well, people keep talking about eventually it's going to replace doctors. It's like, even if it can do that, I want to meet with a human. I want that empathy.
Yes.
Anyway, it's a great question. I don't think knowledge workers have anything to worry about for now. And maybe 20 years from now, maybe 10, I don't know.
I mean, we're still waiting for flying cars, so. And we were told that drivers would be obsolete at some point.
I choose to believe we're always going to have things that are unique.
We will.
Maybe that's self-preservation.
It's beautiful because it's profound in its truth. Are you going to be at the rooftop tonight?
At the what?
At the rooftop.
I don't know. Is there another gathering?
I'm finding out too.
I don't know. I haven't heard about that. But if there is, I probably will be.
Oh.
Okay, maybe I'll see you.
Look forward to seeing
I should bring you my bottle of Monkey 47 in case I can't. If nothing else, if you're a gin drinker, you have to try it.
I'd love to. I'd love gin.
Hi. I'm Tom here. Kamagala?
Yes.
Okay.
I'm a student here in information systems. I want to ask you, you were around our age, maybe a bit older, during the rise of phones.
Sorry,
when phones took over, or not took over, but became more popular and the technology started to develop, right, along with computers. What would you change about your approach, knowing what you know now? How would you change your approach to the technology back then? And how you reacted to that development?
Well, I try to make the point to say people think that, we've got things figured out with AI. Just